Merhaba arkadaşlar. Hello everyone. So I'm just gonna remove this background. One sec. Okay. Welcome everyone. Welcome to the 6th version of DevOpsDays Istanbul and Ankara. So we are a joint conference for this year as well. Because we are doing this online, so we decided to do it together. So I'm gonna make a quick opening and share some important details with you. And I will do it in English, but if you have somehow any questions, feel free to join our Discord channel and ask your questions. If you have any difficulties, it will be live streamed on YouTube and looks like it's working fine. But if you have somehow any difficulties, just please reach out to us. And I will say this in Turkish, just about for the Discord announcement. Merhaba arkadaşlar, hoş geldiniz. Girişi İngilizce yapacağım. Bütün konuşmacılarımız neredeyse bugün İngilizce. Konuşmalarımız İngilizce. Eğer bir sorunuz olursa, herhangi bir teknik probleminiz olursa, sorularınızı da aynı şekilde konuşmacılara olan sorularınızı da sorabileceğiniz bir Discord kanalımız var. Oraya katılmanızı bekliyoruz. Orada güzel konuşmalar döneceğini de umuyoruz. Oradan Türkçe olarak da sorabilirsiniz. Biz buradan konuşmacılara soruları en sonunda İngilizce olarak soracağız. Problem yok. İstediğiniz şekilde katılım sağlayabilirsiniz. Bunu söylemek istedim. Şimdi İngilizce devam edeceğim izninizle. Okay, let's continue in English. So first, it's important that we all follow our code of conduct. We have a code of conduct. So I'm going to read this once. And if you have any questions, if you want to report a violation, please reach out to us on DevOpsTurkey@gmail.com, or you can send DevOpsTR a message on Discord. So all attendees, speakers, sponsors, and volunteers at DevOpsDays Turkey Istanbul 2021 are required to agree with our code of conduct. Our conference is dedicated to providing a harassment-free conference experience for everyone, regardless of gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, ethnicity, religion, or lack of technology choices. We do not tolerate harassment of conference participants in any form. We are expecting cooperation from all participants to help ensure a safe environment for everybody. Again, you can also read it on the official DevOpsDays.org website. And if you have any questions, please feel free to, if you want to report something, please feel free to reach out to us. Thank you for your cooperation. And so, what is DevOpsDays? This is the 6th version of DevOpsDays Istanbul. We are doing this for a while as a team, and we are excited to be with you again this year. Unfortunately, as you know, due to COVID, we are doing this online again. But next year, we are optimistic about going back to an in-person conference. So we are making preparations, and hopefully, in the following years, we are going to be together again. So what is DevOpsDays? DevOpsDays has been happening for almost 12 years now. So it's where the DevOps word comes from. So, and today we are hosting people like Nicolas, Shafer, or Patrick Debois, or Kris. These people were there from the beginning, and we will hear from them today. So we are really excited to have them. And DevOpsDays are happening in more than 80 cities all around the world, and they are community-driven organizations. We are doing this for the community, and we don't right now. For example, we don't have any sponsors because it's an online event. But next year we will also be looking for sponsorship. So because we are getting a lot of questions about that. So if you have been to DevOpsDays before, you probably are familiar with its unique schedule, but because we are doing this online again, we are lacking some, let's say, sense of collaboration. Usually DevOpsDays events are group chats, like what we call open spaces. Open spaces, but we are unfortunately missing that. So hopefully we can make it up with Discord. So if you have questions, please join Discord and ask them, or chat with other attendees. So let me share our online format. So we have regular presentations. They are 25-minute long. They are from our great speakers. They're practitioners and leaders in the DevOps space. And we have panel discussions. First one will be with DevOps leaders, and the second one will be, actually this time we are making a different choice, and we are bringing the DevOps part of DevOpsDays Istanbul team together and discussing a topic on DevOps in a remote world. So if you want to see our chat or our chat with DevOps leaders, you can also join our panels. It will be live streamed afternoon. And we have obviously conversations on Discord, as I mentioned repeatedly. So you can either take a screenshot if you want to, or you can see the link below the YouTube channel, YouTube live stream in the description part, and you can easily join our Discord. And obviously, thank you to our organizers and supporters. We are co-organizing this event with DevOps Turkey team and Cloud and Serverless Turkey team. And DevNode community and Java user group, they have been our supporters from the beginning. And this year, they're also supporting us. So thank you for their support. And let me share, just, go over the program fast. So after this opening, and it's about the end, we will have Andrew Shafer. We are really excited to have him. I think this is the third time. We had Andrew 2 times before in person in Istanbul, and hopefully in the following years we will have him again. But this year it will be online. We are excited to have Andrew again. And then we will have Jason Yee, and he's going to be talking about the adjacent possible evaluation, innovation, and catastrophe. And then we will have a break, and then Çağdaş will give his talk. This talk will be in Turkish, by the way. And then we will have Nicolas Fränkel just before the lunch break. And then afternoon, we will have Rosemary Wang with secrets management talk, and Josh Armitage with lean product development through SLOs. And then after that, we will have our last talk with Laura Santamaria, engineering the cloud infrastructure as code. Then we will have a short break again, and then we will have the panel discussions. With our first panel discussion will be with Patrick Debois, Kris Buytaert, and Bernd Erk. And we will discuss a general, let's say we have a set of topics, and we will ask them and discuss them. And it will be, the title is DevOps, DevSecOps, and how things are changing after 12 years. And then we will have our discussion with DevOpsDays Organizing Team, and it will be in Turkish, by the way. And our topic is about how DevOps change, how remote change DevOps, and how is our industry going. And we will discuss different topics. And obviously, we want your participation. So if you have questions, please feel free to ask them during the panel discussions, and we will try to redirect them and discuss them. And then we will have our closing. So it will be a long day with amazing speakers, with amazing talks and discussions. Obviously, this conference wouldn't have happened without their support. Thank you in advance for our awesome speakers' talks. They spend their time on Saturday to be with us. So thank you. And one last important announcement. So we are actively looking for organizers, both for DevOps Turkey meetup, our regular, usually bi-weekly events, and also this conference, DevOpsDays Istanbul, next year. So if you are interested in becoming an organizer, joining our team, we will be sharing this link in our Discord and in the YouTube comments and description as well. But if you want to, you can take a screenshot. So we need help for different areas. So if you can help us in any way, please reach out to us, and we are happy to discuss. And again, we will be expanding our team. We need design support, we need social media support, we need speaker communications, sponsorship, meetup events. We need help with different things. And it's a community-driven event with people from different organizations. It's fun to work with. And next year it will be hopefully in person, so we will need more help. So again, if you are interested in becoming an organizer and joining our team, please reach out to us through this form, and we will be contacting with you in the next few weeks. Thank you very much. Last word, thank you all for joining us today in this early time in the morning. If you have any questions, again, you can join our Discord and ask us. You can see the details on our official website, DevOpsDays.Istanbul. Or if you want to send a tweet, that would be great, by the way. We would be happy to retweet. Or if you want to share your thoughts or moments on LinkedIn or Twitter, again, please use DevOpsDays Ist hashtag, and we will be following and, again, sharing your enthusiasm there. So thank you for being with us today. And we will be with you in about 5 minutes with Andrew's talk. Hello again. So Andrew is here with us. So I'm adding you to this live stream, Andrew, right now. Hi, Andrew. How are you? So you are muted. Sorry, 1 second. Let me mute you. Okay, I fixed it. Welcome. How are you?
Marhaba. I am, it's an interesting time to be alive. Haven't left my house very much for the last almost 2 years. So
hopefully it will be for Istanbul next. not for Istanbul. Hopefully you leave earlier, but
I would love to come and eat your food and see your city again.
I mean, we are always happy to have you. And we feel your support, by the way. Thank you very much. I mean, you've been with us for twice, and you are with us today again online. So thank you very much for your support. It means a lot for us. At this point, I guess I can add your screen to live stream, and I will remove myself. And if you have any questions, folks, feel free to ask on Discord, and we will ask them, Andrew, at the end of the live stream. All right.
I think what I'll do, I'll probably speak for. You said all the talks are 25 minutes, but I think mine's.
You have a lot more time, but
I don't know if you're unlucky or lucky to hear me speak for an hour. But I'll try to give us like 15, 20 minutes at the end, and we can jump on Discord and maybe have a dialogue with whoever else wants to ask questions.
Debois. Okay, I will remove it. Nice.
So I guess we're gonna do this. And Serhat said that this is people giving up their Saturday. It's actually still Friday here. It's 11 p.m. on a Friday, so we're just gonna have a little party and go with it. So there's lots of idioms, and I love studying languages. So this is one that might be familiar to some of the people in the audience. I'm not gonna try to say this, but I think it has an interesting meaning that's related to what we're about to do. And I also, and I say this quite frequently, and I haven't made much progress on Turkish during the pandemic, but I did make some progress on my Arabic. So I'm slowly making progress, and maybe there's a chance to come and make progress in person at some point. But right now, I'm going to speak English, and hopefully that makes some sense by the end of it. I've shared similar slides to these with you before. The last time I came to visit, I didn't work for Red Hat, but just my background, I've been involved in a lot of open source infrastructure automation projects, going back to Puppet over the first commits in Puppet were like 2004. Spent some time on OpenStack, Cloud Foundry, Kubernetes, and then in parallel, what was one of the early people talking about these topics, wrote a book for O'Reilly, was organizing DevOpsDays and being part of it. And then Red Hat gave me an opportunity to do some really interesting work with their customers that's related to some of the stuff I'm going to share with you today. And just to kind of put a fine point, and I believe I've already shared this in my previous ones, but this is my personal logo and my Twitter handle, which is critical. And this is a picture very nearby my house, which is sort of, I live in the desert with these big cactus, which I think are beautiful. And I just wanted to share this is my peak pandemic beard and hair. And that was shaved all the way off, and we're almost back to the beard, but not quite the hair. And again, I shared this before, but I come in all these configurations of hair and beard. So I might show up in Istanbul in any one of these in the future. So I'm gonna introduce a little bit my team, just because some of the ideas I'm sharing today are really influenced by, I mean, these people influence a lot of other DevOps things, but I think we're doing some interesting stuff, and I'm going to introduce some language that came from some of my coworkers. So we've been involved in this, and you may or may not know some of these books and some of these people, but Kevin Bear's part of my team. He was a co-author of the Phoenix Project. John Willis was a co-author of the DevOps Handbook. And then Jabe, he often introduced himself as the least famous member of our team, but he might be the smartest one. And he's working on a PhD at Carnegie Mellon, studying how organizations change their behavior, designing how organizations change their behavior to take advantage of new technology. And some of the language I'm going to introduce today, I got from Jabe, and I've basically, and I'll show you, and then you can do this too, but I've sort of reimagined DevOps through the lens of Jabe's language. Do you want to say hi and then go to bed? My 9-year-old who should be in bed. Go back and put yourself in bed. Thank you.
Look, he's not sharing.
Okay, but I'm talking to people in Istanbul and Ankara, so you want to say hi to them?
No.
Okay, then go to bed. So with that, I just want to keep going. So we live in these interesting times. I mean, I know a lot changed in the last 2 years, where things that were just hard rules for a lot of organizations with respect to remote and respect to the way work would be done, in the matter of weeks, there was this global change in what was possible. And I think that's fascinating to study. Maybe not the most fun thing we all have to experience, but it's definitely an interesting time to be working on these things. It's interesting before, but it's definitely been an intense 2 years. And in this framing, I think it's fair to say, and people often say this, the change is inevitable. But one of the things that you're faced with as you do this work is that the change is not always, it doesn't work out exactly how you want. And I'm going to come back to that point a few ways. So I think there's lots of people that have made a lot of progress, and everyone still wants to make more progress. But there's also like all these other words, right? And they're all related, and they're all sort of different, and some of them have connections to each other, and some of them don't. But I think that there's this tendency to put a little too much faith in the words or the magic of the new words, and not enough in kind of like doing the work to take advantage of the new thing. Although here's a little trick, a little secret. When there's a new buzzword, it gives you an opportunity. I learned this trick by watching other people exploit it. It gives you an opportunity to get funding in your organization for the new initiative, so that you can go do stuff. So if your DevOps initiative's already failing, then you can find a new buzzword and get more money and go do new things. So maybe that will help. I often do this next bit in kind of like a tongue-in-cheek joke sort of presentation, but I think, and I believe I did this type of thing in Istanbul before. So people say they want DevOps, but what they really want is all these other things, right? So scalability, availability, reliability, observability, profitability, throw in some other ilities. They want it all for free and without changing anything. And that's sort of where this gets hard, right? And this is that resistance to change. So just making it really big to make the point really clear. People want all these things without changing anything. So this is a problem, a difficult problem. And like I said, or I'm sure some of you experienced this, the change is inevitable. The resistance to the change might be more inevitable than the change. And in the topics we're talking about in DevOps and some of these other things as well, when you're talking about organizational change, it's hard because you can't really just do it by yourself. You can study, you can get some skills, you can get some ideas, but if you come to work tomorrow with all those skills and all those ideas, your organization can't all of a sudden do DevOps just because you have those skills, because all the rest of that machinery, all the rest of those individuals kind of pin what's possible in place. So this is another, I mean, I've used variations of these slides going back to the very beginning, even before I started calling this stuff DevOps, and it's sort of this wall of confusion argument. So you have this traditional IT, there's a wall between the two parties, and we don't communicate with each other as humans. We just send tickets back and forth, and that makes people unhappy or maybe even mischievous. This is classic DevOpsDays style arguments. And this is kind of like the introduction to some of the ideas I got from Jabe. So these are really two different games. So that wall of confusion that separates both sides is the division between two different games. And I'm not going to make this metaphor today, but in other contexts, I've compared it to sometimes people say, football, and if you're in the United States of America, that might mean a different game than say football in Europe or Turkey. So these different games have words, and so this is right from Jabe's research, and I'm going to introduce some of this language, and it's going to start as this abstract, almost academic, or actually totally academic idea, and then I'm going to hopefully make it more and more concrete by the end, and then we'll close it out and hopefully have a good discussion. So this is what I'll usually refer to as the core conflict of DevOps, and it's essentially the language here is the tension between innovation and efficiency. And we're not really even talking about dev and ops or even IT. This is just inherent in any kind of process. So if you're doing manufacturing, if you're doing really anything, you have this tension between making things more innovative, making things have more variation, more variety, more novelty, and making things more consistent. So I'm going to argue that, and this is an oversimplified version of this, this is the simplified thing between developers maybe creating more value and operators kind of creating more consistency, driving down cost, creating efficiency. This plays out at the organizational level as well. So you see this common tension, this common conflict develop in a lot of organizations between the business units who have that innovation game they're trying to win, trying to get more customers, trying to enter new markets, trying to do things differently. And then you have this sort of IT operations who's trying to control consumption and reduce the variation and get everything to be very repeatable. And so this is kind of again, like I said, it's going to be a bit academic for a minute, but differentiation economy is all about innovation, speed, going fast, getting that feedback from customers, creating new things, creating opportunities to disrupt, and experimenting in this fail fast, continuous way, so that whatever is possible, you get to explore it and really target those things that are creating opportunities. We'll come back to the implications of optimizing only for this game in a minute. Then you have the other side of this. This is, and this isn't necessarily scale when you think about making things big, but it's just the language that comes from this research. So it's about reducing variability and creating efficiencies by consolidating and getting the kind of very, very consistent, reliable process to do things over and over and over. And we're really going to be talking mostly about IT and sort of software development here, but this tension really also exists in all these other processes like manufacturing, for example. So this is that divide between scale and differentiation, which I'm going to argue is this core conflict that exists between developers and operations, and always has, and probably to some extent always will. So this wall, this confusion that's between these two different games results because the players on both sides, the players in these games, don't really understand the other game in a lot of cases. And in the worst cases, they don't understand that these things are connected, right? And this especially happens, I think, as organizations get big enough that they don't really see, that the individuals don't see the kind of connection to the value they're creating for the organization. And so it allows everyone to kind of optimize their flow and their focus for the game that they're trying to win locally, and not see how it impacts all the rest of the other pieces. So is there a way to win both of these games, to win innovation and efficiency simultaneously? I believe we can. I believe there are examples, and I'm going to share some of those. And like I said, it's going to start academic and then hopefully get more concrete. We need to play a new game. And I think there's some examples of this, but I'm going to go with some of Jabe's language, and we're going to talk about the scope economy. So the scope economy is this middle ground, this sort of shared platform in the middle where you have common resources that are shared. Siri decided to wake up for some reason. And there's a core concept I'm going to introduce in a minute about how these emerge, but it's really about negotiated shared value that allows you to have the kind of connection between both sides, right? And this is also where sort of the observability and tractability of all of these pieces kind of center through this middle scope platform. So the scope economy really acts as a balancing point that connects the other two games and enables you to have both innovation and efficiency. So right now, I know it's like super high level academic, but we're gonna go down. We're gonna drill down. So the scope economy emerges from the ongoing negotiation between selfish interests in favor of the collective interest. And I just really love this language. I fell in love with this language, and I will argue that DevOps, if you go back to the very beginning and kind of revisit what are standout examples, people get sort of focused on tools, or they get focused on culture. Both those things are important, but I'll make the assertion that the most impressive outcomes come when this happens, when the selfish interests in an organization are resolving their selfish interests in favor of their collective interests. They're removing the wall of confusion by building a shared understanding of the games on both sides and how the games that we play on one side impact the game that's being played on the other side. So just kind of thinking through this as an example, and we'll stay abstract and then we'll get more concrete. If you optimize just for differentiation and innovation, and you let every development team do everything they want, so every development team or every developer maybe even has full autonomy, so they can do whatever they want. Well, what happens is you end up with a different way to do pipelines, a different object model, a different data service, a different everything for every single thing, because they're all making those choices as they innovate to create the thing they want to create. But that's going to inevitably create an inordinate amount of downstream operational burden. So you've optimized for that innovation, but some of those things might be more valuable if they were brought into that shared platform, into that scope economy, so that every team doesn't necessarily have to rebuild how to do pipelines, rebuild how to do data services, rebuild how to do object model, whatever. So that's this sort of piece of understanding connection between not just the innovation and efficiency, but between the innovation opportunities themselves. How do they connect to each other? Bringing that into that shared platform and making it more valuable. You also often see the other side. So this is kind of a thing that swings back and forth, sometimes in the same organization. And you see this pattern where maybe operations or compliance has a very strong hand, and or a lot of the processes were designed in a time before cloud where everything was a very expensive decision. And as a consequence of that, there's just a lot of restriction on the resources. And those resources are there and they might be available, but just the process to get them is onerous. And as a consequence, you're really limiting what's possible for the organization to be innovative. And so those overly restricted resources would probably be more valuable if they were brought into that middle platform and made available, right? So here's where we're going to make it even more concrete with examples. So this, I'm just going to read this. Remove friction from product development, high trust, low process, no handoff between teams. Don't do your own undifferentiated heavy lifting. Use simple patterns automated by tooling. Self-service cloud makes impossible things instant. So that's not anything I ever said, although I just said it right now. This is my friend Adrian Cockcroft. He gave this speech in 2014, right after he left Netflix. He was going to Battery before he got to Amazon. talking about the lessons learned at Netflix and how, if you read between the lines and kind of go watch that old talk, you see him describing this platform that allows developers to do a lot of things autonomously. They have self-service access to do deployments. They're encouraged to do those deployments without any restriction, but they have to conform to that deployment pipeline. They have to conform to certain conventions about what Netflix does with their architecture. And it's possible to go outside of those, but to do so looks much more like a traditional change management process. And I'm going to assert that all of these, and there's more than I'm listing here, but all these cloud native companies built these platforms. They built these shared platforms that connect the innovation to the efficiency. And I'm going to argue they had to. It was a Darwinian pressure to get to this level. And I'm going to mention this a little later, but if you haven't already, I'm going to recommend the State of DevOps report from Puppet from 2021, which has a lot of this language. It doesn't quite have the same language I'm introducing here with the scope economy and this like super academic abstract way to talk about it. But the report essentially becomes a bit of an advertisement for team topologies and like a bunch of interesting, thoughtful stuff about how collaboration works across different value streams and supporting these platforms. And it's kind of like a nice way to look at it, more concrete examples of how to implement some of these things in your organization. So this is right from the SRE book. This is the Site Reliability Engineering book that was first published. If you read the SRE workbook, there's a foreword that I wrote in there that I'm quite proud of. But I'm just going to read I'll read this. So this is a screenshot right from this book. So SRE build framework modules to implement canonical solutions for the concerned production area. As a result, the development teams can focus on the business logic because the framework already takes care of the correct infrastructure use. So this is another more concrete example of this middle platform that's enabling the development teams to focus on the business logic, but it keeps strong promises to that underlying infrastructure. Right, and this is Google, in Google's words, explaining how they built their shared platform. So just for the sake of the buzzwords and the tools, the fashion of the day, Borg, which is the kind of original container scheduler that Google built, is a scope economy construct in this language. Kubernetes is also a scope economy construct. Yay, Kubernetes. Also, this is fascinating. I think it's fascinating because just think about the big picture. You basically have Kubernetes as an open source, global commons, the shared resource where everyone's building, and you use what is being built in that global commons to build these local shared platform commons. And I don't know what everyone else is working on, but I work on a lot of kind of Kubernetes-centric programs, and it's interesting to see it all come together. So another thing, and I love the SLO language. I think last time I gave a talk in Istanbul, I gave everyone homework to read the service level objectives chapter in the SRE book. So if you haven't done that homework or you haven't seen me talk before, I definitely recommend reading the SRE book. But the SLO, and this is the way that they frame it, it's essentially this three-way contract negotiated between the business, the SRE, and the SWE, the software engineers. And through the language and the lens I'm giving you now, that's a commoning exercise. That's this negotiation between those interests in favor of their collective interests. So here we have three economic games: innovation, efficiency, and in the middle, we're going to connect them together with this platform. So the three ways you win the three games: you win innovation, you win differentiation by creating more novelty, you win the scale economy by creating more efficiency, and you win that platform economy, that scope economy, the more that you get reuse, the more that you get sharing across those organizational teams. So here's the holy grail. You have this novel value creation, self-service access to the developers, and the differentiation economy. That is facilitated by this platform that keeps all these promises and enables that self-service. And those promises are kept to that underlying infrastructure so you can maintain those reliable compute networking and storage pieces that you love. So again, this is a shout out to another Carnegie Mellon PhD where I got some of this language. I was introduced to this through Jabe as well, but this is a very, very, very smart person. There's a great talk with him and Jabe that was on the OpenShift Commons a few months ago. And he's at Microsoft, but he has this fascinating work he did on his PhD talking about platforms, and it's not even about technology platforms. It's really just about building shared understanding between groups that have common interests, and it's all framed around this model of like an African village. And also, I don't know, the cards, I love them, and like reading through how he thinks about taking common resources and getting groups who have a selfish interest in that resource, but also a collective interest to negotiate with each other in favor of that mass middle. So just reading Demeji's stuff, I'll read the first half of it. Platforms may be understood more conceptually as guiding principles that redefine two sides of binary relationships that reveal the mass middle as an opportunity for intervention. So we can recognize dev and ops as this binary relationship, but we have this shared interest that we can negotiate with each other in favor of this collective. So through that language, through that lens, understanding, and this is going to be different for every organization, right? So you see lots of these attempts to build platforms, and one will be maybe led by operations, and they'll decide this is what the platform should be, but then the developers don't want to use it because it's not fit for their purpose. It didn't go through this process of understanding the resources and the why on each side, and you can go too far the other way and maybe allow almost too much variation. So yeah, the developers get some of these things that they want, but you're not doing any favors to the collective because you created all this operational burden. So finding a fit for purpose platform strategy based on the nature of the work you're trying to do and what will enable innovation for that particular game, for that particular group of developers, but also be able to keep the strong promises. And I'm not going to get into this today, but there's also other selfish interests, right? There's like security and compliance. And I find right now I spend a lot of time helping people think about those interests. And at certain point, certain scale in a lot of regulated organizations, that is the main bottleneck, right? So finding a way to bring security and compliance into that organizational conversation focused on how we can automate the compliance and security is critical, or else it's just a huge bottleneck. It doesn't matter how much you invest in automation for developers and operators if it's still going to bottleneck on all the security and compliance. So that's part of it. So traditional IT, we have this kind of conflict between these two, but can we find a way to bring it into this platform? And you know, right now we have these container platforms, or I'd argue the serverless platforms can serve a similar thing. But even back to the very beginning, my first days of Puppet, the goal was always to be able to build these things. I think those tools weren't quite as good at it in some ways, but that was always the goal, is to be able to have the developers do all this stuff with self-service and having the ability to build their stacks and do their deploys, and then have the operators be able to do all the things they need to do to keep their promises. And I don't know, I feel like we're making progress, but also there's a long way to go. So on that note, and I mentioned this State of DevOps report a little earlier. If you haven't seen it, I recommend you see it. There's a lot of these floating around for the last, it's almost 10 years now, I think. The State of DevOps report is interesting because it like started Puppet, and then it had Dora, and then Dora went to Google, and then there was a separate one, and now Google's doing another one, but Puppet still does one. And so I think one year, like, there was 5 of them, but this is the one from Puppet this year, and I think it has a lot of interesting points. And I just took one screenshot from it that I want to share here because I thought this was interesting. And like I said, there's all this other stuff about team topologies and platform teams and the rest of it that might be interesting, and I definitely recommend you read it. But this key point that I wanted to share here is you see a lot of organizations are kind of stuck in this middle evolution, not getting to be a high-performing team. What do you need, Jasper?
There's a
I don't know. You need to go.
There's no chargers.
Don't talk right now. Go away. Go to bed. Sorry. So this investment in DevOps, this investment in automation is great, but you have organizations that have been on this journey for, some of them are like 5 years or more into this journey, and they're not getting to those higher level, higher performing capabilities. And so I'm just kind of fascinated what is keeping people stuck there. And you can go read it and make your own conclusions. But I think a lot of it goes back to some of the points I was making. They don't use exactly the same language I just did, but just reading between the lines, and you can follow up and tell me if you agree or disagree. It really has to do with the extent that you're bringing all those selfish interests to negotiate in favor of the collective interests. My children are going to go kill each other. Hold on. That's exciting on a Friday night. So moving on, and we're coming to the home stretch. This is also related to a lot of the work that I'm doing right now, trying to get to like build these holistic outcomes with organizations. And so I think it's interesting. I'm going to share with you today. So this is what I normally introduce as the 5 elements. I usually will introduce them as failures, 5 failures. And this is, reflection from the last, let's say 15 years of my career, and some of the other people that I mentioned on my team, and some of the conversations and patterns that we've seen working on these kind of projects. So there's what I'll call a leadership failure, and I'll change it to an opportunity in a minute, but a leadership failure is essentially that the organizational leadership is not prepared for new ways of working, and so there's active efforts to prevent the change and to prevent the new ways of working. Then there's what I'll call a product failure. A product failure, you see this when there's not really good framing for the strategy of what you're going to build and connecting it to something that will create value for the organization. So you see organizations that will spend a lot of time and money on like some websites or some mobile apps or whatever, but that money isn't really well spent. There's not a good value created from those projects. Then there's development failures. This is the center of gravity for the agile practices or whatever you want to call that, where you have some combination of technical skill and communication that allow you to take those strategies, those requirements from your product, and drive them into your development organization and get those features, get that vision for the organization. Then there's an architectural failure, and I think it's a little bit. It's unfortunate that architecture got set up as such a straw man villain in some of the early agile conversations. But I think at a certain scope and scale, if you don't understand architecture, then you're going to run into a lot of problems. And so for me, when I say can't keep promises, architectural failures are, you have this application, the features are meaningful, they're creating value, but it's hard to keep those promises about scalability, reliability, latency, a bunch of sort of quantified and qualitative promises about the things that keep that app up and performing. And then that connects, last but not least, to operations. And I really believe, and probably have some bias from my experience in DevOps community, but operations is the defining advantage of the true cloud native companies, of the true cloud native organizations. So if you look at what it means to be cloud native, they're all operationally excellent, and they don't really suffer or there's a lot of very smart people and a lot of very good technology to make this possible, but it's about keeping those systems running without the incidents. So again, each of these almost could deserve its own lecture, but just sort of thinking about these new ways of thinking or working. In the past, a lot of organizational framing for leadership was really about command and control. Like there's this centralized decision-making function, and all of that goes out. But in the new models, I think you're seeing better results. And I didn't put this in here, but Simon Wardley is doing a lot of interesting research in this direction around how these new organizations are led and what the qualities of this kind of leadership is. So just to oversimplify it, leaders set vision and culture by inspiring, sponsoring, clarifying, and then last but not least, and sort of related to the theme of the day, reconciling those inevitable conflicts that are gonna occur, right? So in a lot of organizations, you get this culture where people don't really resolve their conflicts. They just let the conflicts be there forever, festering and causing ongoing problems. But if we can recognize conflicts, make them explicit, and reconcile them, we get better results. Product. This is, there's culture around this, but in the old way of working, there's lots of assumptions that go out for 3 years, and people are working on a product that is, I think in some cases, provably doomed from the outset, but they're going to still build their thing on budget on this timeline, where a little bit of modeling, measuring, validating would tell you that wasn't a good idea. And then once you have some understanding of what you want to build, I think a critical component of this function is really communicating that into the rest of the organization. Development. This is, like I said, that people spend lots of time talking about Agile, and that's its own thing and has a lot of things, but just kind of to put it here for completeness, collaboration, comprehension, committing, and creating. And then architecture is about connecting these things together in a way that allows these organizations. Did I mention I'm on one thing? I apologize. Jasser, I'm literally talking on a thing. Can you get it? Hold on.
I'm just getting more excited, so Jasser maybe joins us. So no worries.
My wife's trying to get my 9-year-old, and he's trying to get away from her.
No problem at all. We are also waking up, so yeah. I mean, people want him, so let him join us. So by the way, folks, if you have any questions, we are on Discord, and I will ask them at the end of the talk.
That was exciting.
I mean, people just want him live, so
Bring him back.
See the comments, yeah.
So just to come to the end for completeness. Architects, I think, are critical. Not necessarily the person, but this function of being able to see those big picture, right? So when you really focus as a developer on creating innovation, you can't always see how that stuff connects to the bigger vision. And so having someone or people who have that ability is critical. And then moving on, operations. And I think I used exactly these words last time talking about DevOps, but collaboration, automation, metrics, and sharing. And I said this before, the operational excellence is the defining advantage of the true cloud natives. So we're in the home stretch here. I'm going to say most organizations, they have these roles. There's titles, developer, architect, operations. But many organizations don't really have these capabilities. And so there's some kind of thoughtful way to think about what would it take to be better at these things. And this is the framing that I like to engage and have conversations, looking at organizational capabilities and how to make investments and choose interventions for opportunities to improve. So do you have true executive sponsorship for new ways of working? Do you have the ability to create strategic requirements for what you're going to build? Do you have that development capability to take those requirements and deliver those features? Do you have that architectural understanding to make doing the right thing easy? And then can you keep those systems up and make systems that never stop? So this is Sun Tzu, who some of you might know who this is, some of you don't, but I like this quote. And then I'm going to share a little kind of thought leadery infographic that amuses me. So there's this quote: all can see these tactics whereby I conquer, but what none can see is the strategy out of which victory is evolved. And so the point I want to make here is really two things. One is that there's kind of different timelines. So tactical things are in a shorter timeline. You can see them, they're more concrete, where strategic things are on a longer timeline, and sometimes they're harder to understand. And at the same time, Sun Tzu's arguing that they're maybe more critical. So with that in mind, I set up with the three economies this kind of notion of the differentiation, innovation on one axis, going to the scale in efficiency on that kind of horizontal line. And then I'm also setting up the tactical and strategic dimension on the vertical. So the way that I think about this, and I believe this is true, is that the most tactical thing that happens in an organization is that operational response to an incident. So you have operations, in my opinion, is sort of this tactical manifestation of the efficiency of that scale economy game to keep those systems running. Development is the tactical manifestation of innovation, but coming down, you have architecture as the strategic investment in efficiency, and product as the strategic investment in innovation. And then I think of this as like this three-dimensional thing. So leadership is sort of coming on this third dimension, and then going back to this idea of conflicts that need to be negotiated in favor of the collective. The more leadership that your organization has, the more you can have of every one of these other things and keep them in balance. And there's kind of like longer framing that might be interesting to talk about at some point about the types of problems that you have in an organization when one of these gets out of balance and maybe like too strong compared to the other ones. And that's a kind of a fun thing to talk about and think about right now. So this is not a technical problem, and I think this is common in the DevOps conversation, and kind of go back and forth between tools and culture. And this isn't new. I've said this kind of stuff for the whole time, actually 10 years of DevOps, but it's not about the tools, it's not about the technology, it's not about the people, it's not just about the people. What we're trying to do, what we're trying to build is a socio-technical system. That's what's delivering these results. That's what's delivering this reliability, is that combination of technology and people coming together. So you have to solve those problems simultaneously. So you have to solve both of those together. So at the end, DevOps is not a team. DevOps is not a tool. DevOps is not a project. DevOps is resolving conflicts. DevOps is resolving conflicts in favor of our collective interests. So this is kind of like the framing that I believe, and lots of people, and I've used other definitions for DevOps, but this is the one I like right now. Is it's about bringing all the selfish interests together and resolving the conflicts in favor of our collective interests. So with that, we're coming to the end of our time, or I guess we're going to have some conversation. So that's 44 minutes.
Thank you very much, Andrew. I mean, for spending your Friday night with us and live examples of organizational difficulties. So that was fun, by the way. People had a lot of fun. So, my wife's not very happy about it, but I mean, we are happy, so she should be happy as well. No problem for us. Always a great talk, always great ideas. People had some good conversations on YouTube, And we also share Japes and your Twitter accounts for people to follow. I mean, great ideas. So I guess we have one question on Discord, maybe. So let me read it. So it's in Turkish. Okay, so basically, the person asks, what do you see about where this DevOps thing is going, and about all this, tool variety and expertise requirements and lack of people, like let's say experts in DevOps. Like, how will this requirements, let's say, will change DevOps?
So if I understand the question correctly, it's basically how does the proliferation of all the tools and then the lack of available expertise in those tools, like where does that go?
Yes.
So I think there's a couple factors, right? So the reality of technology is most of this stuff is about fashion and tribalism as much as it is about utility, right? So right now, there's kind of this center of gravity around this ecosystem for Kubernetes. At one point, you had competing container platforms, right? So you had Mesos, in some ways had a pole position. Cloud Foundry's born. Nomad still alive, but it's sort of consolidated to Kubernetes. And I think this is the reason I bring this up is it's a pattern that's common, right? You see the proliferation of the tools happens, right? So you have like the previous generation of tools, Puppet, Chef, Salt, Ansible.
Mm-hmm.
No, none of them really went, right? And then it's like now there's a new thing, right? So what I try to think about is, and I think I might have shared this like wave of adoption in the last time I came. So you have this notion of crossing the chasm. Is that a familiar metaphor for most people? So like the idea is that there's some innovation, and then there's early adopters, and then there's gap before the majority will adopt things, right? And so you can kind of think of those as a wave that's coming all the time, and there's new waves. So like you go to the ocean, and there's all these waves. And so this is what makes it both interesting and also difficult, is not all of those waves are going to be big, and not all of those waves are going to get to the other side. And if you want to live in that early adopter world, some of the things that you choose to get expertise in won't make it to the other side. Did I freeze?
No, I mean, we lost a couple of seconds. That's fine. Okay, I mean, that's, I guess, all. I mean, we had some general questions, let's say, about Calms and like adopting DevOps culture, but they're, I guess, too generic. And so if you have...
So I think culture is an interesting word. And I get asked questions about culture all the time. And I feel more... It's not a bad word, but at the same time, it's not acceptable for most organizations. So what I try to frame things is about behaviors and try to get as concrete as possible. So like culture as this generic thing, when people say they want a better culture, they have problems with culture, what they typically mean is organizationally, we are not able to change our behavior to new behaviors. So why focus on what those behaviors or kind of like a information so that those new behaviors will emerge.
And when you say like change in behavior, all I can think of is your keynote from 3 years ago. It was about exactly this topic in Istanbul. So, but if I mean people are interested, they can see that talk on YouTube. So I guess that's all. I mean, thank you for joining us, Andrew. It was really nice to have you, and thank you for spending your Friday night with us.
Well, thanks for having me. I hope that was interesting and thought-provoking. I'm happy to come and have a conversation with you anytime.
All right. Thank you very much, Andrew. Cheers. Bye. Okay, so we now have about 10 minutes until the next talk, and we will take a break and be with you with Jason. All right, welcome back, everyone. So let me add Jason to live stream. Hi, Jason, how are you?
Hey, I'm doing all right. How about you?
I'm great as well. So thank you for joining us. So we are looking forward to your talk about, especially we are following your ideas on chaos engineering. And I think today's talk is a little bit about that and more probably. So we are looking forward to learn more. Again, thank you very much for joining us in this Friday night. And I will give you the floor if you are ready.
Yeah.
And can you share
am ready.
your screen?
Yes, I can.
Okay.
I feel like Andrew's son may have done the chaos engineering for me. So
It was a live example. It was a great one. Yeah, people enjoyed it. Like
yeah, well, thanks for having me. Let's chat a little bit about chaos, but not just chaos. I've been really into innovation recently, but I thought I'd start this off maybe doing a little bit of that interactivity. I've got the YouTube chat open. I've also got the Discord open on my other screen here. So pop quiz. Pretty easy. We'll start off super easy. What's the capital of, well, for most of you joining us today, what's the capital of your country? Drop that into chat if you feel like it. Although you probably, at this point, it's early. You might need some coffee, but I hope you actually remember this. I, being an American, not so easy. Yeah. So, I mean, pretty straightforward, right? You should all know this. It's not that hard. Next question, maybe a little bit harder. What is my favorite color? We got some people throwing a gradient of green or a gradient of purple. So actually, it's gray, color of my shirt. Although, yeah, green and purple, good guesses. Next question in my pop quiz. What will cause your next service outage? So this one might be a little bit harder, right? I don't know. You could probably take a guess at what would cause it. Your next deployment, a configuration change. Yeah, ignorance, a monkey, maybe a monkey. I bring these up because we talk about these concepts a lot, and I think that some people don't really quite get it, especially when I chat with folks about known knowns, known unknowns, and unknown unknowns, right? Known knowns, those are the things that you know and that you know them. You all know the capital of Turkey, and you know that, right? You know for a fact, absolutely 100% true, not going to be wrong on that. And then there are known unknowns, things that you know that you don't know. For example, you guessed at my favorite color. You knew that you didn't know that as a fact. Is worth guessing. I like to say similarly, I know that there are nuclear submarines in the world. Somewhere in the ocean, there are a bunch of nuclear submarines by a bunch of countries, the US, Russia, China. And I know that I do not know how to operate a nuclear submarine, right? So that's a known unknown. And then there are these things that are unknown unknowns. They are facts, they're ideas that are so beyond our current visibility, our current scope of thought, that we don't even know that we don't know about them. And so that's what we talk about when we talk about what's your next service outage, right? You know that you can have an outage. You don't know what that outage is, when that'll happen, and therefore you cannot know what will cause that outage. So I bring this up because I work for a company called Gremlin. Our goal is to help people be more proactive about improving reliability. We often talk about wanting to just make the internet a more reliable place in general. There's a book here if you're interested. My friend and colleague Tammy Buto and some other folks wrote it. about reducing mean time to detection for high severity incidents. I'll pop that link into the chat later if you're interested in that. A little bit about me, though. Just to kick off, I'm Jason. I lead the advocacy team, the developer relations team at Gremlin. I previously worked at other companies that you've probably heard of. I'm super into Pokemon, so I actually did stop in Turkey, in Istanbul, for like one day simply to like go catch Pokemon because it was a layover. If at any point you've got questions, I'm in the chats, but feel free to email me, je@gremlin.com, if you think of anything later. But I've been really obsessed with innovation recently. I've been reading all these books because I find it really, really fascinating. And so I stumbled across this idea from this author, Steven Johnson, called the adjacent possible. And Steven Johnson actually stole this idea from a biologist named Stuart Kauffman. And Stuart Kauffman, the biologist, uses the term to describe the incremental steps of biological evolution. In other words, Steven Kauffman's idea is that you can't just evolve from, say, a fish to a land animal. You first have to, the fish has to evolve limbs, right? It's got fins, and those fins have to get longer, and it's got to develop a bone. And then that bone gets long enough that it can develop a joint, like an elbow, and suddenly you have a fish with legs. And then those bones need to get stronger, and it has to develop lungs, and eventually it can crawl out of the water and walk on land and become a land animal. And so Steven Johnson applies this to innovation. And he says that the adjacent possible is a kind of shadow future, hovering on the edges of the present state of things. It's a map of all the ways in which the present can reinvent itself. And so I love this idea, right? He goes on further to explain it this way, that the strange and beautiful truth about the adjacent possible is that its boundaries grow as you explore them. Each new combination opens up possibilities of other combinations. And you can think of it like a house that magically expands with each door you open. So you begin in a room with 4 doors. You stroll into that room, or you open one of those doors and you stroll into that room, and 3 new doors appear, each leading to a brand new room that you couldn't have ever reached from your original starting point. You keep opening doors, and eventually you'll have added on more rooms, and you'll have built a palace. And so I think if we think back to the known knowns, that's like the things in the room that you're currently in. It's all the things that you know are possible. And for innovation, then, it means that the room next door, those doors, is the known unknown. It's the things that we know we can sort of imagine that we can get to, that with some sort of progression of current technology, we can accomplish that next thing. And the unknown is what lies beyond that next room, the things that we can't imagine, right? The things that we haven't made those intermediate steps for, because we need to first make those immediate, those adjacent possibilities. We need to invent that next thing before we get to see what's beyond that. Innovation builds on itself. And so when I asked you this question, what will cause your next service outage? The answer is obviously, I don't know. I mean, we can all joke, and we know some of what's caused outages in the past, and hopefully we don't repeat those. But it's an unknown because we don't know. And because we don't know exactly what to look for. Because obviously, if we knew what to look for, we would have addressed those, right? If we knew that a certain configuration change would take down production, well, we would guard against that. So when we talk about proactively improving reliability, the solution, I think, is the same as innovation. And I love that Andrew talked about this, right? The idea of innovation being tied to scale, and scale including reliability, right? Including, you can't scale, you can't be efficient if you're constantly going down, and that these are connected. And so for me, I think that innovation and reliability are really two sides of the same thing. If failures are complex and we work in complex systems, then we need to try to move from the current room that we're in, our current understanding. And similar to innovation, we need to start exploring what those adjacent possibilities are, right? Start exploring the failures we can imagine in order to start moving ourselves to a point where we can see the failures that we could have never imagined before. So this is where chaos engineering comes in. Or in Andrew's case, if I had kids, this is where my kids would come in yelling. But chaos engineering, maybe not quite just random chaos and havoc. I like to say that chaos engineering is this, that it's scientific experimentation on our systems that improves our understanding of how they work and, of course, how they fail so that we can make them better, right? The idea behind this is that our systems are only as good as we are as engineers. You can only build a system as good as you are. So the only way to build a better system is for you to get better, for you to get more knowledgeable, for you to understand how things work. So chaos engineering really just follows that scientific process. As a scientific process in itself, it starts with observation, hypothesis, experimentation, analysis, and then iteration and repeating. Observation, well, so a lot of times this is just baselining, right? What are we observing? And a lot of people like to go about this and think about, is my system reliable? But again, we're trying to get at this idea of, does my application or system work the way that I think it does? And that leads to your hypothesis then. Given a certain condition, how do I think my system or application will react? Write that down, make a note of that, and then actually take the time to try that out. Insert that failure, replicate the condition that you're interested in. The analysis is pretty straightforward. What did you learn? What can be improved? But if we start thinking about the adjacent possible, then it's also what else could happen, right? Exploring the failure that I can think about and now actually implementing that and seeing what can go on. If we think about complex systems and we talk about there being no singular root cause to those catastrophes, well, if you now know one contributing factor and you've explored that, you can start to easily imagine what those other contributing factors are. And then, like all things with science, it's all about repeatability, right? So repeat, keep testing, keep iterating, and sharing your learnings so that others can follow. As you do this, highly recommend that you start small and then increase. Don't go full force. Don't take down entire clusters. Don't even really try the whole chaos monkey thing of killing a server. Start it simple, right? Start just with a simple on-off test rather than actually forcefully taking something down. And then start to work through your regular development practice. The biggest question that I get asked about chaos engineering is, well, do I have to do it in production, right? That's what we've all heard from all these major companies, Netflix, Amazon, Google, all these folks that are running chaos engineering. And they're like, yeah, we take down stuff in production all the time. And you go to your boss and you're like, we want to do chaos engineering. And they're like, yeah, no, you're not going to take down production. I'm not an idiot. The thing about it, though, is that's not where you start. You don't deploy code straight to production. You don't deploy things straight to production or log into production machines and start changing things around. Well, hopefully you don't do that. You work in development. You become confident in what you're doing before you move that to staging, right? And then you continue to work on it, test it out, get confident in staging before you roll to production. This is exactly like how we do everything else with our processes. Same thing applies to chaos engineering. But the idea here is really simple. We have our known knowns. These are the things that we design for. We design certain things for reliability. We architect things to have redundancy or failovers or backups. We test to ensure for quality. That's why we have automated testing in our pipelines. We do auto remediation as well. And then there are the known unknowns. And these are the things that we know something could go wrong. We don't know what it looks like. And this is why we have monitoring. We monitor for failure. We create response plans and incident response plans that allow us to say, we know something bad could happen. We don't know what it looks like, but we have a process in place. And unfortunately, those unknown unknowns, we have hope. We just hope they don't happen, right? There's not a whole lot that we can do because we don't know what they are. We don't know what to look for. So if we're here right now and we're working and doing the best that we can to design for reliability, to test our code and our processes, to build auto scaling and auto remediation tools, I think chaos engineering can help us start to explore here. And the great thing is once we move into those known unknowns and we start doing chaos engineering, we start getting a better understanding for how things work and how they fail, means that those known unknowns now become known knowns. We know a lot about them, and we can now design for reliability for a lot of these things and test for them. And that also means that we've expanded that boundary again on the unknown unknowns, and they now become our known unknowns, and we can keep progressing out. So I've got a bit of time. I figured we could do a little bit of a chaos engineering experiment. So we'll start with some observations and make a hypothesis. So I've got somewhere open here in my terminal, I've got a random Kubernetes cluster that I use for demos. We can see that hopefully it's got some stuff running on it. It does. Looks like I've got the Google Microservices boutique shop app running. It's an online e-commerce site. Doesn't really matter what it is. But we all know that Kubernetes, a big fun thing about Kubernetes is things just keep running, right? So if I were to say, delete this pod, right? The whole point is that that pod should just come back. So takes a little while, but we do that. We see that, all right, it restarted it. It's not quite ready yet, but it's there. So this is one of these observations that we can make, right? We can say that our systems are running, looks pretty stable. Kubernetes seems to be working as expected. So then we can create a hypothesis. Well, what happens if we start to do this, but we stress the system? What if there's not enough, say, CPU? So my hypothesis in this is that hopefully this pod will actually wait until the attack is done when it can get CPU, or maybe there's just more CPU on another node. So we'll just move that on over. So you simply run that experiment. So I've got some monitoring open. I've got some Gremlin open. Let's just do a quick test here. And I'm just going to start stressing out some CPU, and we'll see what happens. Once this loads up, let's go ahead and go into infrastructure attack. We're on hosts, and we'll select these nodes. Actually, let's go. I normally say go small. Let's go big. We're going to target everything. We're going to consume all their CPU. We'll go for 60 seconds there. 100% capacity, all cores. We'll launch this attack, see what happens. So while that's spinning up, let's go ahead and delete this new pod. And so that's deleted. Back here, it looks like we are consuming CPU. So that's working. We can work to confirm that in Datadog. Looks like that's cranking up there. So it looks like it's doing the same. It's scheduled. It is not running. So now that we've done this and we know that this service is waiting, let's explore the adjacent possible, right? If this service isn't coming back, what else could happen? What else could happen that could potentially prevent this service from ever coming back? So these are the things that you want to start asking yourself, right? I'm getting close on time here, so we'll just wrap up this attack. Looks like it's still running, so I'll just let that run out. Looks like we're wrapping up on the metrics there. So that's where we'd start to do more of that analysis, though. What else could fail? It's a good question to ask as you're exploring your own systems. So the other question that I get a lot is, does this actually work, right? Aside from the Netflixes and the Googles and the Amazons of the world, does it work? We recently ran a study earlier this year of a bunch of folks who are doing chaos engineering. A lot of them are seeing increased availability. They're using it to reduce their times to detection, resolution. They're using it in their testing processes, so they're reducing the number of bugs that are shipped. So if that was your answer to what will cause your next outage, could do that too with chaos engineering. But back to that question, I don't know the answer to this. You don't know the answer either, but I think you can find out. I think you can start exploring those adjacent possibilities of failure with chaos engineering and avoiding some of those catastrophes. So that said, I'll wrap it up here. As mentioned, I'm in the chat. I'm also in the Discord, happy to answer questions. Also, I will paste these links into both of those so that you can access those.
Thank you very much, Jason. Always a great talk. So we had some comments and questions, if you have some time.
Yeah.
I can ask them. So there was a comment. It wasn't a question, but I just wanted to share and maybe get your opinion on this. Someone said this chaos engineering thing, looks pretty much like pen testing, but not especially for security. What do you think?
Yeah, it definitely takes that same approach, right? The idea of pen testing is you can't know where your weaknesses are unless you actually test for them. And similar with chaos engineering, you've really got to test for your weaknesses.
So in another comment, someone said, like, how do we know which door to open to achieve our target?
Yeah, that's a great question. I think the question for that in terms of chaos engineering and reliability is, what do I test, right? Given any experiment that I can run, what should I test? And I think, again, it's to test what you think you know. And so a good place that I think people should start off with is monitoring, right? Given that I have the system, what do I think I know about my system? Well, oftentimes what we think we know is from our monitoring tools, right? Is it showing me the right metrics? Am I actually getting the correct information? You don't know that until you actually start to play around with that.
Thank you. So this is there was a short discussion about this. This was like a high level, let's say, question.
Yeah.
So someone said, how about flexibility and transformation when considering innovation?
Yeah, that's a great question. I guess it's it's sort of a very broad question, so I'm not sure where to take that.
So someone shared their answer. So he said, Ersin said, you cannot if your system is just like in the metaphor he provided. However, the idea is explore and expand the present state possibilities instead of chasing an unknown and unpredictable future.
Yeah. I guess the other thing too is, yeah, part of that is as you're expanding out, right? You have the idea of, I mean, flexibility and transformation are pretty broad. So I think most people, when they say transformation, they mean digital transformation, which generally means adopting DevOps, right? And that can be very much done in an iterative process. So start to focus on one little thing, right? Whether that's automation, whether that's a cultural thing, whether that's things like adopting blameless postmortems. There are very small things that you can start to adopt, and from there you can start to expand and see, well, we went from changing the culture from blaming people to being blameless as we do retrospectives. Cool. Now that we do this, what more can we do from learning, right? How can we promote people collaborating more? So I think it can apply, but again, broad question. So
Yep.
If that was you that asked it, follow up with me later and we can discuss specifics.
Yeah, I mean, Jason is on our Discord as well if you have questions. And there's a very related, let's say, question to what you just mentioned. So Halit says, how much time do you need to spend on chaos engineering? Because the probability of the issues you will find may not be the same with real world.
Yeah, that's an interesting question. It's one of those hard things, right? When you say the probabilities of what you might find may not be the same as the real world, inevitably they're completely different because what you find is the stuff that you solve and then it never happens. So you're trying to measure a thing that never happened. That makes it difficult. That said, how much time should you spend? We found that companies that are running chaos engineering experiments or game days or fire drills at least quarterly are seeing massive benefits over those that don't. So even once a quarter, once every 3 months is enough to gain some benefits. That said, I rolled out a program within Gremlin that we do them more regularly, and I've constrained it down that it only takes us half an hour to do. I've got information on how to do that as well. So if you're interested in these half-hour, what I call mini game days, happy to share that with you.
Thank you, Jason. Great talk, great chat, and thank you for spending your Friday night with us.
Thanks for having me.
Thank you. Let's keep the conversation going on Discord. And right now, we will have a short, not 30 minutes long break. And after that, we will continue with our next talk. Thank you, Jason. See you. Merhaba arkadaşlar. Tekrar hoş geldiniz. Sayımız artmaya başladı saat 11 olunca. Takibiniz için teşekkürler. Anlık olarak 100 kişiyi de geçtik. Şu anda da 70 kişiyi yine geçtik. Çok güzel gidiyor etkinlik. Hepinize katılmanız için çok teşekkürler. Bundan önce sorularınız çok güzeldi. Konuşmacılarımıza ilettik. Şu an Türkçe devam ediyorum çünkü Çağdaş hoş geldin.
Hoş bulduk. Duyabiliyor musunuz beni?
Evet, duyabiliyoruz gayet iyi.
Çok güzel. Hoş bulduk.
Çağdaş, hoş geldin tekrardan. Şimdi bugünün tek aslında biz rica ettik. İngilizce de yapabilirim dedi ama hani biz bir Türkçe konuşmamız da olsun istedik açıkçası. Çağdaş'a o yüzden hani Türkçe yapmasını rica ettik. Şimdi Çağdaş'a sözü bırakacağım. Çok teşekkür ediyorum Çağdaş. Zamanını bize ayırdığın için, burada olduğun için bugün bizde.
Ben teşekkür ederim.
Şöyle ekranını paylaşayım ve kendimi çıkarıp sözü sana bırakıyorum bir sorun yoksa.
Tamam, teşekkürler. Merhabalar, ben Çağdaş Şenol. Zalanda Search takımında Principal Engineer olarak çalışıyorum. Ve de SLOs Türkiye kanalında Site Reliability Engineering üzerine muhabbetler düzenliyorum. Bugün sizlere mukavemet desenlerinden, Resilience Patterns diye İngilizce'de bahsedilen bunlardan bahsedeceğim. Bunlardan bahsetmekte kalmayacağım sadece kuru kuruya. Varlıklarında veya yokluklarında yaşanmış bizim talihsiz serüvenler dediğimiz incidentlardan bahsedeceğim. Hadi başlayalım. Zalanda'yı bilmiyorsanız Türkiye'de hemen kısaca bir özet geçeyim. Avrupa'nın en büyük online fashion platformu. Ayakkabıdan giysilere, makyaj malzemelerinden takılara birçok bilindik markayı Zalanda'da bulabilirsiniz. Yapılan işin ölçeğini anlamanız açısından, yardımcı olması açısından yani Zalanda'daki SLO boyutunun 10 yıllık 10.7 milyar euro geliri var. 45 milyon aktif kullanıcımız ve 4500'den fazla da markaya ev sahipliği yapıyor. Buna ek olarak Vedit Fırat'la birlikte YouTube'da SLO Türkiye kanalını düzenliyoruz. Orada bugüne kadar Google'dan, Zalanda'dan getirilen ve daha birçok şirketten çeşitli talihsiz serüvenler, incident hikayeler dinledik ve daha sonra üzerinde Discord'dan sohbetler ettik. Şimdi konuşmaya geçeyim. Aranızda bu kitabı okuyanlar var mı bilmiyorum. Konuşacağımız konu güvenlik olmasa da kitaptan bir alıntı çevresinde şekilleneceği için bu kitapla başlayacağım. Kitap 1986 yılında Kris Stoll'a Enerji Bakanlığı'na bağlı olarak çalıştığı Berkeley Lab'da müdürü sistemdeki bir muhasebe hatasını araştırmasını ister. Cliff bu araştırma sonucunda birilerinin bilgisayar sistemlerini kullandığını ancak parasını vermediğini keşfeder. Daha sonra anlayacağı üzere bu kişi sisteme izinsiz giren bir hacker'dır. Cliff daha o yıllarda büyük ihtimalle ilk defa gerçekleşecek uluslararası düzeyde bir hacklenme olayını uzun araştırmalar sonucunda açığa çıkarır. Cliff Stoll'un bu macerasında bugün security camiasında oldukça bilinen honeypot kavramını geliştirir. Kitabı belki de okumasanız da olur ama YouTube'da ararsanız çok güzel şekilde kısa belgeselleri var, hikaye anlatan. Şiddetle tavsiye ederim. Şimdi Cliff Stoll'un bu serüvenini anlattığı kitabında şöyle bir söz var. Öyle başlayalım. Eğer evlerimizi yazılımlarımızı yaptığımız gibi yapmış olsaydık ilk ağaç kakan darbesinde tüm uygarlığın sonu gelir diyor. Cliff Stoll aslında bunu başka bir yerden anlatı yapmış ama bu kitap sayesinde popüler olmuş bir söz bu. Yine şimdi bu açıdan bakalım. Yazılımları bugün yazılımcılar yapıyor. Evleri inşaat mühendisleri, mimarlar, müteahhitler yapıyor. Benim üniversiteden inşaat mühendisliğinden çevremdeki arkadaşlardan bildiğim 2 tane çok zorlanılan ders var. Statik ve mukavemet. Bunlarda ne yapılıyor derseniz binanın ne kadar yük taşıdığı, nasıl sağlam yapılacağı, yani maddelerin direnci falan gibi konular işletiliyor. Bizim yazılım müfredatında genelde böyle bir ders yok. Olsa da çoğunlukla seçmeli oluyor ya da yüksek lisanslar şeklinde oluyor. Peki şunu sorabiliriz, yani biz hani bu hesapları bilmediğimizden mi ilk ağaç kakan darbesinde yazılımlar yıkılıyor diye sorabiliriz ama işin aslı birazcık farklı. Yazılımda deneme yanılma döngüleri çok hızlı bildiğimiz gibi. İnşaatta böyle değil. GIF'teki örneğe bakarsak şu sallanan köprü örneğine. Bir köprü yapılmış, oldukça sağlam. Yani dersin hakkını vermiş ama biraz kullanışsız haliyle. Bir yazılımcıya sorarsanız bunu öbür sprintte hallederiz, fixleriz der. İnşaat içinse bu büyük ihtimal öbür sprintte olmaz. Gelecek bahara kalacak bir durumdur. Can sıkıcı bir iş. Mevzu tabii sadece sorunların fixlenmesi de değil. eldekilerin ölçeklenmesi açısından da mühendislerin işi, yani inşaat mühendislerinin, trafik mühendislerinin, yapı mühendislerinin ne derseniz işi biz yazılımcılara göre daha zor. Bu görüntüye çoğunuz İstanbul'dan aşinadır. Klasik bir görüntü. Köprüden. Birinci köprü büyük ihtimalle. Köprünün kapasitesi yetmeyince yan taraftan kapasite ödünç alıyoruz. Halbuki yazılımcıya böyle bir sorun gelse ne yapar derseniz aslında cevap oldukça basit. Köprünün önüne bir tane load balancer koyar, 2 köprü deploy ederiz diyebiliriz. Ama en basit dediğimize dönersek inşaat mühendisleri genelde bu çeşit soruları önceden öngörmeye çalışıyorlar. Tasarımları ona göre yapıyorlar. Yani o yola kaç sene içinde ikinci bir köprü gerekeceğini daha birinci köprü yaparken ayarlıyorlar. Yazılımcılar için bu çeşit hesaplamalar mümkün ancak uygulanması az. Yani bunun sebebi yazılımcıların da haliyle kötü ya da beceriksiz olması değil. Bunun nedeni yazılımın doğası gereği hızlı deneme, yanılma döngülerine izin vermesi. Yani bir köprü yetmediğinde biz bulut bilişim, cloud computing sayesinde ikinci köprüyü kurmak saatler belki dakikalar alıyor. Hesap yapmaktansa sorunu yaşayınca ölçeklemek daha kolayımıza geliyor biraz. Buna karşın yani sorunu yaşayınca çözmektense buna karşın uygulayabileceğimiz bazı yöntemler var. Bu yöntemler sorunların yaşanmasını engelleyebilir ya da etkilerini yumuşatabilir. İşte bugün bu yöntemlerden yani mukavemet desenlerinden bahsedeceğim. Mukavemet dediğimiz dirençli olmak söyleyebiliriz. Yıllarca design pattern, tasarım desenleri gibi kalıplara aşina olan biz yazılımcılar için mukavemet deseni diye bir şeyden söz etmek abes olmayacak. Çok fazla kişi tarafından kullanılan yazılımlarda bu tür best practice diyebileceğimiz ya da desenleri takip edersek mutlu müşteriler kazanabiliriz. Daha güzeli yazılımcıların sol kulakları daha az çınlayabilir bu sayede. Ek olarak bu mukavemet desenleri bizim yeni keşfettiğimiz şeyler de değil. Bu desenlerin bazıları Linux çekirdeğinde, HTTP sunucularında, başka birçok yerlerde yıllardır kullanılıyor. Bu desenler bize süper dayanıklı yazılımcılar için sihirli anahtar olmasa da eminim ilk ağaç kakan darbesinde biraz daha hafifletmeye yarayacak yöntemler. Şimdi gelin bakalım bu desenler neler? İlk bahsedeceğim mukavemet deseni süre aşımı dediğimiz timeout. Türkçe'de çok güzel bir deyim var, ağaç olmak. Güzel nazik bir karşılık bence süre aşımı için. Görüntüdeki çizim de orta dünyada timeout olan entleri gösteriyor. Yani öyle yorumlayabilirsiniz. Bu problem günlük hayatımızda da sıklıkla tecrübe ettiğimiz bir problem. Köprü örneğinden gidersek siz girdiğiniz sıradaki gişenin çok yavaş ilerlemesi ve arkadan korna çalıp hadi kardeşim diye bağırmanız ve en sonunda da o sıradan çıkıp başka bir sıraya girmeniz aslında sizin bir timeout etmenize bir örnek. Timeout dediğimiz şey bu. Kısaca timeout süre aşımı dediğimiz isteklere veya belli işlere azami maksimum çalışma süresi verip bu süre geçtiğinde bu istekler henüz bitmemiş olsa da bunları kesip sonlandırmak. Şimdi aklınıza şöyle bir soru gelebilir yani. Neden istemcilere böyle bir kötülük yapalım ki? Hani sunucularımızın zaten hani bulut bilişimdeyiz dedik. Sunucularımızın yanına yeni makineler koyarız. Onlar o işlere devam eder diye düşünebilirsiniz. Gelin bu fikre bakalım nasıl olduğunu. Diyelim ki 3 tane istemcimiz, client'ımız var. 3 tane de server'ımız var. Ve client'lardan, istemcilerden server'lara istek gidiyor. Yani bu client'lar tüm server'ları kullansa da 3 istekten biri bunlar sırayla dağıtılırsa bekliyor. Bu bekleyen isteklere biz in-flight istekler diyoruz. İşlemde olan istekler de Türkçe söyleyebiliriz. Yani siz bu sunucuların yanına yeni sunucular da koysanız da timeout etmeyen istekler yani sonlanmamış istekler bu istemcilerde birikip kaynak tüketimine neden olur. Halbuki bunun yerine aslında biz bu sorunu server'ı yeniden başlatsak, çıkartsak ya da bu isteği tekrar dinlesek belki bu sorun çözülecek. Şimdi yani timeout'un faydasını anlatabildim mi bilmiyorum. Şimdi bir tane hemen yaşanmış talihsiz serüven, incident örneği vereyim. Bizler Yazılımda da timeout'u her zaman kullanıyoruz. Ancak hatalı kullanımına bağlı benim hatırladığım bir incident yaşadık. Elasticsearch kullanırken artık tedavülden kaldırılmak istenen Java Transport Client ile kullanılmaya başlanmıştı. Biz de tavsiye edilen kullanım olan REST Client'e çevirdik uygulamamızı. Her şey yolunda gidiyordu. Ancak bazı geceler uygulamamız yetersiz kaynak sebebiyle çökmeye başladı. Sorunu incelediğimizde fark ettik ki Transport Client'ın timeout'lar client tarafındayken REST client'ın timeout'lar Elasticsearch tarafında olan isteklerdi ve Elasticsearch'e kısaca isteği çalıştırınca timeout limitinde sonlanmazsa bana hata döndür diyordu. Gel gör ki REST client bu istekleri yaptığında istekler Elasticsearch'te işlenmeye başlanmadan önce de bir sıraya konuyor. Transport client'tan farklı olansa bahsettiğimiz sırada beklenen süre timeout limitine dahilken bunun aslında bizim timeout dahilken REST client'ta bu dahil olmuyor. Bunun sonucunda aslında bizim timeout sürelerimiz artıyor REST client tarafında transport client'e göre. Bu da bizim HTTP pool'umuz yani istek havuzumuzda daha fazla istek beklemesini, daha fazla kaynak kullanmasına neden oluyor ve uygulama yeterli kaynak bulamadığı için pool'da çöküyordu. Gördüğünüz gibi timeout'un yorumlanmasının geçmesine sebep olabiliyor. Bundan bahsetmek istediğim yardımcı çözümse REST client'te isteklerin sonlanması yine istemci tarafında halletmekti. İşi Elasticsearch'e bırakmamaktı. Şimdiki desenimizde yine Türkiye'de gerçek hayatta çokça sıklıkla karşılaştığımız bir yöntem. Tekrarlamak. Selçuk Erdem'in bu karikatüründe gösterdiği gibi hayır cevabını biz çok sevmeyiz ve illa bir defa hiç mi yok diye sorarız. Bazen bu soru işe yarar. Geçen burada şu anda Türkiye'deyim. Burada tatilde kaldığım otelde Tekirdağ altın serisi istemiştim. Abi bakayım deyip elimize kalmamış dediler. Yani sihirli hiç mi yok sorusunu sorunca 10 dakika içinde 70'lik birden masada beliriverdi. Yani hiç mi yok sorusu gerçek hayatta da işe yarayan bir tekrar deneme yöntemi. Şimdi buna bir örnek ve grafik üzerinden bakalım. Timeout'ta bahsettiğimiz gibi eğer isteklerimiz, işlemlerimiz zaman aşımına uğradıysa ya da beklenmedik bir hata alırsak sadece zaman aşımı değil belki sorunun bir hata döndü. Bazı durumlarda aynı isteği tekrar etmekten zarar gelmeyebilir ve başarılı sonuç alabiliriz. Bazı durumlar dedim özellikle. Çünkü kimse müşterilerin kredi kartından boş yere birden fazla para çekmek istemez. Güvenli şekilde tekrar deneyeceğimiz işlemler idempotent dediğimiz yan etkisi olmayan işlerdir. Grafikteki örneğe bakarsak bir search query'si podlardan birinde başarısız olurken tekrar istek atıldığında başka bir podda başarılı oluyor ve biz de bu sayede ilk hatayı boş yere son kullanıcıya döndürmemiş oluyoruz. Yine bir incident. Aslında bu başka yerlerde de yani doğrudan bir incident değil ama karşılaşılan bir sorun. Yani bir uygulamaya da şirket büyürken birden çok mikroservis eklendiğinde şöyle bir sorun olabiliyor. Diyelim DB'de çok kısa süreli database'imizde yani çok kısa süreli bir performans problemi yaşadık. Bu durumda cascading dediğimiz yığılan şekilde tüm servisler tekrar denemeye, retry başlarsa bu sefer database'imiz birden çok fazla yük altında kalıyor. Bununla baş etmenin bir yolunu ise diğer bir paternde göreceğiz. Şimdiki desenimizde back-off geri çekilme dediğimiz yöntem. Çocuklu seyahat edenler bilirler ya da çocukken seyahat etmiş olanlar hatırlarlar. Uzun bir yola gittiğimizde sürekli geldik mi diye sorardık. Yani bol bol aslında retry yapardık. Anne ve babadan azarı yiyince de sorunun sorma aralığını birazcık açardık. Yani nasıl arabadaki anne babamız sorunun sıklığından sıkılırsa aynı şekilde yönettiğimiz sistemlerde bir önce bahsettiğimiz gibi tekrar denemeler sebebiyle servis dışı kalabilir. İşte geldik mi sorusunun tekrar etme aralığını arttırma desenine de geri çekilme diyoruz. Back-off diye de geçiyor bu. Yine bu örnekte inceleyelim. Bir sorgu yapıyoruz. 503 geldi sunuculardan. Hemen tekrar sorguyu yapmak yerine birazcık beklersek mesela 200 atıyorum tamamen farazi bir örnek 200 milisaniye kadar ve tekrar sorgu yaptığımızda bu sefer başarılı bir cevap alabiliriz. Belki o sırada pod yeniden başlar. O podu load balancer'dan çıkarır. Bizim load balancer'ımız bu gibi şeyler sayesinde o 200 milisaniye bizim işlemimizi biraz yavaşlatsa da bize cevap verme şansını sağlayabilir. Şimdiki desenimizde Matrix 4 yani jitter dediğimiz şey. Matrix 4 yenilenmiş olsa da bu kedi sahnesi aslında bir klasik. Kendi halinde yürümekte olan kediye bir ürperti gelir. Seyirir kedi. Bir defa seyirmesi yetmez, 2 defa seyirir bir de. Bu sırada Matrix tekrar yüklenmiştir. Jitter dediğimiz seyirme de buna benzer. Şimdi bu örneğe bakalım. Eğer sunucularımız bir sorun yaşıyorsa az önce bahsettiğimiz tekrar deneme ve geri çekilme kavramları tüm istemcilerin, client'ların aynı anda tekrar denemesine neden olacaktır. Bu biriken sorguların aynı anda yapılması sunucu tarafında ani yük artışlarına neden olacaktır. Bu durumun oluşmaması için tekrar edilme aralığına random yani rastgele bir ek yapılır. Burada da kutuda da göstermeye çalıştım. Mavi yazıyla random bir 0 ile 1000 arasında bir ek bir gecikme eklenebilir. Tabii bu desen sadece tekrar denemelerde değil, birçok başka yerde de kullanılabilir. Yani bu jitter dediğimiz şey. Mesela aynı anda başlayan paralel batch isteklerimiz varsa kullanabiliriz. Örnek vermek gerekirse tüm servislerimizi aynı anda cache'lerinin yenilenmesini istemek yerine zamana dağıtılmış halde yeniletmek cache kaynağını ani yük artışlarından koruyacaktır. Bununla ilgili yaşadığımız bir incidentle ilgili bilgileri kitapta bulabilirsiniz. Olay kısaca buradaki linkleri daha sonra paylaşırım. Olay kısaca şöyle gerçekleşiyor. Uygulamadaki bir bug yüzünden Node.js sunucuların hepsi aynı anda DNS sorgusu yapıyor. Bu DNS sorgularının hepsi core DNS'e gidiyor Kubernetes'teki. Grafikte bu artışları görebilirsiniz. Bu ani yüklemeler sonrası core DNS'teki başka bir sorun sebebiyle core DNS out of memory oluyor. Tüm cluster'ın DNS istekleri çöküyor ve çok güzel bir incident yaşanıyor. Detayları burada bulabilirsiniz. Bu desenimizde klasik sigorta. Fotoğraftaki örnek eski tip porselen sigortalardan. Kentsel dönüşüme uğramamış eski binalarda onu bulabilirsiniz belki. Türkiye'deki eski evlerde var yani çoğunlukla. Nedir sigorta? Hemen bahsedelim. Diyelim ki timeout, retry, backoff, jitter gibi şeylerle sunucuya ulaşamadık. O zaman artık tüm işlemlere bir ara verip sunucu tarafını rahat bırakma zamanı geldi diyebiliriz. Bu durumda istemci tarafında sigortalar atar ve istemciler de kısa sürede hata mesajı dönüp kullanıcıyı boşuna bekletmez. Yani tekrar denemelerde, timeout'larda bekletmek yerine hemen hızlı cevap döndürür. Yüklenmesi dakikalar süren bir servis almaktansa müşteri olarak hızlı şekilde şu an kötü durumdayız, daha sonra tekrar deneyin mesajı almak genelde müşteri açısından daha iyi olur. Bu desenimizin adı da rate limiting, sınırlama diyebiliriz. Şu ana kadar gördüğümüz desenler istemciden sunucu tarafına olan desenlerdi. Buna sunucu tarafından da sistemin kendisini korumasını sağlayan desenlerden biri olarak bahsedebiliriz. Bunun en yaygın olanı haliyle bu rate limiting, throttling dediğimiz frenleme, sınırlama deseni. Adından anlaşılacağı şekilde istemcilere belirli bir zaman periyodu için bir üst limit koyup onu geçen istekleri reddetmesini sağlamak. Genelde bu durumda HTTP 429 döndürülür. Şimdi diyebilirsiniz ki yani kendi şirketimizde zaten 2 tane servis var. Arasında niye rate limit koydum ya da software as a service company. Yani değiliz yani servis satmıyoruz. Ya da yüzlerce mikroservisimiz yok. Niye böyle bir şeye gerek var diyebilirsiniz. Hemen çok basit bir incident'ta bunu da inceleyelim. Incident'ımız şöyle. Bir tane client var ve sunucumuz var. Bu istemcimiz sunucuya istekler yapıyor ve bunlar aslında tamamen cache'lenebilecek istekler ve cache'liyor istemcimiz de bunları cache server'da. Fakat bir takım talihsiz serüvenler sonucunda cache sunucumuzu kaybediyoruz. Yani cache sunucumuz kaybedince istemci ben cache'siz çalışamam demiyor. Onun yerine cache sunucumuz yoksa o zaman ben server'a gideyim diyor. Burada görüldüğü şekilde. Birdenbire server'a giden isteklerin sayısı inanılmaz şekilde artıyor. Bu ani artış karşısında da server'ımız ne yazık ki çöküyor. Halbuki server'ımız çöküyor. Server'ımız çökünce de biz halbuki orada bir rate limiting olsa istemciye birazcık yavaşla deyip server'ımız ölçeklerine kadar, scale out olana kadar zaman kazanabilecekken rate limiting olmaması sebebiyle tüm sunucularımız çöktüğü için onları tekrar yerine getirene kadar daha çok zaman kaybediyoruz. Yani rate limiting aslında sınırlama. Sadece bir servis istemci arasında da eğer elinizde güzel araçlar varsa işinlerinizi çok kolaylaştırabilecek bir şey. Sıradaki desenimiz bulk bölümleme dediğimiz şey. Titanic neden battı sorusunun çok cevabı var. Ancak en güzeli tabii ki içinde mühendislik olanı. Gemilerin en temel batma nedeni alttan aldıkları darbeler. İnsanlık ve mühendislik bunun için bir çare bulmuş ve adı da aslında bölümleme, bulk dediğimiz bir şey. Yapılan iş kısaca şöyle. Geminin alt kısmına sıkıca kapatılabilecek bölümleri ayırmak. darbe anında darbe hangi bölümü etkilediyse o bölümün kapılarını sıkıca kapayıp gemiye su akışını durdurmak. Bu sayede darbenin etki alanını düşürüp geminin batmasını engellemek ya da yavaşlatmak amaçlanmakta. Bu resimde gördüğünüz gibi geminin alt bölümleri ayrılır ve su gelen bölümlerin kapakları sıkıca kapatılıyor. Bu bölümleme deseni tasarladığımız sistem ve yazılımlar için de uygulanabilir. Örnek vermek gerekirse birden fazla ülkede operasyonu olan bir web uygulamasına sahipseniz her ülkenin verilerini aynı veri tabanında tutmak yerine farklı veri tabanlarında tutabilirsiniz. Güzel bir bölümleme örneği olabilir. Titanic örneğine bakarsak bölümlerin kapıları kapansa da tasarımdaki hata yüzünden bölümlerin tavanı açık kalıyor. Ve bu açık kalan tavandan sular sızarak yan bölüme geçiyor. Ve geminin batmasına yani engel olmuyor. Hatta yavaşlatmıyor da. Gemi hızlıca batıyor. Şimdi Zalando'da da Titanic, onu biz yerinde yapmıştık. Titanic benzeri bir örnek verirsek. Biz de Elasticsearch kullanıyoruz ve data notlarımızı bölümleme yaptık. Her data noduna dedike sunucularda kullanıyoruz. Ancak tüm data nodları bir master nodunu, master cluster'ını paylaşıyorlar. Yani hep tek bir cluster'ımız var. Hepsi tüm master'ları tek bir master'ı paylaşıyor. Titanic misali data nodlarını izole etsek de master nodlar paylaşıldığı için günün birinde master nodlar talihsiz bir takım serüvenler sonucu kaybetmenimizle tüm cluster'ı kaybettik. Bu da çok can sıkıcı bir incidentti. Bunu da eseri Türkiye'nin ilk bölümünde detaylıca anlatmıştık. Merak edenler oradan bakabilir. Ve en son mukavemet desenimize geldik. Son çare diyebileceğimiz köprüden önce son çıkış misali kullandığımız bir yöntem. Tüm denemelerimize rağmen az önce bahsettiğimiz istemciler eğer sunuculara ulaşamadıysa belki de kullanıcıya cevap dönebileceğimiz varsayılan bir seçenek olabilir. Bu seçenek bir hata mesajı olabileceği gibi, hata sayfası olabileceği gibi alternatif bir sistem de olabilir. Çoğumuzun aşina olduğu bir örnek aslında Gmail'de var. Kullanıcıların interneti yavaşsa sayfayı yüklememek yerine Gmail Basic HTML adında 2000'lerin başından kalma gibi bir görüntüye sahip web görüntüsü gösteriyor. Hızlı çalışıyor. Güzel oluyor. Bunun dışında diyelim bir e-ticaret sitesinin kullanıldığı ödeme sistemlerinde bir sorun var. Nasıl bir fallback son çare uygulayabiliriz diyebilirsiniz. İlk seçenek şu anda ödeme alamıyoruz deyip kullanıcıya sonra gelin demek olabilir. Diğer bir seçenek de alternatif ödeme yolları önermek. Avrupa'da yapılan uygulamalardan biri müşterilere fatura ile ödeme seçeneği açmak. Yani fatura ile ödeme ne derseniz ürünle birlikte faturayı yollayıp müşteriden ödemeyi daha sonra almak. Bu sayede şirket belli bir risk alsa da, ödenmeme riski alsa da müşterilerin canını sıkmadan alışveriş yapmalarına yardımcı olabiliyor. Ödeme sistemlerindeki sorunlar için güzel bir fallback son çare de Türkiye'den. Bunu Faruk'tan duymuştum galiba. Türkiye'de fatura ile ödeme çok yaygın olmadığında ve daha riskli olduğundan Trendyol gibi siteler alternatif bir çözüm bulmuş durumdalar. Sonra ödersin yerine, bu riski almak yerine online cüzdan gibi uygulamalarla müşterilerine önceden para yükletiyorlar. Bu sayede BKM gibi sistemlerde, Black Friday gibi zamanlarda, Kara Cuma diyebileceğimiz zamanlarda sorun çıkarsa, bu ödeme sistemleri biraz yavaş kalırsa müşteriler ödeme sıkıntısı çekmek yerine online cüzdanlarından harcama yapabiliyorlar. Bu da çok güzel bir son çare stratejisi bence ödeme sistemleri için. Peki tüm bu konuştuğumuz şeyleri tek tek kendimiz mi geliştireceğiz diye sorabilirsiniz. Çok şükür bunun için açık kaynak yazılımlar var. Poly Project var .NET dünyası için. Resilience for J'de JVM dünyası için olanı. Bunları kullanabilirsiniz. Böyle kabaca örneklere bakarsak hani zaten bir supplier, yani bir dekoratör patternıyla burada işte fallback koyup, retry koyup, circuit breaker koyup supplier'larınızı bu korumaya alabilirsiniz. Bunun yanında bu desenleri bazılarını infrastructure seviyesinde de yapabilirsiniz. Bu Istio adlı, ben bunu kullanmadım. Fırat tavsiye etmişti bahsetmemi. Pek tecrübem yok ama infrastructure seviyesinde de yapılıyor. Bu da gayet deklaratif diyebileceğimiz şekilde gösteriliyor. Hani kod yazmanıza gerek kalmıyor. Sadece bu istemcinin kaç defa retry yapacağını, kaç saniye aralıklarla yapabileceğini söyleyebilirsiniz. Sunumum bu kadar. Her zamanki gibi Zalando'da çok sık iş ilanı bulabilirsiniz. SRE veya DevOps'la ilgili pozisyonlar var. Bakabilirsiniz. Buna ek olarak SRE Türkiye'de konuk olup bizle konuşmak isterseniz Site Reliability Engineering ve talihsiz serüvenler üzerine sizi de bekleriz. Diyeceklerim bu kadar. Şimdi soru cevaba geçebiliriz. Zamanımız kaldıysa.
Var birkaç dakikamız var. Çok teşekkürler Çağdaş. Çok sağ ol.
Ya,
Çok güzel bir sunumdu. Ağzına sağlık. Şimdi yorumlara bakıyorum. Şöyle bir sorumuz var, aşağıya da yansıtayım. Yazılımcılar ve DevOps ekipleri de mukavemeti işin başında ele alması gerekiyor mu?
Alırsanız daha iyi olur ama tabii bu zamanınız varsa yapabileceğiniz bir şey. Küçük bir bloğunuz varsa yani bırakın bana kalırsa çöksün, gece yarısı çalışmayı versin, sabah açılınca halledersiniz. Ama onun için tabii bunlardan biri olmadığında ne kadar para kaybettiğinizi hesaplamak bu karar vermek için size en yardımcı olacak şeydir.
Evet. Ben de hani ufak böyle bir fikrimi söyleyeyim. Yani startup hakikaten çok küçük bir startupsan belki erken olabilir ama büyüyünce bunu yapmazsan kaybedeceğin reliability sorunlarından dolayı kaybedeceğin müşterinin kostu ve kaybettiğin zaman geri kazanmanın kostu çok yüksek olduğu için aslında hani belli bir aşamaya gelip ürün oturmaya başladıktan sonra kesinlikle invest edilmesi lazım. Bunlara hani zaman ayrılması lazım ama çok erken olursa ben de katılıyorum yani. Biraz ötelenebilir.
Katılıyorum.
Onun dışında yine bir Turan'ın bir soru diyebiliriz, evet. Bahsedilen uygulama altyapı seviyesindeki mukavemet desenlerini hayata geçirmek için kullanılan yazılım ortamları yeterli otomasyonu sağlayabiliyor mu?
Bahsedilen uygulamayla kasıt istiyorsa tam bilmiyorum dediğim gibi. Ben çok kullanmadım ama
Evet.
Diğer bahsettiğim Poly Project ve Resilience 4G dediğimiz bunlar tamamen kodun içine sizin yazdığınız kod kısımları, bunun otomasyonu yani nasıl deploy ettiğinizle ilgili, kodla ilgili bir yani öyle hani otomatik yaratılan bir kod yok. Kendi yazıyorsunuz.
Yani soruların şimdi yansıtacağım ama sorular birazcık kontekst anlamında. İçeriği biz yorumlamamız gerekiyor bir şey cevap verirken. O yüzden biraz daha net yazabilirseniz güzel de olabilir. Eğer hani cevap alamadıysanız Discord'da zaten Çağdaş var.
Aynen, Discord'da ben yardımcı olurum.
Ne demiş? Bulkhead işini altyapı mimarisi olarak düşünüyorum. Hep yazılım seviyesinde nasıl uygulanıyor?
O güzel bir soru. Hani o benim verdiğim örnekte de biz işte başka makinelerde Elasticsearch data nodlarını deploy ediyorduk ama bu işte Resilience 4G gibi şeylerde mesela farklı thread pool'lar açarak bir bulkheading yapabiliyorsunuz. Atıyorum her ülke için farklı thread pool açabiliyorsunuz. Bu çeşitli bir yazılımsal olarak da en basitinden thread pool olarak bir bölümleme yapabilirsiniz. Mümkün.
Hı. Şöyle ama Ahmet Faruk bir şey sormuş. Rate limiting için request to load balancer to microservice to load balancer to database server yolunu izliyorsa nerede uygulamak en doğrusu olur?
Hiç bilmiyorum. Uygulamanın şeyine bayağı, kontekste bayağı bağlı bu. Hani sizin orada nasıl kullandığınıza. Yani bizim Zalando'nun kendi kullandığı bir load balancer var, Skipper adında. Bu orada gelen hani tek bu istio'ya benzer şekilde deklaratif şekilde söyleyebileceğiniz bir şey. Benim işime hemen load balancer'a 2 satır YAML eklemek kolayıma gelir. Ama dediğim gibi tamamen sizin kontekstinize bağlı.
Biraz architecture yani çok detay bir soru. Bunun tek bir doğru cevabı olmaz. Bahsettiğiniz jitter örneği Voice over IP'de kullanılan jitter ile aynı mı?
Tam bilmiyorum Voice over IP'deki jitter'ı ama yani bir rastsal bir gecikme eklemek diyebiliriz jitter'a yani. Öyle özetleyebilirim.
Okay. Tamam, süper. Çok teşekkürler. Başka bir soru şu anda gözükmüyor. En azından ben göremiyorum. Hani sorularınız varsa YouTube'da limit var bildiğiniz üzere. Hani atabileceğiniz, yazabileceğiniz şeyin karakter limiti olduğu için belki soramamış olabilirsiniz. Discord tarafında hani çok daha rahat olur. O tarafta sorularınızı bekliyoruz. Çağdaş zaten var. Çok teşekkürler Çağdaş tekrardan.
Çok sağ olun Serhat. Görüşürüz.
Görüşmek üzere. Arkadaşlar yaklaşık 1 dakika kaldı. Aslında çok fazla yok. O yüzden ben bir sonraki konuşmaya geçebiliriz. Şimdi Nicolas, Türkçe devam ediyorum ama İngilizceye döneyim. So we are moving on to our next talk. So Nicolas, hopefully will be here for the Q&A, but he sent the recording of his talk. So I will be playing it now, and even if he cannot join us for the Q&A, he is already in the Discord channel. So if you have questions, feel free to ask him. So I will right now share his recording. Share audio tab. share.
Hi, folks. Thanks to be here for this talk about your own Kubernetes operator, not only in Go. I'm Nicolas Fränkel. I've been a developer for 20 years, and now I'm a developer advocate. Throughout my career, I was always interested in better and faster delivery. And since a couple of years, I'm quite curious about Kubernetes. I work for a company called Hazelcast. Hazelcast provides the Hazelcast platform, which has two main features. The first one is an in-memory data store, and the second one is a stream processing engine. But today, I won't talk about Hazelcast. I will have a look about a bit of Kubernetes. And I assume that you know that Kubernetes is a platform where you can deploy containers. And in general, people introduce Kubernetes with this diagram. And here we can see that there is a central piece, a central component called the API server, and it's the proxy by which everything happens in Kubernetes. And mostly it's the proxy with which we interact. So whether you are using kubectl or something else, everything goes through the API server. And how does it work? Well, you probably are used to using kubectl, at least to play with Kubernetes, but did you ever try to get some verbosity? So let's try to do it. I have launched a Kubernetes cluster. Here I'm using Docker Desktop, but it will work with anything. I will just kubectl get pods, but I will add a verbosity level of 6. And here we can see that to interact with the API server, the kubectl command actually sends HTTP requests. And even better, if we add the verbosity level, if we increase it, we can see that it sends JSON and receives JSON payloads. So nothing magical, is just like the API server, is just a sort of a web server. It receives the request, it responds. And now we have this concept of controller. And actually, you probably used already some of them. Controllers are just control loops. With a controller, the controller will watch the states of your cluster, and it will query the desired states, and between the two, if there is a gap, it will try to reconcile the actual state with the desired state. The most well-known controller is, of course, the deployment controller, meaning that when you use a deployment, when you deploy, let's say, 3 replicas, if you kill a pod from this controller, from this deployment, then the controller, the deployment controller, will regularly watch it and say, oh, there is a missing pod, I need to recreate one. This is just very simple stuff. And now the question is, where are the controllers located? Because probably the deployment controllers are run inside the cluster, and it's correct. All out-the-box controllers run in the control plane. But if you create your own controller, actually, you can run them from anywhere. You can run them inside your cluster. You can run them outside your cluster. And the title of the talk is a Kubernetes operator. And then we add one layer, one semantic layer, is that an operator is a specific controller. And actually, the operator operates on a custom resource definition. So it's a controller, but instead of operating on my pods or deployments or whatever, it operates on a custom resource definition. And a custom resource definition is a way to extend the Kubernetes model. So if you want to add the notion of application, the notion of core, the notion of customer, the notion of, I don't know, inside of Kubernetes, you can like create your own resource through a custom resource definition. So here, for example, I've created a custom resource definition, YAML file, and its name is Hazelcast. So I can create a new Hazelcast. Whatever that means, there is probably something that is specific to you. And of course, I know what is a Hazelcast instance. If you never played with Hazelcast, you don't know about it. But here, anyway, I can extend the models. You can think about a custom resource definition as sort of a new table inside a normal model. But of course, it's not like this, but this is quite similar. So again, controller is just a control loop, and an operator is a control loop that operates on a CRD. So if you know how to do a controller, you know how to do an operator. As I mentioned, the technology stack of controllers is just to talk to the API server. And we have seen that to talk to the API server, you make HTTP requests and you send and receive JSON payload. So it's just like simple REST. So you can probably create your own controller using just shell scripting. But most people, they use Go. And yes, Go is very pervasive in the Kubernetes ecosystem. Most probably because Kubernetes itself is written in Go. Well, it has been rewritten in Go from Java. But I dislike Go. And the reason for that is error handling. I don't have other trouble with other languages feature, but as a developer who programmed mainly in Java in 20 years, I've been used to like separate the nominal path, what the code should do, and what it does when there is something unexpected. And if I don't care about errors, I want to understand what a piece of code does, then I can focus on the nominal path. But with Go, it's not possible. Every time, every function, if something might go wrong, it will return an error. And it's up to the developer to check if the error is nil, is null, like if there is no error. So you can write stuff like that, which, in my opinion, makes it very, very hard. And there is this joke commonly found on the internet that if you are a Go programmer, you probably have this key on your keyboard. And you can say, hey, but you can learn Go. And that's true, I can learn Go. Actually, I try to do it. But I believe that's not the path that everybody should take. Of course, you can learn it. But it's not only to learn the syntax. You might remember those books from like 10 years ago. I hope they are not there anymore. Hey, learn learn C++ in 10 days. Yes, you can learn the syntax in 10 days, but learning a language is much more involved than just the syntax, because you need to use the idiomatic way. I remember when I was younger, I started in Java, but at the time there were C and C++ people like coming to the Java language, and you could see the Java codes that was written by C and C++ developers, because every time at the end of the function, they set all the variables to null, because that's what you would do in C. So in Java, it's not necessary. You don't understand how it works, you will do it anyway. And then it doesn't stop at that, because afterwards, you need to understand the libraries. Like, for example, in Java, the libraries, there are many, many libraries, and some libraries, they do the same stuff. So if you want to do logging, for example, you can use log4j, you can use Apache commands logging, you can use SLF4j, and then you have log4j too. There are many, many libraries to do the same thing, and you need to understand what's adapted to your use case or not. And then afterwards, you've got the tooling, because you probably, well, I know there are some people who do, but you're probably not writing your code in Vim, in VI. So you probably are using an IDE, and you need to understand how the IDE works. You need to understand how you can like run a program, set a breakpoint, and check the state of a variable. So my point is, if you already know a language, then you should probably use it. I did this talk before, and I showed how you can use Java. But here, since I don't have that much time, I will show how you can use another language, Rust in that case. I'm a Rust newbie, I'm not a Rust expert, but it's just to show you, and besides, I won't go very deep into the language. I just want to show you how you can do the same as you would do in Go. So here I'm in my IDE, and Rust like already provides you the way to declare dependencies and to build your package. So here, for example, I've already prepared everything. I'm using logging, of course. I'm using the way dependency to talk with the server, the kube server, and also I'm using an async library, because I don't remember which one, but relies on async codes. The code itself here is pretty like straightforward, and even if you don't know Rust, here I'm initializing the log, so I rely on an existing log configuration file. Then I will create a client to talk to the API server, and then I will use like something called an API, and it restricts the resources to a dedicated namespace. And then from this namespace, I will list all the parts. And well, if I try to run this program, you probably understand what it does. It will just like go through all the pods of the kube system namespace and print them in the console. And that's done. So let's go a bit further. Now we know how to talk to the API server. It's just like REST code, and we are using an API that already like does it for us. We could go like on a lower level and just really use like HTTP commands, but here it's already done for us, so we can already do something. And now if we run this code, it won't work because the program will run and it will stop. And so Kubernetes will detect that we must restart the pod. That's not what we want. What we want is to do that in a loop. So of course we could do that in a loop, but there is an API called the Watch API that does it for us directly. So here it's a bit more involved. So instead of listing, we are watching. And now every time we receive an event, if the event is of type added, then we like write added into the log, blah, blah, blah. So let's try to do that again. And here you can see that I'm running this code from outside the cluster. So far, I don't do anything from inside. Again, it's irrelevant. As long as I'm able to talk to the API server, that's perfectly fine. And now, poof, it works. And here I'm in the kube system namespace, so I don't want to delete anything. I also don't want to add something, but everything there is a change, it will write into the log that there was a change. Pretty cool. But we can do better. Actually, what we can do is we can like do some, it's not real sidecar. Actually, the sidecar would be to be in the same pod here. Every time we deploy a pod in a dedicated namespace, which is actually a REST operator namespace, we'll deploy a new pod along it, which is a Hazelcast pod. We don't want to do anything with it. We just want, it's just for fun. So now when we add something, we will do the deployments, and we first check that it belongs to the correct namespace, and then we can check that it's not a sidecar, because if we don't do it, then you will have one pod, then you will deploy a sidecar, and then the sidecar will be a new pod, so we deploy a sidecar of the sidecar, and it's never ending. So we must check that it's not a sidecar. We must check that it doesn't already has a sidecar, if it can happen, so just be sure. And if it doesn't, then we create the sidecar. And in the case it's deleted, we must recreate the sidecar. So again, I don't want to delve into all the Rust codes. I just want to show you how it works, and let's do it. So now I will create a new deployment into this namespace, just stupid one. And you see here, I have deployed a deployment and a pod called hello whatever. And then like directly, I have the sidecar alongside it. And if we delete the deployment, of course, the hello world is not meant to run normally. And we can check that it gets deleted alongside, yes. So here it deleted the pod, and now we delete the Hazelcast sidecar. Again, it's not a real sidecar because we made the main hello pod the owner of the other one. So it's up to Kubernetes to delete it. Finally comes the time when we decide that it might be a good idea to deploy this, not outside the cluster, but inside the cluster as a regular pod or deployment. But here we will set it in the scope of the pod. Next step is to actually create it. So here I go through several steps. If you want to check the GitHub repository, it will be at the end of the presentation on the last slide. But I directly present you the from scratch Docker file. So we create a Docker file. Here there is like a Rust image builder. It's a multi-stage Docker build file. So we first create the binary, and then from scratch, we add the application we just created in the previous step, and we also copy the log configuration file. If you don't have anything here, you don't need to copy it. And then here, it's very simple. And if we like check the final results, like Docker images grep Rust, here we can see that it's like 17 megs. And probably in Go, you wouldn't go much smaller, if at all. We must just be careful that when we do that, we must give the pod authorization because to talk to the API server inside the cluster is actually like dangerous stuff to do. You don't want every pod to be privileged to do this. So here we must create the correct cluster role, and we must create a service account, and we have a cluster role binding that uses the service account and the cluster role. And finally, the pod, we must use a dedicated service account, the one we've created before. So this is something to remember when you are outside the cluster. It depends, but here I'm using Docker desktop, so it's just as if I was using kubectl. I have all privileges. So let's try to deploy this. K apply F, and it's called deploy. K get pods W. And here you can see that it's already working. And the reason for that is it deployed the Rust operator pod. And when it has been deployed, hey, there is a new stuff arriving. And so the pod itself has created its own sidecar. And likewise, we can remove it. K delete pod Rust operator. And it will, again, because of ownership, it will delete the sidecar. And that brings us to the end of this talk. So in this talk, I've shown you what are controllers, just control loops, like nothing really mind-blowing. We check the current state, we check the desired state, and we try to reconcile the two. I've shown also you that operators are nothing mind-blowing. It's just like a specific controller, a controller that operates on a CRT. So here, this is not an operator, this is a simple controller. No tech stack is actually required. You don't need to use Go, you don't need to use a library. You can, as long as your tech stack can make HTTP requests and is able to send and receive JSON payloads, then you can use whatever you want. And I would probably advise you to do that, because learning a new language is hard. Go, despite all proofs to the contrary, in my opinion, is quite hard to read because of this error handling. When they add a better error handling, I believe it will be much easier to understand. Of course, your language stack probably has limits. Like, for example, if you use Java, that means that you will use the JVM. And if you don't want to use the JVM, then you probably need to do some ahead of time compilation, where there are ways to do that. But some languages, some stacks might be better for running inside a container, especially if you want to kill the pods and to restart them every so often. So startup time might be important, so be very careful about that. But otherwise, yeah, just use the language you are most comfortable with. Thanks a lot for your attention. You can read my blog, you can follow me on Twitter. More importantly, you can get the repository, so you can check the code here. And here is the blog post that I wrote about it, which basically is the same as this talk, but in a like perhaps more detailed way. I also did the same for a JVM controller. So if you're a Java developer, you might check that. And though this talk was not about Hazelcast, you are welcome to join our Slack and to get some free training. Thanks a lot for your attention, and I wish you a good day.
Hi again, everyone. Thank you, Nicolas, for his presentation. I think he is in Discord right now, so if you have questions, you can ask him there. You can find the Discord link on the YouTube description and join us. So we will see you after lunch at 1 p.m. See you. All right. Hello, everyone. Welcome to our afternoon sessions. So we have Rosemary here on the backstage. So I'm adding Rosemary to live stream. Hi, Rosemary. How are you?
I'm doing well. How are you doing, Serhat?
Thank you. We are doing great. We had a lot of great sessions, and we are excited to see more of them. So happy to have you here. Let me check the background. Okay, everything looks good. So Rosemary from HashiCorp will be talking about secrets management. So I will leave you the floor and add your screen here and remove myself. Thank you.
Thank you very much. All right. Well, thank you everyone for joining. It is morning here for me, so it's a little dark outside. Don't be alarmed. Hopefully there's enough lighting and my audio is okay, but do let me know in the Discord if there are any issues. Welcome to Secrets Management for Development and Operations. I think that this is a topic that is very near and dear to me, mostly because we always talk about protecting our secrets and being secure, but we don't talk about the after part of it, which is how do you use a secrets manager as someone who wants to protect your secrets? Secrets are passwords, API tokens, certificates, or any other sensitive information that is used to access something else. And we have a lot of them in our companies and in our technologies. So whether you're using Kubernetes and you're using a token to authenticate to the Kubernetes API, or you're using a database password, they're everywhere. And that's the one way we kind of protect our information. Now, there are many other ways that we do it, but I would say it's probably the primary way that we protect information that we transfer. Okay, so we get really excited about the prospect of a secrets manager, right? We introduce something in our company that helps ideally protect all of this sensitive information. And the idea is that we use a secrets manager to help us securely access, store, revoke, and rotate any secrets that we have. This is actually very important because you want to make sure you're centralizing some of your secrets management so that you can understand who is accessing it, how long the secret has been around, and whether or not you need to rotate it. So you need to create a new one and delete the old one. I won't go too much into the benefits or why in particular you need a secrets manager. I think part of this is a whole other talk and a whole other discussion. But what I find the most common when you start to adopt something like a centralized secrets manager to manage your sensitive information for access is that it changes the way how you think about secrets and how you use those passwords, certificates, and more. Immutability, which is the creation of a new resource rather than updating in place, and ephemerality, which is the changing of an infrastructure resource, is something that we're talking more and more about. But when you talk about immutability and ephemerality in security, it changes the way you develop and the way you operate. Telling someone that they need to change their password every 30 days on their Windows machine is often a source of frustration. And imagine if you had to do this across any applications, delivery pipelines, infrastructure, and more. It's friction that sometimes we don't want. So the question I'm going to answer today is, how does a secrets manager affect my development or operations workflows? It doesn't matter if you're working on an application or you're working on your infrastructure. At the end of the day, ephemerality and immutability that your secrets manager will bring to your secrets will affect development and operations workflows. And more importantly, I want to answer the question, what do I need to do to adopt a secrets manager? It's easy to build the cluster. Well, actually, it's not easy necessarily to build a secrets manager cluster, but you might start to build a secrets manager cluster and realize, wait, I don't know how to get it adopted across my company. So we're going to answer some of the knowledge you'll need to get it adopted. If you ever have any questions about this talk and others, you're welcome to reach out to me. I'm a developer advocate at HashiCorp. Today, we're not going to be really talking much about HashiCorp Vault. I'm talking more about the patterns that you might find, and they apply to a number of secrets managers outside of Vault as well. Okay, what do you need to know? You need to first organize your secrets manager, compare patterns for secrets injection, and then you need to think about how you add your secrets manager to your delivery pipelines, infrastructure, local development, and applications. All of these things are very, very different in some ways when you add the secrets manager or a centralized secrets manager to your workflow. So we'll start with the first and then we'll go through the rest. So let's start with organizing your secrets manager. This is for someone who might be administering to their secrets manager. Imagine if you're a development team and you need to store your database password in a secrets manager like Amazon Web Services, Azure Key Vault, any of the above, right? You need to organize your secrets manager in a way that you can read secrets from it. But you can't just put the secrets in there. If you want to scale this across your organization, and if you want to try to collaborate on this more effectively, you need some practices set in place. The first is authentication. Try to use built-in protocols or methods. It's easy to use username and password for a secrets manager just because it's out of the box default. But instead, try using the built-in authentication. Most secrets manager have some protocols that they support that handle the authentication of a target that needs the secret to the secrets manager. So when you authenticate, consider using OIDC or JOT. Those are very popular right now. Kubernetes is effectively JOT. So I think the cloud providers have their own. If you're using Amazon Web Services, this would be AWS Auth, and other services or providers might have their own special token system. So when you are trying to set this up for yourself, whether it be for another development team or for your operations team or for your general platform team, you want to make sure you're using a built-in authentication protocol. Don't try to use username and password. That doesn't necessarily scale across applications, local development, pipelines, or even infrastructure. The second thing you need to do as a practice is implement some form of least privilege access control. Divide this by business domain, environment, and usage. We talk a lot about modularizing our infrastructure and trying to break it down by domain, business domain, as well as environment. And this is the same rule that you should apply in your secrets manager early, because if you do it later, it will take time to fix it. So when you try to organize your secrets manager, try to localize the secret right at that path. So whether you're using sort of your cloud secrets manager or otherwise, you should be able to divide access to certain secrets. So maybe you allow read for business dev secret, and you allow read for business prod secret for target prod, target dev, and you allow administrators, human administrators, to write to anything in business. But you don't allow, let's say, administrators to edit everything in prod, for example. Or maybe you don't want to add the target prod to the business prod secret. And so all of these pieces need to be in place in order for you to implement a scalable and secure secrets management solution. The other thing that you need to consider is a reasonable TTL, time to live. Most secrets managers will have some form of tracking the time to live for a given secret. So how long that secret has been around in that secrets manager. You don't need a database password rotated every 5 seconds. Someone did ask me that once, and I will tell them that it probably wasn't the best practice, because in some ways you don't necessarily need to revoke or have that level of ephemerality in your database password. You don't need it so temporary, maybe 24 hours, but not 5 seconds. And so my general rule of thumb is that when you have a target that authenticates to a secrets manager, the target needs to communicate with the secrets manager at least half the interval of the time to live. So if your database password is rotated every 24 hours, set that to about 12 hours. Set the target to ask the secrets manager for that new secret every 12 hours instead, right? Don't expect the target to renew at the 24-hour mark, right? That timing might be off, and then your target will no longer be able to access that database anymore, for example. So make sure you set a reasonable time to live, enough that your target can authenticate and retrieve the new secret. Okay, so these are the 3 main practices that when you start to administer and organize your secrets manager, you need to know. But what about comparing secrets injection patterns? There is a question about how you get your secret from the secrets manager to the target. And that's what I was showing before. Most of what we consider in secrets management is a direct injection, secrets injection. So this uses a script or a client library on the target to authenticate to the secrets manager as a first step, and then get the secret at the second step. So the authentication and the retrieval of the secret, which is then injected into the target, is something that is directly done. Now, there are some benefits to that. You have a lot of control from the target. Target can be an application. It could be a delivery pipeline. You have all the control there to access the secrets manager, as well as any retries, any behavior handling you want to do. However, there is actually a second way you can do this, and in some ways it may or may not be worth doing or worth investing the technical effort to implement this kind of pattern, and that's the sidecar pattern. It's more common now in the container space, but there's actually a reason to do it for, let's say, non-containerized workloads. So what you do in the sidecar pattern is that you run a separate asynchronous process. That asynchronous process authenticates to the secrets manager, gets the secret at that path, and writes it to a file. Then the target consumes it from the file. The idea is that the sidecar is constantly processing new changes to the secret in the secrets manager and writing it to the file for the target to consume. You can do this in containers, for at least if you're doing something in Kubernetes, this might be something that's a common pattern. But you can do this for non-containerized workloads. Imagine running a separate process on a virtual machine that is retrieving that information and writing it to a file for consumption. So both ways work, but they also depend on your use case. And we'll go through some of these use cases, and I'm going to apply the patterns as well as the organization that I talked about before to some of the use cases you'll find. The first is delivery pipeline. I think this is the one, the question I get the most, which is how do I use my secrets manager in a delivery pipeline? Most of the time, you're using secrets for deployment in delivery pipelines. You are not using them as application runtime secrets. Some pipelines do use a sort of a declarative way of sending the secret for applications to use, but for the most part, you're using secrets for deployment specifically, like authenticating to AWS or deploying an application to Kubernetes. So the direct injection is usually the pattern to choose. It's very difficult to do a sidecar in delivery pipelines unless you're managing your delivery, your CI framework end to end. So direct injection often involves a stage to get secrets from whatever environment you need. In this case, let's say I need to retrieve it from development environment or development secrets manager. I'll retrieve it from the development secrets manager, deploy something to development. That could be an application or infrastructure. And then I run the integration tests. Typically, integration tests need a secret. So you want to set the secret retrieval or secrets injection stage at the very beginning. Then you repeat the process for production. One thing to consider is that some people separate the secrets manager for development and production. So they may use one instance for development and one instance for production. This is something that's more common if you're using something like AWS Secrets Manager. You might have one account for development and one account for production. If you're using something like Vault, you might have a cluster for development and a cluster for production. However, you can also separate by path. This is something that you can do for more granularity. If you don't have multiple secrets managers, you can separate them by API path and use API authorization. The other thing that you need to consider is only allowing certain CI runners to authenticate. It's very vulnerable. A CI runner is very vulnerable when it is accessing the secrets manager. You may not want every CI runner with direct access to that secrets manager. You might choose a CI pool of runners that is tagged to access the secrets manager, whether they're on separate networking, they have additional permissions, or they have built-in authentication protocols to authenticate to the secrets manager. Let's talk about infrastructure. Infrastructure has been a bigger question, I think, because you're defining secrets as code. We are being declarative about, let's say, a database username and password. We are declaring that the database username and the database password we want to log into the database with in our infrastructure as code. Now, this is optional, but otherwise, how would you log in? And the answer is, well, you don't. You need some kind of bootstrap password at some point. You need one that will get you into the database before you can do anything to the database, at least in most cloud platforms. And so this brings up a very interesting question. Is this secure? Is it secure for me to pass my username and password, knowing that it may or may not be stored in state? Now, in the case of Terraform, which is what I'm showing on screen today, this may be something that is in state, right? It is actually plain text in state, and you should encrypt your state as well as control access to it to prevent someone from retrieving that information. However, there is actually a way to think about this. And it is one that I think causes a lot of brings a lot of questions for people when they do it. The first is that when you start your infrastructure as code, you might get a bootstrap password and you retrieve that from Secrets Manager. Then you inject it and pass it to infrastructure as code. You could do this as part of your pipeline. The infrastructure as code configures the database based on the bootstrap database password you previously stored in your Secrets Manager. Then you, outside of infrastructure as code, rotate your bootstrap database password. Now, people are screaming at me, I think, at this point, because they're telling me, but Rosemary, this introduces configuration drift. My bootstrap database password in infrastructure as code is not the same as my bootstrap database password in reality. Well, you have to configure configuration drift. You have to think about configuration drift versus security. It's always a balance. If you have something in your system and you're trying to secure it, right, you may or may not want to store that in something insecure. So you have to think about whether or not having the changes that are happening outside of infrastructure as code will help you in the benefit of security. In addition to this, does everybody need access to the root database password? Probably not. The other thing to consider is secret storage in infrastructure as code. There are mechanisms that folks are trying to brainstorm and rethink this, as well as secure them better. But in general, I try to avoid the secret storage infrastructure as code as much as possible. And if I do need to make those definitions as, let's say, a bootstrap kind of secret, I then rotate them outside of my infrastructure as code. And most of the time, infrastructure as code does not necessarily detect the difference, right? So it won't necessarily detect the drift itself. And if it does, you also have this ability to understand that, well, your secrets manager rotated it. So we'll pick up the new one anyway. Okay. Finally, the third use case is local development, and this is for retrieving secrets for testing. When you are doing local development, you might want to make calls to a database. You might want to try to test your application code or any other code that you want with some kind of environment. Okay, so one thing that you can do for local development is implement some form or some layer of secure access management. And the formalized term for this is credentials brokering, which is a mouthful. But basically, credentials brokering comes down to getting the secrets from a secrets manager and then logging into the database with those credentials. By adding some kind of secure access management a layer and using credentials brokering, that allows someone to use secrets from the secrets manager in some ways a less frictioned way, right? So you don't have to have two steps to go get the credentials and then log in. Instead, you have an access management tool that brokers the credentials for you from the secrets manager to log in. So it's automated. You can use your own tool. There are a number of folks who have written their own tool, for example, for Vault. Boundary, for example, HashiCorp Boundary will do this. But in any case, most organizations start to offer some layer of credentials brokering and secure access management to handle this for you, so you don't have to think about it. Do consider tracking human versus service access, right? I mentioned before that there's the delivery pipeline, and there's also the infrastructure use case. You have to track and separate whether or not a human is accessing the secret, or one of those delivery pipelines or infrastructure as code pipelines is actually accessing the secret. Tracking and auditing the two will help you understand what is happening, who's accessing the secret, and whether or not there may be a malicious actor in your system. Evaluating the time to live for development testing is more important than I think some of the other use cases. While the other use cases are very important to think about your secret time to live and how long that secret lasts, I think in this particular situation, you have to decide whether or not people need, let's say, a time to live of 1 day and they renew their credentials every day, or they're doing prolonged development testing and maybe need 7 days, right? So you have to balance the interest of the two. So this is more important, I think, for this use case than the previous two. So finally, let's talk about applications. I think this is the one that we don't talk about as much just because it's not entirely clear. Applications need secrets while they're running. So this is a more typical use case is an application accesses a database. How does the application get the database username and password? Well, there's two patterns, right? And this is where this direct and sidecar pattern come into use. So the direct pattern means you start the application uses a client library to get the secret. They retrieve the secret from the secrets manager, and then anytime there's a new secret, they restart the application. This is one of those things that you have to think about very carefully. If you are very good at building libraries with retries, building libraries with separate threads, implementing some kind of application reload, handling connection failures to secrets managers, that is perfectly fine. This kind of control in your application code means that you declare your interaction with the secrets manager very, very, very in a code-oriented way. So it's very familiar often for those who are more organized around software development. In some frameworks, this is a little bit easier. And if you do this in Golang, which is all of the tooling there is available for it very easily. The two questions I get in terms of the application frameworks are for Spring Cloud, so Java and .NET. If you do this in Spring Cloud, there is a Spring Cloud Vault configuration you can add to your bootstrap.yaml. This is an example of that. And this, for example, connects to HashiCorp Vault and retrieves the secret information and injects it for you as part of MySQL, the MySQL configuration and the MySQL connector. So much more convenient in Spring. And .NET is more complicated. In .NET, you have to add a configuration provider, and the configuration provider needs to have some kind of retry handling. Once it has the retry handling in place, you need to add it as an extension. Once you add it as an extension, then you can inject it to your application on startup. There's also the sidecar process. So remember we talked about the pattern of using the sidecar process to retrieve information from the secrets manager and write it to the configuration file. In this case, you start the application, and the application reads it from a configuration file. If you're familiar with the Spring suite of tools or .NET, in the Spring suite of tools, you might just decide, let me render this to config.properties or bootstrap.yaml. In the .NET space, you might consider appsettings.json. Basically, that configuration file stays about the same as what is native to the framework. If there's a change to the file, you restart the application. Some frameworks support a hot reload in that once you set that to true, if there are file changes, the framework will detect them and reload itself. So in this situation, there are some benefits and there are some problems with this. You might have to configure a separate process, and configuring a separate process may be difficult depending on your secrets manager as well as your environment that you're trying to add the process to. You also have to think about access control to file. Not everyone should be able to read from this file, just the application should be able to read from the file. And also, as I mentioned before, configure your application reload if the file changes as well. So those are the main things you need to know if you are bringing the secrets manager to your company and saying, hey, we should use it, or you are someone who's responsible for consuming from a secrets manager and you want to make sure that you're implementing the best practices as you do it. In each of these workflows, it will change and affect how you're doing your development and operations over time. And as you try to build more on your secrets manager, you might find it easier to establish these patterns earlier. Okay, so if you would like to learn more, I have a number of resources on here with different details. If you're interested in delivery pipeline, you can dive further into it. I show at least a more technical deep dive of how you retrieve it and some injection patterns in a much longer talk. There's also a secrets management for applications deep dive. So this is more specific to .NET. But the same principles apply to Java as well as some of the other application frameworks, depending on which one you use. And there are some tutorials as well as on application libraries, client libraries, and Kubernetes and Vault. I get a number of questions about Kubernetes in particular and how secrets management changes for that. And that is in some ways separate mechanisms. Kubernetes tends to favor more of the sidecar approach. So you're welcome to check out those. With that, thank you very much for having me. And if you ever need to reach out, you're welcome to drop a note to me at that handle. And you can find the slides at my personal page. Serhat, I think
Sorry, I was muted. Yeah. So thank you very much for spending your morning with us, Rosemary. It was a great talk. So if you have time, we've got only a few questions. So one is, when accessing secrets management as an admin, Turhan asks if multi-factor authentication or two-factor authentication works, because he said you mentioned you should not use username and password authentication.
Yes. So if you're using OIDC, for most providers, if you're depending on what provider, identity provider you are using, if it is Okta or if it is the cloud provider like Azure, AD, OIDC, if you have OIDC plus 2FA or multi-factor authentication, that is a good way to manage your human user accessing the secrets manager. For example, in the case of applications or delivery pipelines, you may not want to turn on 2FA for that. There are other mechanisms like tokens, more temporary tokens that can be issued, and then you re-authenticate. To be honest, I don't know how exactly which cloud providers do not offer 2FA or through a identity provider with OIDC. So keep that in mind. But if you have OIDC plus multi-factor or 2FA on top of that identity provider, it should work.
Thank you. There is another question. This is the only one left. So is there any built-in or recommended user admin roles to configure in deployment pipeline applications infrastructure?
Yeah, so I think that there are a few that you need to consider. There are not any built, at least there are not any that I know of that are specific to the use cases. Most of them are asking you to configure your own policy for API authorization to the secrets manager. So you have to decide. What I tend to do is I nest the secrets, the bare minimum secrets that any of these use cases need. So we can take the example of a deployment pipeline. One of my teammates, Kareem, asked me the other day, what is the minimum secrets engine path that I need for my pipeline to get secrets from AWS? I want AWS access key and secret key. And so we were able to narrow down the path for the secret to a static secret, to AWS, and to the name of the pipeline or the name of the workspace, for example. So in the case of pipelines, I usually name it after the pipeline. So I know which pipeline is running, and then the development environment or production environment. So I know which stage. For applications, usually applications need a couple of secrets and not more than that. Tends to be database, or if you're doing encryption in transit, usually that is the encryption key of some kind, and certificates. So those are usually the ones that you might nest if they're shared across different applications. Like a certificate may be shared, right? You probably want to nest that at a top level. So those user admin roles would be aligned with those API paths. For admin in general, human user access. Most should have write access to development secrets at least. In production, you may only want a few people with write access, or grant temporary write access during a break glass scenario. So use that more conservatively and make sure you're always checking for least privilege.
Right. Great response. Very detailed. Thank you very much, Rosemary. I guess that's all. There are a lot of thank yous and highs in Discord and YouTube. I guess people really like your talk, and we like your talk. Thank you very much again for spending your morning with us. See you soon, I guess.
Thank you very much, everyone.
Bye. So I guess we don't need a break. Josh is here. So I will add Josh to live stream, and we can get started on the next talk. Hi, Josh. How are you?
Good, mate. How are you?
Thank you. We are great as well. So can you share your screen and
I can definitely try. Let's make sure this.
Right. So Josh is gonna talk about service level objectives and lean product development through service level objectives. And if you were here with us for the keynote, Andrew also is a great advocate for service level objectives. So he mentioned that concept. So hopefully you will have a better understanding of what that means. And Josh will probably do a deep dive. On the topic. So.
I'm curious if my definition is going to match. Hopefully it does. Otherwise, I think I have a problem because he's more likely right than I am. But let's see how this goes. It should be fun.
All right, awesome. So I will give you the floor to you, and good luck.
Awesome. Thank you very much. All right. Happy Saturday, everyone. I kind of feel bad because it looked like Rosemary was up a lot earlier in her day than I am. Yet I'm the one with a giant can of caffeine next to me because that's the only way I can function. But hey, we go on regardless. Okay, so this is going to be a bit of a 25-minute buzzword bingo, and I kind of apologize for that, but it's conference circuit. Sometimes you have to do it. But effectively, we're going to be talking through lean theory, a passion of mine, product development, and SRE, and we're going to try and put them all together in about 25 minutes and show how by combining the three, you can drive some really interesting and impressive outcomes. I'm just going to kick off, as I do every talk I ever do, with the key takeaways. So I think it helps frame it, and hopefully it helps people remember, and hopefully it means that you're more interested in the talk as we go along. But the first one is that eliminating waste drives better outcomes. Anyone who has spent time in lean circles knows that's also almost axiomatic lean, or at least one part of it. Secondly, that implicit expectations exist, and hopefully you will see what I mean by that as we go through. And the third, one of the powers behind SLOs and service level objectives is that you can convert those implicit expectations into concrete outcomes that drive the way you build products. I have to do an obligatory about me slide, for which I apologize unreservedly, but just quick 30 seconds on myself. I'm the AWS practice lead at Contino. We are a global digital transformation consultancy headquartered out of the UK, which is where I am right now. I'm an AWS APN ambassador. I'm a HashiCorp ambassador because I like the sound of my own voice just a little bit too much. And I'm a bit of a lean junkie. Ever since I came across lean theory about 5 years ago, it's been the way I look at the world for better or worse since then. So maybe I might get some converts here. We'll see. So the story and example I'm going to use today is a real one from what I did with a client towards the end of last year. I'm going to be talking about AWS landing zones. Now, I know not everyone here is probably spends all their day in the cloud like I do, but when you talk about landing zones, it's the framework and governance and everything else that underlies the scale of your AWS or GCP or Azure environment, right? So account vending, access provisioning, kind of ever so slightly piggybacking off Rosemary's talk before, security guardrails, CI/CD, all that kind of stuff. So how you can build out all these services to enable all the delivery teams in your organization to move really quickly, because you've taken kind of that common substrate underneath and gone, that's what we're going to do, and we're going to do that really well. One of the reasons I really like this when you talk about SLOs is where SLOs came from were super high throughput systems at Google and around the place, right? With millions of requests a day, all that kind of stuff, maybe an hour. I'm not going to be using an example that's that high throughput, but I still want to show the power of taking an SLO approach, even in low throughput systems as well. And we're going to focus in a little bit, not just landing zones in their entirety, but we're going to focus on account vending in landing zones. So how do you give a team a new AWS account, a new GCP project, a new Azure subscription? How do you do that? How do you do that well? How do you do it quickly enough? When you're building that function out, what does it actually have to look like? And how do you know you're doing that well enough for the business? So, I mean, I think everyone's going to be across user stories because they are ubiquitous, right? And, this is just like a classic user story template. As a development team, I want to be able to provision AWS accounts so I can deploy my application, right? I think everyone can understand that, but in everyone's head, the understanding is maybe going to be a little bit different based on their experience, based on what they've done before and everything else. We all get the general concept, but it's not really all that specific. And I'm going to come back to this a few times as we go along. Now, 25 minutes, even if I was to spend it all just proselytizing lean, wouldn't be enough time. But I'm just going to narrow down on the concept of waste in lean. And even in then, I'm going to narrow down a little bit further again. When you look at lean, it outlines 8 kinds of waste you can have. When you're trying to deliver something to a customer, there are 8 different kinds of waste you can have in there. And anything that is wasteful, as the name would very much imply, is not adding value, right? So these are the 8. I would say in initial, when it came out of Japan and Toyota, there was only 7. We've added an 8th in the Western world recently. But you have defects, pretty self-explanatory. Overproduction, making too much. Waiting, I think we all work in teams where you give something to someone else to do and you're waiting days or weeks. Like, that's waste from being able to deliver on what you want to do. Unused talent, which is kind of the most recent one added. Extra processing, transportation, motion, inventory. Again, I don't have time to go into all these today. There's a lot of really good books on lean software development. I highly suggest going and reading them. But for today, I'm going to talk about extra processing specifically. And this is building goods of too high a quality than what is absolutely required, right? If you just need a car to get from A to B, you could get a Lamborghini to do that, right? You probably don't need to do that. You're wasting a lot of money if all you're worried about is getting from A to B, right? You can buy a cheap car that will get you there. And the same thing happens in software and product development, right? Gold plating is often the term used for you build things, engineers go and build something amazing when something good would have done, right? And when we get back to the user story here, there's not really any notion of quality here. There's no notion of what is good enough. There's no notion of really much anything. Like, I can do this a million different ways, or potentially an infinite number of ways. I can invest a lot of engineering effort to get this really, really, really fast. I can get someone to just go through all the account requests every week and just do it manually. I have options here on how this can actually be done. And really, the question, and I already said it, but the question we'll want to try and answer is, what is good enough? What is good enough that we can, it's in production and it's doing a good enough job for us? And before you can answer that question, there's another question. I swear this doesn't go forever, but who defines good enough? Who gets to say when the feature is good enough? Now, some of you may say product owner, and I get that, but it's a little bit more nuanced than that, right? The product owner is effectively an arbitrator for other people's opinions of what good looks like. They're very rarely making unanimous decisions in a vacuum. I argue if they are making unanimous decisions in a vacuum, that's a problem. And really, when you get down to it, product management is really tension management. You're trying to manage all these different sources of tension. So between the product owner and the engineers in the team, because the product owner wants everything he can get out of them, the engineers need to pull back and go, well, no, this, we can only really achieve this much, right? You've got it between the team and their dependent teams. So if you're a delivery team and you're working with a platform team that's building out a landing zone, right, there's some tension there. And the one I'm going to talk about today is between kind of delivery and consumers. So as a delivery team and what the consumers want, you don't always want the same things. And it really comes down to a bit of a negotiation. I'll dive into that a little bit more in a second. Now, potentially, this might be old hat for people that got the keynote, but I'm just going to define SLOs just to make sure we're all in a common understanding. So the first one, the SLI, or the service level indicator, is your binary definition of success and failure. So given a, in a classic web request scenario, if it's got a 200 or 300 response code, then I consider that okay. If it's got a 400 or 500, then something's wrong, right? And we'll dive into what a service level indicator for account vending might actually look like. The SLO, or service level objective, defines what's acceptable failure frequency. For every 1,000 requests, how many times can I fail and that be okay, and that be the expected outcome of the system? No system is 100% and never breaks. Actively chasing never breaking can actually be really toxic, and again, I'll talk about that a little bit more in a bit. And the third one is a service level agreement, which is the one I think most people are probably most familiar with, because generally we work with providers that provide service level agreements, right? I always use an example of AWS. Like if I go and use any AWS service, pretty much, it comes with a service level agreement. And what that agreement states is that service should be up, whatever that definition for that service is, for a amount of time every month. And if it's down more than that agreed amount in the service level agreement, then AWS will give me service credits in exchange for that. So if the service is down too much, then there is a contractual obligation for them to give me some kind of payback for that, for the service being down, right? And really at the crux of it, in order to have an SLA, you need to have an SLO. In order to have an SLO, you need an SLI. And a really common problem that I see, and I generally work with enterprises, big companies going through big transformations, and a lot of the time they may have SLAs on paper or SLOs on paper. Very rarely do they have a defined SLI next to the SLO. And it makes the SLO kind of worthless. If I can't actually determine what success and failure is, how can I say how often something's going to fail? That makes no sense to me, right? And another big problem they have, and I've coined a term for this, unfortunately, but Schrodinger's SLA, where the SLA only exists on paper, it's not measured, potentially it's immeasurable, but people say, oh, we have an SLA for this service. Where is it? It's on a page in Confluence. I'm like, no, you don't. You have an idea of what an SLA might be, but this really doesn't mean anything. If all it does exist on a web page somewhere, where someone's typed it in and what they want it to be, you may as well not have it in the first place, right? You can't drive any decision. It can't drive any behavior. It can't do anything there. It's both, you're both exceeding and not and failing your SLA at any point where you can't measure it, right? So again, coming back to this user story once more. Okay, so we've talked about SLOs, SLAs, and SLIs. But what's the SLI here? What's the indicator of success for account vending failure? And if you go out to a team that's using your AWS environment and you ask them, okay, well, what do you think? Like, well, I want my account in 5 minutes from when I ask for it, right? Because I need it quickly, because I need to be able to move fast. Now, if anyone's actually worked on an AWS landing zone or similar, you know that 5 minutes from request to fulfillment is probably insane. It's maybe physically possible. I'm not convinced it is even possible right now with the way AWS works. To go fully Australian for just 10 seconds, but tell him he's dreaming for anyone who has watched the castle. If you haven't, please do. So, okay, so that is what the customer might send. And this is where I come back to this tension, right? Just because the customer says that doesn't mean it's what we have to deliver, right? Because that's not possible. So we'll come back with something, right? As the team, we'll come back with, well, how about a week? What if it takes us a week? Because in my mind, I can get this done with very little engineering effort, and I can just have someone go and click through and create, because it doesn't need to happen that quickly. The problem with this is now the teams might get bottlenecks on us. If they have to wait a week for an account when they're trying to stand something up, that waste of waiting is now getting really real. Like they're having to wait 5 days for us. That feels a little bit too long. And at the end of the day, what you'll do is you'll end up with something somewhere in the middle. It's a negotiation, right? And this isn't about, it's, the nice way of negotiating where you're trying to find a win-win. What works for both sides? What's reasonable to implement and still enables the business? And this is an example of exactly what I arrived at with a client. For reference, this is 100 times slower than the initial request of 5 minutes. Not that the 5-minute request was legitimate, but I could definitely see it happening. And it's 5 times quicker than what we came back with. So we've ended up somewhere in the middle. And this is something now we can kind of move forward on, right? And one way I like to look at SLOs is using SMART goals, because an SLO is a goal that you're trying to hit for service. And I know, at least in my experience, SMART goals come up every quarterly review, OKRs, personal growth, career growth, and businesses, right? But I quite like it for this as well. And if we kind of step back to the definition we have here with the SLI, it's specific, it's measurable, it's relevant, and it's time boxed. But the one thing we really haven't talked about here is attainability. Like, yes, we think we can get it to the point where we can vend an account in a day. How often do we think we can do that? How often are we allowed to fail? Because without room to fail, you have no room to experiment, no room to grow, right? When I talk about going for 100% can be quite toxic. If you do not have room to fail, you don't have room to experiment, and it ends up being really bad for the system because everyone gets too scared to touch anything. And over time, due to entropy, the system ends up failing anyway and everything blows up. I think anyone that's worked at an enterprise has seen that trajectory of system, everyone gets too scared to touch it, and then all of a sudden it will blow up later down the line, and everyone's like, well, you know, we couldn't do anything to it because we couldn't take the risk. And then it just ends up being way worse. So another common anti-pattern I see in the SLO SRE world when people are first going on that journey is they like slapping 9s on things. Because when you look at most SLAs out there in the industry, they are measured in 9s. You have 1 9, 2 9, 3, 3.5 9s. You know, I think people who've been around that space will have heard all those things mentioned, right? But an SLO does not have to have a 9 in it to be legitimate. And let's just look at what happens if we go on these, especially these lower frequency systems. What happens if we try and make it so 99% of the time we're there? So if you imagine that, okay, we're vending accounts, we want the ability to miss 2 accounts, say every month we're happy for us to not hit that target for 2 accounts because we're busy or something breaks or whatever else. We want to give ourselves that room. That means that every month you have to vend 200 accounts. I would say, and I'm pretty sure AWS would back me up on this one, that no business in the world is vending 200 accounts a month. Just no one's doing it. I've seen, you know, when you talk to AWS, the biggest amount of accounts they see at enterprise is around the 1,500 mark, and that takes years to get there, right? Like, this is insane. But we still want the room to fail here. We want something legitimate, right? If you have what's actually legitimate in terms of the amount of accounts that get vended every month. Now, this is just based on kind of my experience, and when I was at the client, it was based on some rough feel of historical data that we went to, assuming 10 accounts a month. I think over time we've kind of gone with some months more, some months less, but that's generally been a half decent guess. And with 2 failures, that gives an SLO of 80%. Okay, cool. Now instead of adding 9s because that's what everyone else does, we've used the numbers to drive what the SLO should be, the SLO that we feel comfortable about as a product team. Because really, you want to feel comfortable when you make these commitments out to the business that you can do it, and that you're happy to accept whatever maintenance burden, whatever else goes into doing this over the long term, right? When you build these systems out, they're going to live for years. So you want to make sure you get the right decisions in early. Yes, you can go and change them later. That's a lot harder than being realistic in the first place. And with this, we actually end up at an SLO, right? Account vending happens within 1 business day, 80% of the time, over a 30-day window. Amazing. Okay, so we've got our SLO for account vends. This is awesome. Okay, we're starting to get somewhere. Hopefully you can kind of feel that too, right? Like this feels better. Just quickly, a general rule of thumb in this space that every extra 9 is 10 times the investment that the previous one was. Taking a system from 99% up to 99.9% up is generally significantly harder, significantly more expensive, both in time, money, people, expertise, all those kind of things, right? When you're working on these teams, your team capacity is limited. And the budget the business has and everything else, you only have a limited capacity here. You don't have infinite people, you don't have infinite money, you don't have infinite time. And really, when it comes down to it, less is more. The lower set of SLOs I have, the more of them I can do. If I have a raft of SLOs that are conservative but still enable the business, I can support more functions and I can support a wider kind of horizontal service. If I start slapping 3 or 4 9s on everything, all of a sudden my team will shrink to focus on that one service because that's all we can support. And it's not that necessarily one of these is wrong or the other, it depends on context, but it should be a mindful decision that you make. When you're looking at a platform team, ideally you drive the most value in the business by going wide. So you want low SLOs. If you're generating money for the business in a highly competitive market, you probably want really high SLIs, in which case you need more teams. And you need to be cognizant of Conway's law and design around that. But, you know, in a platform team, in most cases, as a product team, I want the lowest SLOs that the business will accept me to have, because that makes my life easier and gives me more room and more freedom to experiment. And in my career as an engineer, right, which of these two would I rather have? If I'm given a ticket on Jira to build out the account vending solution, if I give 10 engineers the one on the left, then I'm going to end up with 10 potentially radically different solutions with different performance characteristics that, you know, it's almost potluck at that point as to what I get at the end of the day as a product owner. If I get the one on the right, I know the performance characteristics of what I'm going to get. There may be different ways of getting there, but at least I know whatever I get is there related to what the business actually needs, right? When you get to the point, and this is when I talk about like lean product development through SLOs, if you go to the SLO first and define that first, before you build the thing, it will define what the thing is that's built and how it reacts and how it performs. And I did lament about Schrodinger's SLA right now before, and people will have noticed that by now I have not actually said anything about really fixing this problem. So I'm just going to kind of finish up quickly talking about that and what behaviors that can drive once you take it off a piece of paper. So you can't debug systems with a dashboard, right? But you can understand health of a system from a dashboard. Those are two separate things. And you can build out these dashboards using, I picked AWS services because that's where I built this one, but this is not necessarily, you can build this on any cloud, wherever you are, on-prem, wherever you are, you can do this, right? But you can build out these dashboards. And kind of the next key step is build it into your process. If you work in sprints, talk about this at sprint review. If you work in Kanban, make sure that you talk to this and this is looked at on a regular basis. Build it into the way you define the priorities for your team moving forward. Because once you have these numbers visible and readily calculated, you can use that to drive behavior. So let's just quickly step through them now. So with account vending, in this case, we've got the 80% SLO from before. We're at 95. Cool, we're doing awesome, right? Which gives us this 15% error budget. So we can afford to have quite a few accounts fail their window and be made a little bit slower than expectation, because on the whole, we're still doing what we said we would to the entire business. This then gives us freedom to, if we want to do a big refactor for something, maybe it works, but we don't like the way it works, and we want to do a massive refactor, which does come with risk. We want to add new features, again, comes with risk, but we have an error budget to draw down against here. So we can invest in risky things because we know what we've got is more than achieving what we need it to. Or you can shift the focus away and go, actually, we're not looking at account vending anymore. That's a solved problem for us. We don't care. We're going to move on to the next thing. Another thing when I talk about this error budget, and again, kind of a rule of thumb in the space, is don't let systems, this is going to maybe sound weird, don't let systems operate way above the SLO for an extended period of time. If you have, say, that account vending example, if it operates at 95% for 6 months straight without ever kind of breaking, the business will start to expect it's 95, even though you said 80, right? Humans like to draw patterns. We like to see the patterns in things, and we'll inflate our expectations to match the reality. So really, you want to occasionally break your systems to make people aware of the fact they can break and that they have to be okay with that, because that's just reality. If you have systems that never break, in the end, when they do break, it's a lot worse than systems that break occasionally and people are familiar with that. So it's a bit of a counter logical one, but it does really hold out in practice. If we talk about one where we're only just exceeding the SLO here, this is a good time to pay down debt. We want to build up that error budget, and we don't really want to put new features in here right now because that's risky. And if we start to do that, we're going to drop beneath our SLO. As much as I say you want to break systems, you still don't want to drop below the SLO, but you want to kind of tend down towards it and then back up again, just to remind people. And lastly, if we look at one where we're massively underperforming against the SLO, invest in stability. You need to fix this. This is not, well, you either need to fix it, or based on what you've learned so far, is the SLO legitimate? Is it worth the investment? Now you've been doing it for a year and you've gone, this is a lot harder than we thought it was. Maybe we need to actually renegotiate the SLO to pull it down to something legitimate, right? It's not that these are written in stone and can't be changed, but having the numbers allows you to make the right decisions. Your decisions should be data-driven, which is why I always think this is important to get the data there in a way that you readily consume. Please don't read this slide. The slides will be available after. You can go and have a look. But if you do go and read it after the fact, I'm sure these are just some example SLIs and SLOs. There will be ones on here that you fundamentally disagree with for your business or based on your experience. Fantastic. That's exactly the point. Because if I didn't put them up and we didn't have the conversation, we'd never know that we fundamentally disagreed about it, right? And instead, we're just going to work in our own spheres with our own ideas of how things should be. That's a problem. What you want is a common understanding, right? And this is a really good way to drive that. If you want to have a quick go at kind of a way of getting through to the dashboard and building events, I have a simple little demo here on GitHub you can do, which allows you to generate events for that account vending piece in AWS, all based on Terraform, so it nicely pins off the end of Rosemary's talk before. You can go and have a crack with that as well. So I'll just finish up by just going quickly back to the 3 key takeaways. So the first one is eliminating waste drives better outcomes. If you know how good a feature has to be and you build to that, you can move on to the next thing as opposed to building something that's significantly overperforms for what the business really needs. The second is that implicit expectations exist. And I hope with that table towards the end, you kind of go, well, yeah, okay, no, I had some different ideas about what's legitimate here and where we should be aiming. And the third, again, coming back to that table and the dashboarding, is if you have these SLOs, if you define them and make them concrete outcomes that you're driving towards that are known and communicated and transparent, these expectations go away, and instead you have a common understanding which allows you to move forward. And I'm 2 minutes to spare. I don't know if there's any questions, but I think I've kind of almost run to the end of time. I am on the Discord if people want to ask questions after.
It's only a minute away, so we don't really have questions. I guess there are people thanking you on Discord and here, so thank you very much for joining us today, Josh. It was a great talk.
Thank you. No, it was really, really good to be able to do this.
Thank you. We will move on to the next talk now. So see you, Josh. I will.
Thank you. See you later.
See you. 1 second, folks. So I will fix this. So I will add Laura to the live stream. Hi, Laura. How are you?
Hi there. How are you?
Thank you. We are great. So we are really excited to have you.
It's quite dark, but I'm
it's
here.
Quite dark. So what time is it there?
It is, I have no idea, 6 a.m.
6 a.m. Wow.
I think I got up at 3 to make sure I was ready for this. So cheers. I'm here.
I don't know how to thank you. So.
I just hope everybody enjoys it. That's really why I'm here. So hopefully everybody gets a little bit of something. And I'll try to remember to look at the camera, not at StreamYard again, just because I have a bad habit of looking at the people I'm talking to. So.
I mean, both look great. Don't worry about that. Like, it's nice. So again, thank you very much, Laura. So I'm gonna leave you to the floor, and I will remove myself from the stream.
Okay. Well, real quick, I'll just do a really quick introduction. Thanks for having me. My name is Laura Santamaria, and I am a developer advocate at Pulumi. I'm the newest developer advocate. So if there's questions that I really don't know how to answer, I will say so. But please do feel free to ask questions. I think it's really important that everybody gets a chance to see anything or ask me anything they really think is really important. But on that note, let's just kind of dive into it. So I'm here today to talk to you a little bit about engineering the cloud, or exploring infrastructure as code in real life. You might have seen some talks about just infrastructure as code in general, but hopefully today we'll get a chance to try it live. We'll see how long my live coding skills, my very, very rusty live coding skills, will be able to keep up with everybody. On that note, let's get moving. So first things first, I like to define what we're up to. What is infrastructure as code? Infra as code is the idea that infrastructure configuration should be treated just as you would treat your code. So that means putting it in source control, doing some versioning, using commits and reviews to update that configuration, as well as also automating it as much as possible. I'm pretty sure everyone here is familiar with the concept, so I don't want to dwell on it too long. Infra as code, though, has really shined as cloud computing has come to the fore. So it's been around for a while, but now that cloud computing really is basically the default for most organizations, infra as code is just huge. IAC, or infrastructure as code, we often call it just IAC, it helps us automate the provisioning of infrastructure, which reduces mistakes because we're not manually doing all of those changes. And as noted earlier, it allows us to have multiple near identical environments without configuration drift. So that's kind of the idea behind having infrastructure as code. We can declare our configuration, and we can avoid hard coding secrets into our system, which does help us secure our infrastructure a bit as well. Now, it does take a little bit to stand up. It does have some various things that you have to consider when you're doing it, because you might not already have had it in previously, and it takes that work to get everything moving. But once you're there, once you already have all of your code, all of your infrastructure set up as code, all of that management, it can make things a lot easier. So that's infrastructure as code, just that definition. Let's move on to another term, which is cloud engineering. What do I mean by that? What is cloud engineering? So cloud engineering is applying the software engineering principles we've come to know and love, and we've refined over the years, to cloud-based infrastructure management. In doing so, we can ensure that we use the same tools, the same processes, and the same practices across not just our infrastructure, but also our applications, so everything can be one unified system. This uniform approach enables teams to work more closely together and break down those silos of communication across the entire organization. Now, it does mean there's a bit more of that initial lift to ensure everything integrates seamlessly, especially if you're working across multiple teams or multiple CI/CD pipelines, things like that. And there's more work to also set up some testing systems, because you probably haven't had testing systems on your systems before. testing systems on your systems, testing systems on your infrastructure before. However, it means that we can use all of these same tools, which is pretty nice when you think about it. But enough about the definitions and the theory. Let's talk about real life. When we think about doing this in real life, there's a few approaches to actually do infrastructure as code, infrastructure as software, which is part of cloud engineering. One is using someone else's system, and the other is doing do-it-yourself or DIY. So let's specifically explore that provider situation or someone else doing it for you. The first one I'm going to actually call out is directly from cloud providers. So a lot of cloud providers will actually give you some kind of infrastructure as code system, whether that's Amazon's AWS, Google's GCP, Microsoft's Azure, or other cloud providers. Now, the one I'm going to pretty much call on just for an easy sample to point to that everybody's fairly familiar with is AWS's CloudFormation. So you actually have AWS set up this system so that you can configure your infrastructure on AWS with their version of infrastructure as code. Now, there's some pros to that, where basically you have a native provider for that specific cloud-based provider. And that means pretty much everything that they have is in that. And anytime there's an update, that also gets updated very quickly. So that speed of getting all of that up and running is good. Also, maybe you have a really great integration with AWS. You've been using it for a while, and it's easier to reach out to support to get some help with your CloudFormation system if it's not working. So that's some of the pros to actually using that provider. Now, there are some cons to this. First things first, vendor lock-in. You are stuck on whatever cloud you've actually been deciding to use. With that means that if you went from, let's say, AWS to GCP for some reason or another, you have to redo everything. So that really ramps up the cost of using that infrastructure as code system directly from the cloud provider. When you have that kind of a problem, you also then have to build up all of that knowledge back into your organization. So obviously, that also ups the expense, but it also means that you're going to have to spend a lot more time. So in the end, if you have a really, really tight integration with your cloud provider and you're not intending on switching ever, which may not actually be accurate, but let's just say that's true, then perhaps this is the best solution for you, is sticking with a cloud-based provider's infrastructure as code system like AWS CloudFormation, their CDK, etc. Now, there are other providers, and the most famous one is HashiCorp's Terraform. Terraform enables you to have a multi-cloud system using their proprietary HCL or HashiCorp configuration language. Now, that's awesome. Having a multi-cloud system means that, hey, I want to go from AWS to GCP. That's a lot easier. You're not sitting here trying to figure out, okay, well, now I have to change all of this code over to this code and somehow make this just magically happen. So that's a really big pro for having something like Terraform. It's easy to switch. Also, with Terraform specifically, they have a very mature ecosystem and a very healthy open source community. So therefore, if that's something that really matters to you, Terraform might be a great solution for you. Now, there are some cons, just like any of these solutions that I'm putting out in front of you. First things first, you are managing your state with state files, so you have to store that, secure it, etc. So that's one example of some various things that might be a con. Also, maybe you don't want to learn another language, so HCL might not be for you. However, Terraform is a really great solution because they do have that lovely mature ecosystem. So if you're working across multiple clouds and maybe you need to prove that for compliance reasons or various other concerns that you have, that mature ecosystem may be extremely attractive to you. And then there's systems like Pulumi. I admit that I am biased. I say that with a loving wink at that. Pulumi is also mostly multi-cloud, if I can talk this morning. And you're using familiar programming languages and tools, which we'll see in a moment. And that can be really helpful, especially if you're talking across teams. Like, let's say that you're building a platform that the developers can actually ask for infrastructure from. And they can actually take a look at the configuration file and go, oh, I know how this works because I can read it. So that might be something that's really helpful. You also get testing. So you're using your standard testing tools from whatever programming language you're using. Also, with something like Pulumi, there's typically a state management system provided as a service. So you're no longer worrying about securing that state management. And there's also integration across the entire pipeline. So this is where we get into that cloud engineering idea where you start at the beginning and everything gets deployed on the pipeline. Not just the application, but also provisioning the infrastructure, standing it up, testing both of them together, making sure they work seamlessly together, etc. Now, there are cons to the Pulumi platform as well. First things first, and I'm going to say it, we're not as mature as Terraform. That's just a fact of life. In fact, we do build off of some of Terraform's stuff. So if that mature environment is important to you, perhaps we're still getting there, to say the least. Also, state management does come as a service. If you decided to do the open source version, which I'll explain in just a moment, you wouldn't have that state management. So you are actually relying on someone else for this case. Speaking of that, let's then go into the DIY version. And when we talk about the DIY version or the do-it-yourself version, people often like to take the open source projects that are underneath systems like Terraform and Pulumi, and they want to go stand it up themselves. They want to own it from end to end for various reasons. And there's some pros to that and cons to that. Pros to that, you own it. You know exactly how it's built. You know every little bit and piece of it. You have full control over it. You don't have to worry about whether someone else's system is down. Con to it, you own it. You have to maintain it. You have to manage all of the security. You have to manage everything involved in it. So, choose your own adventure a little bit. But enough about some details. With all of that said, let's go see what building something with infrastructure as code looks like when we use some cloud engineering principles. And this is where we get into some real life code. So I'm going to be using Pulumi just because that's what I'm familiar with, but I'm also going to be using Python. Python is the language that I am the most familiar with, and I also think that it's a little bit easier to read for some folks. So take it with a grain of salt. And I'm going to come over here. Let's just take a quick look at what this program does. So we've got some imports. This is all of our library imports. And as you can tell, we are using real life code in an IDE. So yes, the documentation does come up just like you would use for any IDE tooling. And in this case, we're just going to do a very, very small static site. So we are creating an AWS S3 bucket. And here's our little index document. And we're running a for loop. So again, if you're using cloud engineering, one of the nice things is being able to use the constructs that are already in your language to do whatever you need to do. So a lot of the struggles that we might have already been solved for applications. So why not apply them to infrastructure? So here we are. We've got our little site directory and we have a site path. Here's my object getting added. We have some exports so that we can actually use the data that we're getting. So exports typically are things like a Docker containers ID, for example, or in this case, a bucket's website endpoint that we don't actually know what it is ahead of time. So we're able to export that to use it later, which we will see in a moment. And I do want to point out this configuration up here. I already have all of the Pulumi config set up for our stack. So I'm going to just do a Pulumi stack ls. I did set a few things up because I knew this was going to be a fairly tight demo. So I have 2 stacks that are running. A stack is an environment. And one of the things to think about with infrastructure as code is, remember how I said near identical environments? This enables us to have a development environment, a QA environment, a staging environment, and a prod environment, just as you would expect from a truly classic software development lifecycle system. So in this case, I'm only just going to stand up 2 stacks, and that's dev and prod. So I'm currently on dev. That's what that little asterisk mean. And in each stack, I do have config set up. So if I just do Pulumi config, I believe it gives me some information. So I've already set this up through the CLI. I gave it an AWS region of US West 2 because that's the closest one to me, and a site directory, which is this www. And we'll see where that matters for prod in a moment. So let's actually do just real quick Pulumi up. And this is going to then take the application that I've written, so my infrastructure as software, and stand it up as infrastructure. So it's going to interpret it. So let's just run a Pulumi up. We get a preview, and you'll notice that view live. This is what I was talking about in terms of you have something else managing state. So we're going to go back here, and we'll see that I have my state right here. And here's my configuration. There's some secret management and tags, but you'll notice there are no resources, meaning there's nothing that I'm managing on AWS right now with this specific stack. Let's go change that. So I'm just going to, actually, let's first look at the details real quick. This might look a little bit familiar because it looks a lot like you might get in terms of output from something like CloudFormation. So you actually can take a look at all of the updates you're about to do right there in the terminal. So let's run yes. This should be fairly quick. Any other demo that I would do, unfortunately, does take like a little bit longer. So I thought this was a fun one just to kind of stand up. So it's thinking about it, adding the objects. And there we are. You'll notice that we have those bucket endpoints, which I'll click in a moment. But the one big thing I want to point out is the resources. The thing about infrastructure as code is that it only changes just enough to get to this desired state that's listed in the program. It's not actually going to touch everything. So the next time we do an update, you'll see that we're only going to have 1 or 2 things touched. That's really important to help with that configuration drift that was mentioned earlier. So let's just real quick take a look. And here we have a little quick Hello World website. Pretty cool. Now, let's see what happens if oh, actually, wait. I do have another site here. So if we take a look at about.html, you can see this getting out. We're learning a little bit about infrastructure as code. Now, you can also curl that. So, and this is where that stack output is really important because we can just do a Pulumi stack output. And I want the bucket endpoint, if I remember correctly. Ta-da! So there's the same exact HTML file. So you can use that bucket endpoint as an export. And the nice thing is you can also use that across more programs. So you can call this just like any other variable in your program and go ahead, reuse it in multiple places, which is kind of nice. All right, let's actually see how this matters for standing up a different stack. So in this case, let's go select Pulumi stack, select prod. I can type and talk at the same time. Watch that. That'll be a miracle. So now if we do a Pulumi stack ls, we'll actually see that I am on prod. That little asterisk has now moved. Now, the nice thing about this is that we can see how using the same configuration, we can stand up a near identical environment with a slightly different configuration to show prod. So in this case, let's just do a Pulumi config to see the difference from before. And again, you're going to see the site directory is now this www prod, which is over here. So I have a slightly different file that we're going to be taking a look at. And you'll see it'll actually say, hey, we're going to be in prod. And I was doing this last night. I kind of gave away my little excitement there. So let's save that. And we'll go back and fix it in a moment. But the idea is that you can change things to the next stack, but only what you want to change. So let's go and stand up that stack. So Pulumi up. And we're going to see our preview. It's going to do the same thing, basically. We don't need to look at the details. It should be pretty familiar by now. And we'll see it go up and running. And again, because we have this console that we are working off of, we can go here to the prod stack and see the activity happening in real life. This is really useful if you're doing CI/CD and it's all happening remotely, not on your machine. And this is another reason why you would actually want infrastructure as code, because you can run it in your pipeline. You can run it as part of other things and be able to watch what's happening just like you would do with any pipeline, really, on a remote system. So we've actually been able to go here and set up our stack. So here's hello Pulumi in prod. Pulumial, apparently I can't type. Let's actually change that. So let's see what it looks like. And now I'm going to say hello Istanbul. And I'm going to save it. I use Vim key bindings because I'm that person. If you would like to argue about Vim versus Nano, we can do that in Discord later. But let's do another Pulumi up here, and we'll see that it's going to give us this preview, and it's only going to tell us that I don't really need to do much. I just need to update one thing. So we can look at the details, and we can see that source file is changing. So that's that tiny, tiny little update. And you just hit yes. And the stack is going up, and we have an updated thing. Now, when we click that link, everything has changed. So that's the idea behind actually having infrastructure as code in real life in a fairly simple demo. And then, of course, we can go back here and take a look here at our resources, and here's all of the state about the resources. I have a lot of various things in my Amazon things, so you'll just have to trust me that everything is up and running in AWS. Now, of course, it's always good to clean up after yourself, so we're going to just do a quick Pulumi destroy, and all that means is I'm just going to take down everything that's there. But again, because we're managing state as part of any kind of infrastructure as code system, we're able to say, okay, now take it down, but keep the configuration for me for later. And I'm just going to destroy prod. By the way, don't actually do that in production unless you actually mean to destroy prod. You might not have a really great day if you destroy prod on purpose, though it actually should be pretty easy to stand up. Okay, so, and it is going to tell me that the history and the configuration is still there, again, because this is a managed service. If you were doing it with other systems, you still probably have access to your state files. So you could pull down those state files and take a look at it. So in this, again, we're going to go back to prod. We can see this is gone. There's nothing here. So we get a 404 that's standard for AWS. And I'm just going to real quick go select the dev stack and destroy that too. And we'll let that go. And then I actually have one more thing to show you. We'll just let that run. We don't really need to worry about those. I want to show you what this looks like in a much more complex system that we don't have time to build. And believe it or not, Pulumi uses Pulumi to deploy its documentation website. And all of our previews are done via Pulumi. You probably can do this with any other infrastructure as code tool. I honestly haven't tried it with Terraform yet. I'm actually kind of curious if it works. So if you actually use something else other than Pulumi, but like if you use Terraform to do this for something similar as part of your CI/CD pipeline to build out your docs site, I'd love to take a look just because I think that's really fun. I'm a docs junkie. I will 100% admit it. So I would love to see what you're talking about. But you can see here, we actually have previews for various things, and we can take a look at our infrastructure there. All right. So yeah, that's the short version. Thank you so much for having me. I really appreciate being here. I will have all of the information about this talk as well as a demo repo to go play with. I'll be putting that up in the Discord in a little bit. I still haven't committed the actual final bits and pieces. But I do want to mention that Cloud Engineering Summit is coming up. So if you would like to learn a bit more about cloud engineering, you will be able to hear from a few experts in the industry, lots of experts from the industry. But that's about it. And I will happily take any questions.
Thank you very much, Laura. It was a great talk.
Yeah.
Let me see. So there is one question. I will show
Sure.
it here on the stream. So
Ooh, I love that question.
So let me read it first.
Yeah.
In case anyone misses it. So what do you think about the relationship between self-service platforms and infrastructure as code? For example, managing ephemeral environments might be too static in infrastructure as code.
This is a really great question. I love self-service platforms, especially for development environments when you have various developers needing to build things. I actually used to work on this at a prior company. So to me, the lovely thing about doing something like this is you can create a dashboard that allows people to self-service request, I need a stack that looks like this. Or you can also, from the flip side, take a look at it and say, hey, I only want people to be able to use these 5 tools. Let's say, like, for some reason you're restricting, maybe you're trying to stick on the AWS free tier for some reason, maybe for a dev stack or something like that. You can actually restrict that by giving them very specific building blocks. Pretty cool. So I think that's one of the lovely things about IAC is you're actually able to tell people this is what you're allowed to use and have it reliably get reproduced every single time. And when it comes to ephemeral environments, that documentation site, all of the previews are ephemeral environments. They get stood up only as long as people actually want to see the preview. Once everything gets merged, it gets taken right back down. And so I think that it's possibly one of the best ways to ensure that these little environments that people might need for only a little bit are always reproducible and always give you the same result, so it's easier to test your application. So, cool. Oh, you're muted again.
Okay.
It's okay.
So, thank you very much, Laura.
Absolutely.
As far as I can see, this is all. Again, folks, feel free to reach out to Laura in the speaker channel on Discord. So thank you again, Laura. See you.
Thank you so much. Bye.
Bye. So, folks, let's give 30 minutes break, and we will be live with our first panel with Patrick, Kris, and Bernd, and talk about DevOps. We will see you in 30. Mute as always. So let's get started. I'm adding Patrick, Kris.
Hi.
Ting,
Hey.
Bernd, also live. Okay, we are all live. Nice. I'm fixing this branding, going under the banner.
You got this, Sarah. Go for it.
We do have a folk, like we do have someone working on that. But so how are you?
It's weekend.
It's weekend and Bernd is sober.
Yeah. For a couple of days, honestly. So there are no conferences, no in-person conferences, which is mostly the chance to. But your drink is a little bit touch of a gin and tonic, I think so. But I know you are into margaritas. You're on a different side.
Nice. So thank you for joining us. I know that this is Saturday, so I really appreciate it. It's gonna be free flow, so feel free to ask questions as we talk. But I do have some to get started. So I want to start with, so I find here some of the originators of DevOps. So you were there from the beginning. So I wanted to ask is if you remember the earlier times, when you have discussed DevOps and, more than 10 years, actually 12 years now. So how do you think the companies and the industry have converged DevOps? You see title, department, what do you think, how DevOps changed over the years? It's a very generic question, I know. But
how do we have, how many days?
Patrick, you want to start?
Okay, I'll kick off. You all know the rest of the history. So I'll kick off with obviously the first DevOps conference being called DevOpsDays. Before that, I think the word DevOps had popped up in the presentation from John Allspaw and Paul Hammond of their work at Etsy. I think I came personally, and I think that goes then for a lot of the stories. People came from different backgrounds to DevOps and the idea of DevOps. I came from the agile world, where I was envious about them working together as a team, and then I started exploring how operations people would be involved. The funny story is that even after the DevOps days, the first DevOps days finished, I didn't know DevOps was a thing until somebody wrote a blog post on this, Stephen Elsa Smith, what is this DevOps thing anyway? And I think in my mind, it's still very much an extension of Agile. In that way, yes, we've extended it along the way with new practices, but for me, the core collaboration that is in the Agile Manifesto is still at the beginning. I think that's not the way the industry sees it right now. So there's been, quite a journey over the many years, but I'll let the other two guests pick up from there. So,
yeah, to the industry, it's running Kubernetes on Amazon.
I can say I go ahead. I'm not in there from the beginning, so I came in late compared to Patrick and Kris by far. I think when I came in touch with DevOps was PuppetConf 2012, I guess. At the time where PuppetConf, in my opinion, was one of the top-notch technology conferences, less about the product, more about all the tools around it, like Logstitch and all the things coming up at the time. And I guess I met Kris there. I'm not sure at a European conference or over there. And the year after, we had DevOpsDays Berlin 2013, and from there means if you look in the DevOpsDays archive, how many events we had until 2019. Obviously, it's just take off. And then, so the group of us, we meet from time to time because in Europe it's really small. So we're always laughing about the traveling circus when the same people pop up at a conference.
Like that's in San Francisco.
Or this, yeah, exactly. Yeah.
No, I guess Patrick started with saying that a lot of it came for him from the roots of the Agile movement. For me, that's also partially true, but I think to me, it was the crossroads of open source, large system automatization, the influence of Agile, and then the early cloud adoption. And basically those three grouped together is where we started discussing how to help people to deliver software better. And if I look at what today's industry calls the word, it's still sometimes about that, but it's definitely not in a way that it works. If I look at what I see a lot of organizations call DevOps, that has nothing to do with what we think about DevOps. What they've done is put a DevOps engineer in a DevOps team, and they have sprint and stand-ups now. But actually being able to deliver software in a better fashion than 6 months before, not really. And that I think is the real struggle we're facing now. I've been saying this for a couple of years now, but we still are not even close to where we could be, or where some of the poster childs of 10 years ago were back then. I think there's a lot of small organizations and a lot of large organizations that have improved, and they've gone on a journey and they've made a lot of progress, but the majority of our industry is still in pain. And that to me is definitely still a problem.
So the relationship between what it currently is more focused on is in like some engineering practices, some more of the technical stuff, and then the collaboration as such as the agile movement and kind of thinking more about product. That tension has always been there between finding that balance. I think now the industry has set the tone where with SRE and observability, it's kind of like folding back to the technical state of DevOps. I think last year, it took me quite a long time, and I've never wanted to give any of the definition of DevOps because I always wanted it to keep expanding. But I settled down to DevOps is everything that you do to overcome the friction that was created by silos, and all the rest is engineering. So when people tell me they're doing Kubernetes, they're doing other stuff, they're good engineering practices. I'm not like going anywhere against that, but then I usually ask them, why are you doing this? Are you doing this to like automate and help self, or are you actually helping with the abstraction layer by others doing their job better? And that is just an example on like that collaboration and that friction. Are you helping to overcome that, or are you just doing the technology for the technology? And in that way, yes, there is a relationship, but it's also often how you apply it and why you apply these techniques.
Yeah, absolutely. The number of organizations that just cargo cult the technology and call it DevOps, it's way too high. And the thing is that a lot of wrong adoptions of technologies actually pushes back the collaboration and actually makes teams go slower. And that is a real challenge.
But I think to add one thing, what happens to me that when companies started to have the DevOps engineering team and DevOps senior, whatever title, let's say the insiders were laughing. It was creating a silo as well, right? Because we were looking at the industry. But if you also look at large industries, they often need a title for a framework or a team to frame an idea, because they cannot just like have this in their minds. As I see it now, sometimes it's necessary in a bigger company to name it and give it a name that other people get their head around it and get an idea what's going on. So they need sometimes the DevOps engineering team or senior DevOps, whatever. When we come from that's a culture perspective, perhaps it does not fit, but I think an enterprise in some way to adapt it needed to give the baby a name, if that makes sense in some way.
I've had a lot of projects where that actually turned out to be the problem, because once you give it that name that has a common knowledge somewhere by other people start having their own definition. And one of the practices that I took after a couple of years was, let's not call it a DevOps team. Let's not call it a DevOps transition. Call it engineering 2.0. Call it the new way of working. And then define as an organization what you as that organization understand and what you want to achieve. Because if you're going to call it SRE, if you're going to call it Agile or whatever, people are going to go and assume that it is what they read somewhere else that they want to achieve, which might or might not be what the organization wants to achieve. And to kind of clear up that being lost in translations, come up with a completely new name like Project Blue. And Project Blue it's actually adopting a number of those practices, the things you like to achieve, but it's not going to confuse people with what organization Y or organization Z has done within their project. And they might have called it DevOps, but it's completely something, it looks like it, but you need to set your own goals and then make further approaches towards those goals.
I mean, I
similar
do have...
similar issue is like, we're going to do a Spotify transition.
I mean, I do have a very related question, and I'm looking at comments. The only comments I got is how Kris looks different than his keynote. Like, like, are they asking you, is he really Kris? Like, yes, he's Kris. So my other question is actually very related. So we see these terms like delivery teams, for example, who can end-to-end develop and deliver the software, or platform teams who develop the underlying platform. So what you just mentioned is related. So do you think the industry converges to this?
Sorry, can you repeat that last? Because we didn't understand.
Yeah, so there are now terms like delivery teams who can develop and deliver software, and platform teams who develop the underlying platform. Do you think the industry converges to this instead of just, having DevOps teams?
I think there's value in these teams in a way that I look at all the different teams as skill sets that need points of attention. And whether that's the front-end developer, the back-end developer, the infrastructure coder, the platform abstraction layer coder, those are all kind of different groups. And while you can think about it like one person does everything, or you collaborate with the groups to do that. I think the industry will think about this, because the cloud is actually the abstraction layer where it used to be the hardware. So they're thinking, oh, this is kind of the new group that takes care of this. It's not hardware, but it's like cloud infrastructure. We're going to help that. I think the difference is that where I hope the industry doesn't settle is that if we were to fall back that these teams only care about their abstraction layer and only care about their layer, then, well, DevOps was for nothing. If they do that layer, but they do it actually to help the others. So if you're a platform team and you're just building the platform without going talk to your teams what they need, how they need it, how they want it, then you're missing the point of a platform team. So I'm not afraid of the new term or the new grouping. I'm more afraid of what will be the direction that people will take from this in the company. There's so much value of standardizing practices across group, speeding up groups, by helping them bootstrap in a bigger organization. So all good practices that a platform team could help. But if you're just folding back to only infrastructure, only cloud, and only your layer, then yeah, we missed the point with DevOps on that part.
And one thing I would like to add is that what I see is, especially people come into the industry now, so that I would say, talking about us, perhaps we started that technology career with where ops were in place and there was no public cloud, pretty much no cloud. Perhaps you rented out a server somewhere, but since people coming into the industry now, they often have no idea about the ops going on. They have these abstraction layer they use, so pretty much they live with that silo, use an API as an abstraction to orchestrate the infrastructure or use a service there. On the other hand, they often really have no clue what's going on, and that the imagination that there are still computers on the other side of the API is not there. Because it's honestly, it's really true somewhere. They don't have an idea what a loon is or how a disk works or all that stuff, because they just pump it in an API and then they were wondering that, I don't know, hammering 20,000 objects a second and that API does not work for some reasons because it's not designed around this. But this knowledge about how to design infrastructure in some way, which we talked about 10 years ago, I would say this knowledge in some way disappears, or of course move to the platform team. But I see another silo in that API abstraction, if that makes sense, and if I can say what I mean about this. But I think there's a new silo coming up where you just open up a ticket and say your API does not work, your service is not okay, but you're totally misusing it.
Yeah, just a small remark on this. there's abstraction layers everywhere. Use a framework for your database. There's an abstraction layer for your front end, for everything. So the problem is everywhere. There's a specialism to be born. That these abstraction layers will kind of create these knowledge gaps and transitions. So, but I'll let Kris finish on this one. So,
because I think the team structures, and we'll still see organizations who have DevOps teams and operations teams, and some have a lot of people running things and a small number of people who build things, and kind of a lot happens and depends on what kind of business you're in, what kind of size your organization is. But like Patrick mentioned, like if it's really just a DBA team that just cares about the database and just doesn't understand what kind of application is running or what the end user are doing or how the rest of the business work, if those silos are really completely isolated, then that is the problem. If you have different functions, different people with knowledge who are grouped together, who work together, who build things together and service the business, that could perfectly work. Cross-functional teams are teams that move fast, that move things, and that are capable of doing things themselves. But your organization might just not be big enough, or it might be too small or too big to do work like that. And that's kind of the exercise everybody will need to do. But indeed, what I also see is that there are people who just don't realize the cloud is just other people's computers, and that it's still computers in the back who are managed by somebody, that APIs also are managed by somebody, that it's not just magic happening.
But I want to nuance the thing, and I understand, Bernd, what you're saying is people understanding the lower layers, but my motto is always being just enough, right? And understanding just enough doesn't mean you need to be the specialist in kind of all of these layers. But you kind of, I always say when people ask me, oh, so that means I have to have all these skills? No, like you don't need the skill. You just need to know when to ask for somebody else's skill. So if reaching out to that other person because you know there's an issue and that he can explain this to you, that is a better approach than trying to learn everything yourself and all layers. And don't forget, our computers will build on electronics, and they were thinking the same things to us, like, oh, you don't even know like what a PCB board looks like and how the hardware is made and the tolerances, of all that. So it's always going to be there. And like driving a car, I don't need to know what's inside them there. I need to know just enough when I need to go to service or have a service. And then what becomes important is that service person actually helps me instead of saying, buy a new car or you know nothing about cars. That's not really helpful. So he will give me maybe like a couple of answers of quick things I can do, which is solving maybe 8% of my problems. And then I go to that other person. And we'll probably segue into DevSecOps, and it's the same thing when we're explaining, should I then learn everything about security? And you can't learn the same thing as a security person who has done this all his life. And the same thing with infrastructure. You can't absorb that knowledge, but you can learn, understand empathy for the other person's problems when you're hammering the disk, that there's something going on. And then the other approach is actually re-architect. When a lot of the VMwares and stuff running a local infrastructure, they came to the cloud, they kept designing the same way in the cloud as out the cloud. But you need to adapt your design and your architecture to cope with the new reality. So I can't see inside, I'll create a redundancy so it doesn't matter too much that I can't see inside, and I'll flip somewhere else. And that's another technique of coping with these abstraction layers that you might not fully see, understand, or might not even be allowed to see on the other side.
And also like how you use it, but also like what service you choose. Means if you look at AWS, how many services they have, like Infinidash or some other weird services nobody knows. Nobody really knows what service to use. I often see that compares like when document databases came up and everybody said, no SQL, no database model. We just put our documents in there. And then they figured out under high load, perhaps it's not the result they expected and moving back because they just had no idea how that works. And you are right, like you don't repair that service. but even like figuring out the right service to use for a specific purpose of storing or retrieving data or work with it is really challenging. And if you don't get a head around how that works, it could be really tricky. But of course, you cannot be an expert for databases, security, and containers. That's the full stack engineer, which is the new thing, right? Then you know everything and have 2 years job experience and know everything. We end up here.
I'll tell you a quick story about my son. He wanted to have a Minecraft server, so he comes to me and says like, "Oh, Dad, I want to do a Minecraft." And it's just like, me as a technical dad, I was so happy. I was like, "Oh, I can give you like a virtual machine. You can run there. You can learn that stuff." The next morning, he came to me. He said, "Dad, it looks really cool, but if I just pay $5 for a service, that's done, and I don't need to worry about that." And I think, I was actually right, not having to go through the whole length and just pay $5 for a reliable service where he could do whatever he needed to do in his business. So anyway, I thought that was applicable as an answer to this discussion.
A good selling point.
You bring up the $5, and you also brought up the part where you go have your car serviced and mechanic says, well, that car is actually total loss, you need a new one. And I think in our industry that is kind of part of the problem, because what are people struggling with from the commercial point of view? What are their salespeople trying to sell? They're trying to sell you to work together, and actually that's going to reduce their revenue. So the next thing you're going to do is look at all those shiny fancy tools and say, hey, you need the new observability stack. And a lot of the people who just don't understand, they just need to change the light bulb and actually replace the disk because it's broken. They go and say, hey, we need a completely new observability stack. Hey, we need to go to containers because that salesperson has told us to. Isn't that a problem we need to fix?
But isn't that capitalism reached IT finally? That we throw everything away. When have you last time repaired your shoes? You throw them away, if it's good or not. But you ended up that it's the same here. You throw things away and make it from scratch. But
I wouldn't say it's capitalism. I think it is actually, reflecting on the business side is the extra point, right? There in is it beneficial? Yes, no. How much am I paying for this? Yes, no. It's still, I'm okay with paying a premium for a service if it's good, and if I don't have to worry about it, and that's fine. Even if they are charging me too much, if it's helping me that enough that I'm willing to pay the premium, then yes, somebody will say, hey, you can do this much cheaper, but I don't care because I can afford this. This is important to me. Somebody else is doing a good job, and that's fine. So, and I think that's the mentality, like not having to build your own data center. Thank God we're not doing that too much anymore because, we didn't like the cooling system. And the same thing is, should we build our own
Cat5 into the right spot?
Should we build our own service? Should we build our own server? Yes, there's learning. Yes, there's pro and cons. But not being dependent on others, I believe that's another reason why sometimes we need to understand what's going on the other side. But yeah, economics play a part in this, and engineers, will not always focus on that, to be honest. So
I'm thinking about what the original question was, honestly.
I mean, that's what I want. So
there's a question.
So yeah, there's
answer
a
the
question. It's I think probably you've got this questions, like similar question, a lot. Like there are now companies building like teams, small teams that does everything, or I don't know what they call, but sometimes they call different things. So the question is, how should we find the right balance between standardization and autonomy freedom? A lot of companies are actually building walled gardens, zoos, but I feel like we should build safaris. What do you think? Safaris can be dangerous, but
the big question is, how mature is your organization, and how mature are the people that are trying to build software? And if you have a lot of young people that are just out of school, you need to give them some form of guidance. If you have a lot of experienced people who have been doing this for years, who have been building things that they've proven that are stable, they've proven that are giving users a happy feeling, then you probably don't need to give them that much of a really strict set of tools to work with. They'll find their own way. But you see a lot of organizations and typically banking, government, and a lot of other traditional industries where the maturity of the developers and the maturity of the people helping the developers is not close to what you see in the actual technology companies. And there it's much more difficult to say, well, we're going to let you roam around and do whatever you want, because they will bump into trivial things and they will shoot themselves in the foot, or they will just be building things that if other people who have more experience look at it, say like, that's not going to work. So there probably you need to give them more of a strict guidelines, like you can build this. But the challenge there is that within those organizations, it's really hard to find people who have the right experience. So what might be backfiring is that there's people setting boundaries and people setting guidelines like you need to build it like that, which actually also won't work. And that is why you see in a lot of those larger organizations that there's a lot of struggle between finding a good balance and becoming a really agile environment, while they look at the smaller or the more technology startups who are much more capable of doing so. It has to do with the experience and the capability level of the people that are involved in those teams.
I mean, even in large technology companies, the job turnover is really high. Like, if you got the talent and that person can leave in about a year, so it's like always changing. Jobs are always changing. People are always going to different companies. So it's, I think, really hard to keep that kind of knowledge inside, even in tech companies. But I don't know if the solution is standardization or not. So
I don't recall which book it was, but one of the books that I looked into when I was researching autonomous teams and how that would become successful is they explain that autonomous doesn't mean you do whatever you want. And Kris, talked about this. There's some guidance you need if you're like new to something. But the crucial point that book made is that they had like one rule that was really building, like making autonomous teams effective. And the one obligation rule was not like you should do what A does or like what B tells you to do. You have to solicit advice if you think another person is impacted. And just by making that the rule is that you have to seek out what the other person is doing. So for example, if you're building something, somebody else is impacted, you get from that. But if you also think like, I think another person could have a benefit from me using the same system as them, I should reach out. And that's not putting the obligation, should we standardize or not standardize? I think that there is, if your team thinks standardization is important enough, then you should do it. If it's not, and it's not helping you because there's a lot of friction and you can't do your job right, then it's not. But I think if you only look at your own benefit and not sometimes of the benefit from the company or at other layers, then, I know what the expression really is, but, take one for the team is sometimes like I standardize because that I know that going to help all my friends in the ecosystems. If we're doing this, we can turn down costs, we can get some benefits. But if the standardization is not helping you, you should talk to those people, tell them why it's not working. If they're okay, if you change the structure and try to help them find a consensus. But so the crucial point is always reach out and the why, but the top-down forced structure, I think it's still there, unfortunately, in companies, but we should get past that and more have the debate on, is it useful and helping me, yes or no? And if it's not helping me, I'll explain you why. And then I'm allowed to take an alternative in that approach.
I think one thing is my personal experience is also that standardization gets even harder when you are more people, because of course standardization is always a snapshot of current technology and current usage. And then if you want to change and adapt the standard as more people are involved, then it's really getting hard to get a new set of standards and improve and change these standards that in some way the teams get apart, to not lose the speed in some way. Because I don't know, establishing a new standard all the time or adapting with it is also getting hard, depending how your company or your team works.
The thing with those standards is that sometimes you need to redefine how you describe them, because at some point in time with the technology stack you had standards how you did things, but you also had standards on how you deliver things. Like we had this performance, we had this uptime, this was the response times of people who needed to fix things. And even if new technology pops around, I think the more important is not how you use it, but to keep those quality standards high enough. Like it's still going to be that stable, it's still going to be that fast, and if there's a problem, we're still going to be able to solve it this fast. And that is something you need to get to the people. Like, yes, we're going to need to adopt with new tools, with new technologies, but the quality levels we've reached with this chain of tools, that's something which we spend time on, where we have learned a lot of things, like how things will go wrong. What about we take those experiences? What about we take those quality standards and try to achieve the same level of quality with the new tools? And a lot of times you see people, yeah, but it's going to be easier and it's going to be fast and it's going to be fun, but they've lowered their quality levels. And I think that is a big warning. Like keep that quality level which you at some point reach for your organization.
So Patrick touched on the DevSecOps topic just a little bit. So maybe we go deeper and, talk a little bit in more detail and, with maybe concrete practices about some of your favorite practices around DevSecOps. I mean, the essence of DevSecOps, as you mentioned, is not very different than DevOps. It's just, breaking down the silos with the security team. But what are your favorite practices which favors this, shift left mentality?
I think in, let's say, ancient DevOps, it was kind of getting around the deployment was a good discussion, and then we did the value stream mapping as an exercise. In DevSecOps, the exercise that I see that brings the teams kind of closer together is quite often thread modeling. And I'm deliberate not going to what's my favorite tool in the DevSecOps tool chain and to do shift left. But I think many times if you run this thread modeling with the security team and the team that is running the service in a collaborative way, that you're like, oh, so what do you have? Why do you have it? How it's working? And you do this together as a group. And then one says like, hey, but did you know there was this little back door that we never plugged? And there's this ticket here. And then the security people maybe showing an attack. I think that's almost is like the grounding exercise between building the shared states of what is the actual thing that is there, and then from there you have the baseline to improve. So that's why I like this practice as a collaboration exercise. I don't like it if it's run like, okay, build a scheme and then show me the report and I'll send you a reply. The fact that if you're doing the threat modeling together to build that common knowledge, then I think that's one of my favorite exercises in DevSecOps to kind of build the trust, because both see what the other knows, how they can help each other on that. And then the second practice is when there's questions, and any questions on security or what they should do or in doubt, the practice of replying very fast and caring about the reply, and not just saying, well, we'll schedule a meeting in 2 weeks. So those are the two building blocks for trust for that collaboration. That's why I like them so much.
To me, I mean, DevSecOps, when I first used the word, that was 2012, and we were talking about RUG DevOps and DevOps and security. We're like, there's no need for a new word because we're all in this together. And that kind of settled it down for a couple of years. And then when it first popped up again, I was like, but we had this discussion. We don't need to have this. But now I'm like, it was time we had the discussion again. So I'm quite happy the word is there. But what over the years, I always found really moments when I got security people involved was the moment when they realized that continuous delivery actually is a security requirement. And having security people who were still faced with, we're going to block this, we're going to basically say no to get this to the production, we're going to try to put up much more barriers. And where in the early DevOps days, we were saying, well, operations is the people who say no because you don't get to production with this manual deploy thingy. Now it became the security people, and getting those people on board and helping them realize, like, look, you want continuous delivery because it's going to give you all the benefits you want. It's going to give you the ability to actually patch something when you want it, when you need it. And it's going to help you to reduce the risk in changes. And when that starts changing in an organization, when they actually start realizing that it is through automation, it is through adopting a bunch of those best practices and doing much more automated testing rather than just the one-off automated test or the one-off manual test, which is way too late. When they realize that, that's when you see really the collaboration pop up again. And it's really nice to see that happen with organizations that traditionally have been like the guardians of productions, where the security people said, no, not passing.
So I don't have the knowledge like Patrick and Kris have about it, but what I read about it and what I think about this one, the big thing itself is that the name that people think about it, even like because its security is in there, it changes the mindset that it's a part of thinking about how an application, how your infrastructure should look like. And even if you're of course not as skilled, like Patrick mentioned before, people who works their whole life as a security manager, you just think about it. Like we have the throwing it over the wall from development to operation. Now it's your problem. There was another wall from operations to security because you figure this out, what we need to make this application secure. And it just changed, hopefully, the mindset at some people that they take security decisions into consideration, what that means when they develop their stuff and when they deploy it somewhere. And I think that's the thing about all the methods. I honestly don't have a clue about it, what Patrick's saying.
I also want to add that I sometimes hate the term shift left with a passion, in a way that in my mind I always translate shift left when people say that to fix problems early as possible in the value stream. But for a lot of people, it equates, well, if we can solve all problems early in the value stream, we don't have any problems coming up in production. And I don't believe that to be true. I'm not going to invent anything new there, but like I always say, whenever you shift left, you should also shift right. And that means you should build the observability for security in production, because there are just things you will not be able to fix, prevent, or foresee in the value stream early on. And that's why I think I'm against it. Like we should all shift left. Well, we shouldn't all shift left. We should shift in all directions. But it's not that catchy a title, I guess.
It's really catchy for me.
The number of people only scanning their container at boot time and not wanting to start it if it's vulnerable, but completely forgetting that 6 months down the road, that same container is vulnerable as hell. Because they've only shifted and forgotten about the operational model.
Yeah.
Always positive, Kris.
Always realistic.
Yeah, no, it's okay. It's not wrong, but just saying.
I like how you say you're not wrong, but this is German negotiation tactics.
Yeah, we invented the sitting ovations,
So, folks, here is your last question. Bring in the crystal balls. So, what do you think about where this, DevOps thing is going? Like, how it's changing and how it's going to change over the next few years, or maybe not 10 years, but.
I think in 2014 they asked me the exact same question, like what's the future. I made a presentation indeed with a fakir and a crystal ball, and in my mind, the way that I've taken peace with it is that memes on the internet never die. So, and a meme, if you look that up, it is the piece of cultural change. That is the definition of a meme. And DevOps will keep being there as some of the collaboration happening. Whether at that time we call it SRE and it goes somewhere in, that's fine. I always, in a way, hoped that at some day the word DevOps would go away and it's just taken as good practice. And I think Agile tried to extend some parts of it, ITIL's being rewritten. So there's a lot of moving things that will be happening there. I do think that the audience has settled that DevOps equals deployment and containers and so on. I don't see an immediate spin on making this a completely, 3.0 or something like a new spin on the same variation. Yes, you might now be doing GitOps and then there's serverless, but they're all variations on the same theme of trying to overcome some of the friction in several ways. So I'm positive in a way that it's been in a way settled, but from there's going to be new friction points, and they will emerge again. That's not much of a projection in a way that it will be there, but it won't change too much in my opinion over the years. Even though, like, if you look at the content of a DevOps Days in this year versus a DevOps Days plus 10 years ago, the same concepts are there, but a lot of people will come there that will bring kind of new practices, and that will change. The tool chains will change. So that will probably keep on changing, but the ideas of collaboration will stay the same. So
I go ahead because I don't know, we don't want to be the last. I leave that to Kris. So for me also, the DevOps and DevOps Days is of course very related. I think there will be a change of the whole conference landscape in the next years. Means of course in the last years of COVID, and it's still not over. But if we look back to 2018 and how many events we had around the globe, I think that will change, that we have less events in the future and perhaps going way more back to the hotspots. I don't know if this happens, but this is what I just assume, that we just have like 5 conferences, 6 in Europe, and perhaps it goes back to the same amount. And perhaps in some way, if events are smaller and the groups are smaller, there's more real discussion, especially in the open spaces. So when I remember my last DevOps Days, they were all really big. And I enjoy them, and I really miss it, like meeting you all in person and other people. But in some way, it really was really hard to follow a specific topic over 2 days. It was just like the hallway track was crazy. So there were really about, if you know what I mean, like sitting there for 2 hours and discussing really a topic and taking the time, because there's so much going on. And in some way, even I like the big conferences. I hope we have some more cozy, small environments where we have time to really bring things forward. It's also a chance, I would say, in the change we currently have, that it's going to be different.
Suspense.
I was thinking about quoting Nicole. I think she said in the panel of Delivery Conf, she was, and that was one of the last conferences in person last year in Seattle. Patrick, you were there too. I think in that panel, she was asked, what about the future of continuous delivery? And she said, if I'm not mistaken, finally doing it. I think there was a word in between, which I'm not going to repeat. To me, that is in a way where DevOps is heading. A lot of people are already doing this, and a lot of people are really benefiting from having those shared experience, from really collaborating, from working together. But I only think it's really just a small part of the industry that is already working like this. The number of organizations that are still on their starting point, where just after we have been talking about this for 12 years, but they are still at a point where, hey, we're thinking about improving, we're thinking about doing this, can you help us? There are still so many people that need to go through that journey, and I think that is, it might be end up with different names. It might be that we change things and use different technologies along the way. But like Patrick said, at some point, those things will become common, but we're definitely not there yet. There's still so many organizations that are struggling, that are in pain, that are trying to improve the way they deliver software and trying to deliver software in a better way for their users. So I think that is where DevOps is heading, like hopefully getting those organizations to be better places to work and getting those organizations to be healthier and happier with what they're doing.
You see who is positive for once.
So, folks, it's already been 45 minutes. So let's close the session. And thank you very much for spending your Saturday with us. We really appreciate it. I mean, it's really always great to see you. Hope to see you soon in person. Hopefully in Istanbul or in Europe somewhere, probably. See you.
Thank you very much, Erhard, for all the work. So keep it up.
Thank you.
See you around.
Thanks for inviting us.
Thank you.
Stay healthy. Bye, Kris. Bye, Patrick.
Ferhat Yutsun sanırım.
Gene mute'lu galiba.
Var ya bugün başımın belası. Hemen şu şeydi. Emrullah el attı herhalde. Alt tarafı da kaldırırsam benim. Şöyle yapalım. Tamam. Yapmışsın zaten. Hoş geldiniz. Nasılsınız? Şöyle bir saniye. Tamam.
Evet.
Güzel oldu.
Güzel. Bir senenin daha sonuna geldik.
Aynen. Şu an bir hani Derya yok burada. Mustafa da ben davet ettim. Normalde bizim DevOpsDays ekibinde olmayan bir tek Mustafa var şu an burada. Ama bu konuda özellikle hani konuşacağımız konuda da çok bilgisi olduğu için onu da davet ettim. Ben açıkçası çok fazla hani hands-on DevOps'cu değilim bir süredir. O yüzden bir şeyler söylesem bile hani diğer arkadaşlarımın söyleyeceği şeyler daha değerli burada. O yüzden hani şeyi söyleyip başlayalım. Derya ufak bir kaza geçirmişti. O yüzden bugün çok fazla hani ekran önünde olamadı. Ona bir geçmiş olsun diliyoruz. Yani bizim ekibin zaten hani liderlerinden birisi. O her sene her zaman destek veriyor bize ama bu sene dediğimiz gibi göremediniz çok fazla. Ama Twitter'dan vesaire takip edebilirsiniz LinkedIn'den onu da. Şimdi ne konuşuyoruz? DevOps Remote.
Abi dolarla ödüyorlar. Oraya niye gitmeyelim? İlk başlangıç direkt acı gerçeklerle gireyim mevzuya diye. Evet,
ya yani çok böyle elimizde 3-5 tane soru var arkadaşlar tabii ama bizim burada bu sohbette istediğimiz mümkünse eğer sorularınız varsa siz de sorun. Çünkü burada şu an gördüğünüz herkes öyle bayağı hands-on DevOps'cu ve ben hariç dediğim gibi ve hani
benden de geçti ya. Ben de son bir senedir manager tarafına kaydım.
Geç onu. Sorduğun soruları görüyorum. O yüzden hani dediğimiz gibi sorularınız varsa mutlaka sorun. Ama benim hani direkt merak ettiğim böyle ortaya atacağım şimdi 2 senedir belki 3 senedir yani çoğunuz 2 senedir uzaktan çalışıyorsunuz. Şimdi bir DevOps'cu olarak DevOps'un hani getirdiği belki çok fazla developer size soru soruyor. Çok fazla böyle cross-cutting concern diyebileceğimiz şeyler geliyor. Hani bir anda bölünüyorsunuz. Zaten DevOps'cular biraz bölünmeye alışıktı ama uzaktan da olunca bu sorunları çözmek belki daha böyle hani zor olabilir diye düşünüyorum ben. Sorunların dışında tabii ki işin normal coding tarafı vesaire de var ama yani sizin hayatınız nasıl değişti bu remote dolayısıyla? Onu merak ediyorum.
Kim almak ister sözü? Ben gireyim mi?
Gir abi. Fark etmez.
Tamam.
Döneriz.
Öncelikle kalan herkese bu saatte teşekkürler. Tekrardan hoş geldiniz. Açıkçası bizim özellikle tanımayanlar için ben Getir'de çalışıyorum. Platform ve infrastructure takımının lead'iydim. Geçen sene kadar bu sene engineering manager olarak çalışıyorum platform ve infrastructure takımının. Açıkçası biz zaten şirket olarak bu hyper growth sürecine girmeden önce de açıkçası destek çalışmayı seven bir takımdık. Zaten az bir developer kadrosu vardı ve genelde o hani az kişi olmanın faydasından bir tanesi de hemen bir araya gelip bir şeyleri çözebiliyorsun. Bu da seni böyle resmi süreçlerden biraz uzak tutuyor. Ben açıkçası şirket olarak mesela pandemide bu hani dirsek çalışmaktan direkt olarak ayrı kalmak zorunda olduğumuz için mesela bir derece gafil avlandığımızı düşündüğüm alanlardan bir tanesiydi. Orada da en çok aslında developer tecrübesini bir geri hatırlamak faydalı oldu bizim için. Bir de biraz ister istemez istemeden daha doğrusu biraz süreç oturtmak gerekti. Bazı şeyleri ilk yatırım yaptığımız şey mesela bizim kendi tool'larımız üzerindeki saçma gelebilir ama hata mesajlarına değinmek oldu. CI üzerinde çalışan scriptlerin hata mesajlarından kendi içerimizdeki automation'dan normalde onlar bizim için olan hatalarken artık hataların daha çok developer'ların kendi kendini keşfetmesini sağlayacak şekilde mesela değiştirmeye başladık. Bu önemli oldu. Mesela pipeline'ı tetikleyen bir şey varsa o artık pipeline'daki hata mesajını scrape edip direkt developer'a götürüyordu. İçerisinde bir şeylere bakıp öneride bulunmaya başladık falan. O bayağı önemli oldu. Dokümantasyona zaten önem veriyorduk. Artık böyle ama dokümantasyonu iyice hani kendi kendine çalışabilecek bir formatta yazmak gerekmeye başladı. O da çok ciddi bir aslında emek gerektiriyormuş. Yani dokümantasyonu yazıyorsun ama Hani genelde kendin için yazıyorsun aslında. Böyle dışarıdan bakan kişinin bilgi eksikliklerini unutabiliyorsun. Onu çok fark ettik. Mesela yazdığımız dokümanların aslında genelde genele olduğunu düşündüğümüzde kendi perspektifimizde olduğunu fark ettik. Mesela onları özellikle şeyle yapmaya çalıştık. Mesela her takıma yeni katılan bir arkadaşa sadece dokümantasyon üzerinden bir şeyler yaptırıp oradaki hataları geri kapatmasını istedik. Ki bu sayede de sistemi bildiğimiz yani şeyleri de oraya koymuş olduk diyebilirim. Ve olabildiğince proses yani ister istemez biraz artık diyalogtan çok çünkü şirkette çok hızlı scale olmaya başladığı için bir şeyleri de hani otomasyona ya da belli başlı servis süreçlere yıkmak zorunda kaldık. Bunu biraz beklediğimizden daha hızlı yapmak zorunda kaldık açıkçası çünkü İster istemez hani dediğin gibi saat yani normalde 5 dakikada çözebileceğim bir şey artık işte abi müsait misin Zoom call'u atayım mı ya şuna hemen bakalımcılığa döndüğü zaman bile o 5 dakika insan hayatından 40 dakika çalar hale geldi bizde ve bu gerçekten yönetilmez bir hale geldi ama şu an iyi bir konumdayız ekip olarak. Bir de en büyük tavsiyem açıkçası takvimimizi yöneten tool'lar kullanmaya başladığımızda bayağı fayda görmeye başladık. Yani o kendinizi bir yerden sonra çünkü yani ya, remote çalışmanın benim gördüğüm en kilit noktası fazlasıyla açıklama yapmak. Çünkü yazılı iletişimde bazen niyet de kaybolabiliyor. Ama bunu yaparken de işte kendinize belli sınırlar koymanız gerekiyor. İşte şu kadar vakit en fazla toplantıya harcayacağım. Bu kadar fazla işte Zoom'a gireceğim. Slack'te en fazla şu kadar bulunuyor olacağım diye. Bunları da organizasyon seviyesinde zorlayan ve insanların sizin görünür olmanızı sağlayacak tool'lar kullandığınızda daha efektif olduğunu da gördük diyeyim. Böyle kısa bir özet geçebilirim. Ya da uzun da oldu bilmiyorum. Kusura bakmayın. Ben de böyle.
Yani biriniz girin isterseniz kendinizi de tanıtırsanız güzel olur.
Ben devam edeyim. Ya da Mehmet devam et. Fark etmez abi. Okey. Tamam. Ben şu an ben Emrullah bu arada. Şu an Vengers'da DevOps Engineer olarak çalışıyorum. Bizde aynı şekilde pandeminin başından beri remote çalışıyoruz 2 senedir falan ama yaşadığımız en büyük problem bence takım olarak düşünmekten yani takım olarak bir şeyleri oturtuyorduk. Normalde DevOps takım olarak çok güzel işte çalışma planlarımız var. İşte beraber bir araya gelme şeklimiz vesaire güzeldi. Ama şimdi şirket olarak düşünmeye başlamamız gerekiyor. Yani diğer takımlardaki developerların sana müdahalesi ya da senden isteklerini de senin sürecine girmesi gerekiyor. Yani onların da girebileceği kolay bir süreç yaratmamız gerekiyordu. En büyük yaşadığım problem bir toplantının ortasındayken sana başka bir toplantı isteği atan ya da işte Salih Emre'nin söylediği gibi bir Zoom linkini bir Zoom linkindesin zaten. Diğer bir de Zoom linki atıp 5 dakika bakar mısın abi diye seni böyle darlıyor bir yandan. Ama toplantıda olduğunu fark etmiyor. Ya da takvimine bakmıyor. Bunu yönetmek için ya da işte buna göre bir çözüm bulmak bayağı uğraştırdı diyebilirim. Yer yer çözdük ama hala bence bazı insanların remote çalışmakta zorlandığı kısım bu. İkinci bir olay da yine bu 5 dakika olayları yani işte yüz yüzeyken çok hızlı çözülen olayları için yeni tool'lar ya da yeni bir şeyler bulmak, yeni bir süreç bulmak gerekiyordu. Ona da Discord'u biz genel olarak sunduk ve işte takım olarak çoğu zaman Discord'da hani boş vakitlerimizde Discord'da takılıyor oluyorken işte birinin birine bir soru sorması gerekiyorsa olabildiğince hızlıca erişebiliyor oldu. Bu bayağı güzel çözdü. Ama yani müsaitlik ve takvim olayı bence şu ana kadar yani 2 senede yaşadığım en büyük zorluklardan biri benim de. Öyle diyebilirim şu an için.
O zaman ben devralayım buradan. Selam herkese. Mehmet, ben de Cloud ve DevOps konularında danışmanlık veriyorum ben de bir süredir. Burada Salih Emre'nin ve Emrullah'ın değindiği en önemli konu aslında süreç konuları bence daha çok ortaya çıktı bu remote çalışmaya başladığımızdan ötürü. Çünkü eskiden biraz daha kimin ne yaptığı visible iken şu anda mesela benim gözlemlediğim kadarıyla herkes one on one'da birebir bir şekilde bölünebiliyor. Atıyorum 5-6 kişilik takımdaysan 5-6 takımın hepsi farklı yerlerden bölünebiliyor. Ve bu da day to day işlerden stratejik improvement'lara vakit ayıramamaya yol açıyordu benim gördüğüm. Burada Salih'ten daha önce duyduğum bir yöntem vardı. Biz bir takımda bunu uygulamaya başladık. Mesela her hafta belli bir kişi day to day işleri karşılayan birisi oluyor ve geri kalan da stratejik improvement'lara kendini çok rahat vakit ayırabiliyor. Ayrıca SRE takımı da vardı bu bahsettiğim takımda. O yüzden on-call gibi bir muhabbet olmuyordu. Yani bu tarz süreçlere oturmanın çok değerli olduğunu bence remote çalışma daha ortaya çıkardı diyebilirim. Hani ve bireysel takvimi yönetmek en önemli şey olduğunu düşünüyorum remote çalışırken, rolden bağımsız olarak.
Selamlar, ben de Mustafa. Atlas DevOps'da çalışıyorum. SRE ve platform ekibinde teknik lead olarak çalışıyorum. Bizim işte Ops'unu pandemiden yaklaşık 1,5 sene önce Atlas'a geçti. Şimdi dediğiniz gibi daha önce iç içe çalışırken mecburen yavaş yavaş başka ekiplerle çalışmaya başlamıştık ama pandemiyle iç içe de başka ekip oldu herkes. Bizim orada yapmaya çalıştığımız zaten her takımın kendi on-call'u, kendi şeyi var. Development cycle'ı. Paylaştığı şeyler tabii ki oluyor. Ama bu sorumluluğu onlara yıkmaya hep çalıştık. Yani ekiplere. Biz girip sizin yerinize deploy yapmayacağız vesaire. Ne varsa alert size gelecek. Bu yavaş yavaş oturttuğumuz bir şeydi. Pandemi süreciyle beraber bunun faydasını gördük. Yani çok etkilemedi. Ama yine de iletişim sıkıntıları olmaya başladı. Ofiste 5 dakikada olacak şey şimdi yarım saat 40 dakikada oluyor. Bunun içine bizim bir Hindistan'da bir ekibimiz oldu. Bu kadar kişi de orada var. Sydney ile beraber çalışıyoruz vesaire derken toplantılar yönetilemez hale geliyor. Ama işte bu pandemi başında böyleydi. Bizim yaptığımız en büyük yatırım Atlas'ın 6.000-7.000 kişilik bir şirket. SR ekipleri de bölünmüş durumda artık. Sadece metreye bakan 5 kişi var. Sadece deploy'a bakan 15 kişi var vesaire olunca biz Atlas Tooling'e geçmeye başladık. Ve insanlara soru soracaksınız, onlara sorun. Responsibility'yi yani sınırlarını çizip dağıtmak en önemli şey oldu bizim yaptığımız. Öyle bir faydası oldu diyebilirim ama artık işte 2 sene oldu neredeyse. 1,5 sene oldu. Bence rayına oturdu ama takvim yönetmek hala bir sorun.
Ben çok bir şey söylemeyeceğim. Zaten hepiniz çok güzel noktalara değindiniz. Bu Samet'in bir sorusu var. Onunla devam edelim. Ondan sonra management tarafıyla ilgili bir soru var. Bence gelen sorular eğer ilgiliyse az da olsa o taraftan devam etmemiz daha faydalı olacak gibi duruyor. Çünkü bizim sorularımız biraz daha jenerik zaten. Şöyle bir soru gelmiş. Yeni bir ürün öğrenirken önce doküman okumak mı yoksa hemen POC yapıp ara ara dokümana bakmak mı daha yararlı? Genel olarak bir üründe nasıl uzmanlaşmak gerekiyor? Yani
bu konuda benim çok genel fikirlerim var. Böyle ne derler? Radikal diyebilirim ama.
Yani, tabii paylaşalım.
Tamam. Ya şöyle
Code of Conduct bir şey yapmadığın sürece
yok öyle diyeceğim. Genelde ben çünkü böyle standart düzenin tam tersi birisi olduğum için böyle hani diyelim 2 haftalık sprint var. 2 haftanın işte zamanında yani çalışırken yani 10 günün varsa iş günü benim 6 günü sadece dizayn ve dokümantasyonla uğraşıp 4 gün işi yapmakla falan geçiyordu böyle. Bu genelde standart çalışmanın tersine ben biraz daha böyle waterfall görünen bir adam olabilirim ama dizayna çok kafa yormayı sevdiğim için. Burada büyük ihtimal diğer arkadaşlar biraz daha hands-on seven arkadaşlar. Mehmet'le Murat'la daha önce çalıştığım için. Hani ya açıkçası ben bir de şirket orada aslında en önemli şey öğrendiğin tool'un ne kadar neyi etkilediği de çok değerli olmaya başladı. Onu fark ettim ben. Hani şirkette bulundukça ve Getir'de de bu büyümeyi gördükçe hani etki alanı küçük bir yerdeyse çok özgür bir şekilde aslında takılabiliyorsunuz. Hani bu işte SLO ya da error budget dediğimiz konseptlerde yani orayı patlatmanız ya da orada herhangi bir problem çıkarmanız ya da o sistemi kullanan paydaşlar, stakeholder'lar çok yoksa bence en güzeli gerçekten kafa atıp bir şeyleri bozup parçalayıp böyle yerinde görmek. Çünkü asıl öğrendiğiniz şey uygulayarak oluyor. Bir işin ne kadar paydaşı varsa ya da bir işten kaç kişi ne kadar etkilenecekse o zaman işte bir işi neden yaptığınızı, işte bunu yapmaktaki sebeplerinizi, design prensiplerini falan daha çok satabiliyor ya da açıklayabiliyor olmanız lazım ki herkesin de kendi sürecin içinde bir şey olsun, onayı olsun. Ben burada biraz şeyde değiştiğini fark ettim ben yani hani spesifik bir her şeyde çalışmıyor. Önemli olan ne kadar impact'ı var o tool'un ya da o sürecin. Ona göre farklı, hani ne kadar küçükse o kadar kafa göz girip ne kadar büyükse proje o kadar design üzerinde yorumlamak daha iyi gibi geldi bana diyebilirim yani.
Ben de katılıyorum buna. Çünkü yani internal olsun, external olsun, bu tool, süreç ne olursa olsun doküman yani çoğu detayı atlıyor olacak. Onu nasıl kullandığın çok önemli. Daha önce dediğim gibi Atlassian Tooling'e geçiş yapıyor. İçeride bir pass var yani. Docker imajı alıyor. Tamam, bu kadar bizim bilmemiz gerekiyor. Bir de YAML dosyası var. Deneye deneye öğrenmek bizi çok daha hızlı bir noktaya getirdi. Yapıyorum abi bu alet mesela oradaki tool Atlassian tool'ları yani kendi servisleri yavaş açıldığı için normalde Kubernetes'te bir update yaparken eskisi kapanıyor. Bu kapatmıyor. 5 dakika daha bekletiyor. Bunu yazılan şeyi okuyarak öğrenmek bile böyleymiş demek akılda bile kalmıyor yani. Bu kadar küçük detaylarla. Çünkü her tool'un bir assumption'ı var. Proses var, bir hikayesi var. Ne olduğunu sadece okuyarak öğrenmek çok zor. Bir de o tool'u niye kullanıyoruz? Neyi çözüyor? Biz bir şey değiştiriyorsak öncekiyle farkı neydi de bu tool'a geçiyoruz sorularını cevaplamak çok önemli. Hype driven development hepimizin düştüğü bir şey de oluyor bazen. O amacı öğrenip hızlıca hareket etmek, aksiyon almak her zaman bizim de tercih ettiğimiz bir şey.
Ben belki sıraya alabilirim. Ben genelde denemeyi daha değerli buluyorum önce, ama her tool'un kesinlikle başta bir böyle dokümanını bir skim etmenin çok yararlı olduğunu gördüm önceki tecrübelerime dayanarak. Bazı tool'ların dokümantasyon şekli farklı oluyor mesela. Geçenlerde Cortex diye bir tool var Prometheus için. Onun dokümantasyonunun structure'ını önce bir anlaman gerekiyor ki ve o tool'u seçtiysen zaten neden seçtiğini az çok biliyorsun. O kafandaki planı yaparken dokümanı arkada zaten okumaya başlıyorsun. O yüzden ben dokümanı hafiften göz atıp direkt getting started'ını yapıp kafamdaki planı ilerletiyorum genelde. Ama internal to dokümantasyonlar tabii ki Mustafa'nın dediği gibi eksik olabiliyor genelde. Öyle şeyler olabiliyor. Özellikle.
Benim için de genelde yani ilk başta girerken hands-on Mehmet'in söylediği gibi tool'u seçtiysek zaten belli başlı çerçevesinde ne olduğunu biliyor oluyoruz. O yüzden kurulumu yaptıktan ya da ilk baştaki ilk adımları attıktan sonra herhangi bir sorunla karşılaştıkça ya da trouble etmek gerekiyorsa ya da bir şeyi nasıl daha geliştirmemiz gerekiyorsa, yani bir improvement gerekiyorsa orada, o zaman biraz dokümana bakmaya başlıyoruz. Ama zaten o tool'u seçiyor olmak ya da o tool'u kullanmaya başlıyor olmak bile yine o getting started'ı okumak ya da en azından en başta intro kısımlarını okumayı her türlü gerektiriyor. Ama her ikisini birlikte yönetmek benim için daha rahat gidiyor diyebilirim. Bir yandan farkındayım okumak.
Yani biraz ben de birkaç yorum söyleyeyim. Yani biraz kişinin öğreniş şekliyle de ilgili ama skimming diyorlar ya, hızlı bir şekilde böyle bir ne olduğunu anlayıp hands-on girmek çoğu şeyde çok daha hızlandırıyor diye görüyorum ben de. Özellikle skopu çok büyük bir şeyse yani bunu öğrenmenin imkanı yok oturup okumanın. Mesela çok denk geldi yani microservice yani çok bir şey ama yani diyorlar yani microservice architecture'ına bir şekilde geçmemiz lazım diyor. Ya oturup bunun bir ay kitabını okumanın hiçbir yararı yok sana yani. Oturup 3 tane 5 tane kitap okuyup yani hands-on girmeden önce aylar harcamanın hiçbir yararı yok. Böyle büyük konseptlerde özellikle biraz ufak parçalara bölüp adım adım hakikaten hands-on gitmek en mantıklısı. Ama daha ufak bir ürün kullanıyorsanız tabii ki hızlı bir şekilde dokümantasyon üstünden yarım saatte geçin yani. Onun bir zararı olmaz. Ben de öyle bir kendi tecrübemden, yorumumdan bahsedeyim. Bir tane de şeyle ilgili soru var. Onun bir üstündeydi. Yani bu şöyle güzel bir soru, değişik bir soru. Çünkü gülüyor herkes tabii. Çünkü burada management'a zorlanmış insanlar olabilir. Management'ı yaşı dolayısıyla belki kaymak zorunda hissetmiş insanlar olabilir. Ya bu biraz tercih meselesi de ama her şirket buna da izin vermiyor. Yani belli bir şeye gelince, belli bir tecrübeye gelince doğal olarak herkes soru sormaya başlayınca artık soru cevaplar moduna girip onun adına da manager diyorlar vesaire. Bu da çok oluyor. Yani siz bunu nasıl görüyorsunuz? Yani sizin tecrübeleriniz özellikle bu alanda çok fazla. Sözü size bırakın. Başka diyecek bir şey mi yok? Hadi girdiniz.
Sözü direkt Salih Emre'ye bırakalım.
Ben önce çok kısa bir başlatayım. Yani bu bence çok öznel bir konu. Kişinin kariyer planlarıyla alakalı, ileride ne olmak istediğiyle alakalı bir konu olduğunu düşünüyorum. Ve iki tarafında çok tatlı ve farklı challenge'ları olduğunu düşünüyorum. Ben management yapmadım ama bunu düşünüyorum ve sözü diğer arkadaşlara bırakıyorum.
Tamam, ben gireyim o zaman. Title'ı aldık. Rozeti taktık. Sebebini açıklayalım diye. Ya şöyle ki ya öncelikle değinmek istiyorum. Maalesef Türkiye'de şimdi ya yurt dışında normalde bu iş biraz farklı yürüyor. Çünkü yurt dışında gerçekten individual contributor dediğimiz bireysel katkı sağlayan kişi peti diye bir şey gerçekten var. Ve bir de management pet'i var. Bunlar aslında böyle madalyonun iki ayrı yüzü ve iki level'da da ekspertize ihtiyaç duyuyorsunuz aslında. Türkiye'de de iyi startuplar başladığı için, Türkiye'de de global işler çıkmaya başladığı için onlar yavaş yavaş o işleri yapan şirketlere de sızmaya başladı. Ben açıkçası hani bu süreçte hani o korkulan adımı atıp yapın gençler diyen perspektife bürünmüş olan kişi olarak görünürde. Şundan bahsedebilirim. Yani genelde bizim ülkede tek terfi imkanınız management petinde olduğu için insanlar oraya evrilmek zorunda hissettiriliyor. Bu aslında bizim sektörün organizasyonel bir boşluğu ve sıkıntısı. Herkes yönetici olmak zorunda değil. Herkes insanları inspire etmek ya da hani ne bileyim böyle insanları liderlik yapmak ya da insanları bir yere sürüklemek için sadece çene çalıyor olmak ya da insan yönetiyor olmak zorunda değil. Müthiş insanlar var. Developer'la sadece yazdığı kodla, komüniteye katkısıyla, bulunduğu yerdeki tartışmaya verdiği teknik bilgiyle bile insanları böyle gaza getirip buradan da ilerlenebilir dedirtebiliyor. Öncelikle hani bulunduğunuz yerde bu fırsatların olup olmaması bayağı kritik. Hani buna
Burada
zorunlu
küçük bir firmada zaten imkansız gibi bir şey. Yani
Evet.
orada her şeyi yapıyorsun çok küçükse. Orta ölçekliyse de senin dediğin case mesela oluyor bence. Çok büyükse mesela Getir, Trendyol gibi böyle büyük firmalarda dediğin gibi IC manager peti olabilir yani. Mesela Atlassian'da tam dediğin var yani. Hani IC peti var, manager peti var. Ama çok büyük değilse alternatifin de yok hani Türkiye'de çalışıyorsan.
Evet. O biraz aslında insanlara böyle zorunluluk gibi geliyor. Şimdi klavyeyi bırakacağım ve artık bütçe hesaplıyoruz falan. Ya ben şu perspektifi çok sevdim. Bu konu hakkında bayağı çünkü kafayı da yordum hani bu geçişi yaparken nasıl olur ne eder diye. Öncelikle aslında şu çok önemli, bunu dikkat ediyor olmak. Individual contributor olduğunuzda genelde üstüne koyarak ilerlediğiniz bir yapınız var. Management'ı iyi yapabiliyorsanız eğer bir hani bu servant leadership modelinde olan insanların genelde zaten bence management tarafına gelmesi gerekiyor. Hani böyle dikte modelinde değil de ekibin gitmesi için yolun önündeki engelleri kaldıran ama yolu takımın gittiği bir personanın olması genelde daha doğru oluyor. Hani buna önem veren şirketlerde management petine geçmeye başladığınız ama zaten öyle korkunç o klasik yönetici modelinden farklı bir iş yapıyorsunuz. Bir gene takımla birlikte çalışıyorsunuz. Zaten teknik işi hala anlıyor olmanız gerekiyor ki o insanların önündeki engellerin ne olduğunu gerçek anlamda tespit edin. O yüzden hala teknik kapasitenizin de devam ediyor olması gerekiyor. Bunu da gelişmesi için yönetiyor olmanız gerekiyor açıkçası. Bir de artık nasıl bir şeyin üstüne koyarımdan çok bir şeyleri üstüne koyan insanları nasıl daha katkılı hale getirir, nasıl çarpan olurum perspektifinde bakmanız gerekiyor. Böyle olduğu zaman aslında engineering manager'lıkta da teknikten kopmuş olmuyorsunuz. Çünkü zaten onu anlayamaya devam ediyor olmanız lazım ki bu çarpan olmaya devam edebilin diye özetleyebilirim. Gene çok detaylı konuştuysam kusura bakmayın ama hani tecrübe yaşadığım için son zamanlarda anlatmak istedim.
Ben de ekleyebilirim bu konuda. Yani bizde PET var, işte Serhat'ın dediği gibi. İşte P3 seviyesinden başlıyor Junior Engineer, P8'e kadar sıralamış gidiyor. Şöyle yaparsan promote olursun vesaire. Ama şöyle de bakmak lazım. Ya dışarıdan bir menajer gelmesini mi tercih ederdim? Yoksa ben bu ekibi alıp götürmek istiyorum. İleride başka işler yapmak istiyorum. Yani manager deyince sadece bu bana bunu da şunu da yaptı şeklinde management olmuyor her zaman. Yani ben senin gelişmen için ne yapabilirim? Yani individual contribütörlerin kariyer gelişimini de yönetmek bir management. Onlara proje bulmak, yeni iş yapmak, onları bir konumlandırmak da bir management. Sadece şey değil yani çok şey işi de oluyor, kağıt kürek işi dediğimiz böyle görüyorum yani menajer arkadaşlardan ama o denge tamamen kaybolmuyor. Salih'in dediği gibi yani klavye bırakmıyoruz yani o şey menajer olan arkadaşlarda. Bırakan da oluyor. O tamamen şirketteki dinamiklere bağlı.
Mesela bizde şeydi yani Opsgeni'de eskiden Atlassian öncesinde vesaire hani çok fazla menajer yoktu ama olanların hepsi hands-on deli gibi kod yazan insanlardı ama Atlassian o kadar o scale'de orada birazcık daha hani şey koddan uzaklaşıyorsun mecburiyetten dediğim. Yani oradaki management beklentileri o yönde çünkü. Şirketin management'tan beklentisi, menajerler beklentisi farklıydı. Büyük firmalarda özellikle yani biraz daha hands-on'dan kayma oluyor. Bir soru gelmiş. Burada biraz daha Salih'e gidiyor bu. Çünkü Mustafa da aslında hala üst level individual contributor petinde. Yani neden peki management'a geçmeyi tercih ettin? Çünkü bizde mesela şey de oldu yani bu gayet normal. Management'ı deneyip sonra çok o işten mutlu olmayıp individual contributor olmaya geri dönen arkadaşlar da oldu. Bu bir depromotion yani değil. Bunun bir senin maaşın olsun hiçbir şeyin etkisi yok. Aslında farklı bir pet. Gerçekten farklı bir pet yani.
Şöyle ana sebeplerinden bir tanesi de bu. Bence management tarafını deneyip geri dönmek individual contributor'la tersine göre biraz daha kolay geliyor bana. Hani çünkü gerçek anlamda teknik mükemmelliği kovalayan ve bu işe deep dive yapan birisi olduktan sonra işin o kısmından çıkmak ve o kadar edindiğin yeteneği bırakmak biraz daha zor oluyor. Ya bir de ben zaten ağzı çok laf yapan, konuşan bir insan olduğum için sanırım manager oldum diye özetliyormuşum. Ya şöyle dediğim gibi benim daha çok
güzel bir şey dediğin şey.
Ya benim daha çok şu açıdan oraya kaymayı tercih ettim. Genelde şirketlerin stratejik süreçlerinde bulunmayı seviyorum. Yani insanların bir şey neden yaptığını anlamayı seviyorum ve bunu takımıma açıklayan insan oluyordum genelde çalıştığım ekiplerde de. O yüzden işin stratejisinde olmak, o hani roadmap dediğimiz yol haritası çizilirken üst kattaki insanları etkileyebilmek, onların developerların daha efektif hale gelmesi için ne yapabileceğini anlatabilmek vesaire bunlar üzerine kafa yormayı seçtiğim için yani tekniği de çok sevmeme rağmen biraz daha hani doğal yetenekler de biraz daha buraya yönlendirdi gibi oldu beni. İkincisi de dediğim gibi yani management demek kağıt kalemi bırakmak değil. Öyle olursanız zaten aslında iyi bir manager olmuyorsunuz. Ben hala işte şu an işte kendim POC yapmaya çalışıyorum. Product ekipleriyle birlikteyim. Onun yüzdesi farklı yerlere gidiyor. İşin hani bu işi nasıl yaparımdan çok bu şirketin ya da takımımın bu hedefleri gerçekleştirmesi için stratejik olarak ne yapmamız gerekiyor? Hangi ekiplerle çalışmamız gerekiyor? Yurt dışında globalde bunları yapan insanlarla nasıl iletişime geçebiliriz? Ekibimizdeki insanların kariyerleri o global şirketlere nasıl yaklaşabilir? Bizim burada şirket olarak yapmamız gereken şeyler ne? Ve bunların gerçekten ne kadar anlamı var? Birinin de bakıp anlatabiliyor ve bunun önünü açabiliyor olması gerekiyor. Aslında ben biraz da engineering management'ı bu konsepte gördüğüm için gerçek anlamda iyi engineering management anlamında o gördüğüm için biraz daha denemeyi tercih ettim. Yani genel olarak böyle bireysel söyleyebilirim. Umarım tatmin etmiştir cevap.
Emrullah ekleyeceğim bir şey var mı? Başka bir soruya geçeyim mi?
Yani benim genel olarak söyleyeceğim şey olabilir. Son bir yorum gelmiş. Senior developerlar en az menajerler kadar kıymetli olmalı ya da kıymetli diye. Yani şeye katılıyor olabilirim. İşte bir menajer olma isteği ya da bunu yapabilir miyim, yapamaz mıyım isteği sanırım insanda böyle işte nasıl şu an biz DevOps seçtik, bazı insanlar backend seçiyor. Bunu nasıl keşfederek kendimizde hangisinden zevk aldığımızı keşfederek seçtiğimiz gibi management'ta ben yetkinim ya da işte ben bu işi yapmaktan zevk alıyorum da biraz sanırım zevk işi. Yani bir beceri ve zevk işi. Yani beraber geliyor gibi geliyor. Ben kısaca böyle düşünüyorum diyebilirim.
Teşekkürler. Ya şimdi bir tane sertifikasyon vesaire sorusu var ama bence çok alakasız şu an hani şeyden, PET'ten. O yüzden o tarafa kaymayalım diyorum. Ama hani işin bir de DevOps şu an eminim hani junior seviye ya da mid seviye bir sürü arkadaş izliyordur. Şimdi hepiniz neredeyse artık yıllarca bu işte DevOps tarafında emek harcıyorsunuz. Yani birazcık basit bir soru ama zor bir soru aynı zamanda da. Çok da fazla soruluyor. Özellikle juniorlar çok merak ediyor. Şimdi DevOps tarafına kaymak isteyenler hakikaten o tarafa yani belki backendçi de oluyor ya da junior oluyor. Bir hani hangi petten gitmesini, sizin petiniz nedir, sizin hikayeniz nedir? Çünkü burada tek bir doğru yok. Onu hepimiz biliyoruz. Herkesin hikayesi farklı. Kimisi backend'den geçiyor, kimisi işte sıfır operasyon tarafından başlıyor, kimisi çok bir direkt DevOps'tan giriyor vesaire. Orada sizin petiniz nedir? Bir de bu işin gittiği noktayı nasıl görüyorsunuz? Çünkü görünen hani yurt dışında, yurt içinde en çok aranan pozisyonlardan biri artık cloud bilgisi olan, DevOps bilgisi olan insan. Hani böyle ucu açık bir soru sorayım. Bu da son soru olabilir belki. Uzun sürerse. Hadi bu sefer biriniz girin. Değişik biri girsin hadi. Emrullah gir hadi.
Olur. Yani tam diyecektim. Beni DevOps'a böyle havuza atan insanlardan 2 tanesi burada direkt zaten. Salih Emre ile Mehmet ben Rangers'ta stajyerken beraber çalışıyorduk. Öyle diyebilirim ya da işte neleri ilerletmem gerektiğini yol gösteren sağ olsunlar yardımcı olan insanlardı. Ya bence kendi öğrendiğim petten sonra ya da işte kendim daha sonrasında birine nasıl öğretebilirim petinde şöyle düşünüyorum. İşte başta hep böyle işte klasik söylediğimiz işte DevOps kültürdür ya da işte belli bir anlamamız gereken bir mentaliteye sahip. Bunu zaten kesinlikle kavramak gerekiyor. Yani ne yapıyoruz, neye hizmet ediyoruz veya işte neyi geliştirmeye çalışıyoruz. Bu kesinlikle ilk başta göze alınması gereken bir şey. Bunu geçtikten sonra bu tamamen işte soft kısmı geçtikten sonra teknik anlamda çok fazla yine yönelilebilecek alan var mı? Tek taraflı yönelilebilecek işte bir ürün firmasında o ürünün altyapısına göre işte kısıtlamalarına göre değişiyor durum. İşte cloud'da olması ya da on-prem'de olması bu işi değiştiriyor ya da hangi cloud'da olduğuna göre bile bir pet değişiyor bence. Bundan bağımsız düşünecek olursak işte temelde çok fazla var. İşte otomasyon kısmı var, cloud kısmı var ve işte alt tarafta daha önce DevOps'tan daha önce diyebileceğimiz işte sistem engineer mantığında daha alt bilgileri de her türlü bilmemiz gerekiyor bence. Bunları böyle harmanlayıp sıra sıra öğrenmek ya da hepsine vakit geldikçe ya da önümüze çıktıkça öğrenmek gibi geldi benim petim. Yani böyle önüme ne çıktıysa öğrenmeye çalıştım. Ve sonra artık bir aday bakarken de ya da bizim firmada bir aday bakarken bile düşündüğümüz 5 adım oluyor işte. Infra kısmı, altyapı kısmında ne kadar tecrübeli adaylar ya da orayı nasıl geliştirebiliriz kendi adımıza. Otomasyon kısmı ve işte Kubernetes gibi daha sonrasında çıkan tool'larla management kısmı. Bence bu 2-3 adım şu an gösterilebilecek petlerden başı. Ve saydığım sıralamada bence öğrenmek için de güzel bir sıralama. Öyle diyebilirim kısaca şu an için.
Çok kibarsınız ya.
Ben alabilirim. Çünkü benim de aslında böyle DevOps'a geçmem garip bir süreç oluyor. Ben en başta HTML falan filanla başlıyorum. Onu geçiyorum. Herkesin yaptığı şey zaten. Ama gerçek kariyer planımı düşündüğümde aslında ben iOS developer olmak istiyordum ve ona yönelik çalışıyordum. Sonra iOS yaparken bu iOS uygulamasının bir backend'i olması lazım. Python'la backend yazalım. İşte tamam o zaman bunu Django ile daha güzel yapalım. Frontend'ini yapalım falan derken her şeyi yapıyor buldum kendimi. O sırada da Vengers'ta çalışmak isterken Vengers'ta DevOps ilanı vardı ve öyle başvurup o şekilde DevOps'luğa başlamıştım. Yani o yüzden yeni arkadaşlara en önemli tavsiyenin bence öğrenmek olduğunu düşünüyorum. O yüzden yani tool'lar öğrenilir. Bugün Kubernetes var. Önceden Mesos vardı. Tool'larda bir şey yok. Bence yeniliğe açık olmak ve kendini sürekli geliştiriyor olmak önemli.
Benim şöyle oldu. Ya programlamaya zaten ilgim vardı. Üniversitede network olsun, operating sistem olsun bu dersler bende çok şey oldu. Computer organization, her şey yerine oturuyormuş gibi. O ona bağlı, bu buna bağlı, şu paket şuradan gidiyor. Bu sistem taraflarına hep daha çok ilgi duyuyordum. Normal software engineering olarak başladım ama dediğiniz gibi hep bunu nasıl deploy edeceğiz, bunu nereye kuracağız vesaire diye gelişe o alanda daha mutlu olduğumu fark ettim. Benim de böyle geçti. Zaten şirkette de yani çoğu şirkette şöyle oluyor desem yalan olmaz herhalde. DevOps diğer mühendislerin yapmadığı şeyler olarak başlıyor ve yani yapmak istemediği, dokunmadığı. Jira mı kurulacak? Tamam sen de DevOps'cusun da. Deploy mu yapılacak? Sen tamam DevOps'cusuna kadar. Bir geniş bir skalası var DevOps'un her yerde. Yani bir anlamı da yok. Böyle farklı şeylerle uğraşmak beni mutlu ediyordu yani. Devamlı yeni bir şey öğrenmek ama bu yüzden de şey olmadı mesela. Baştan sona bu projeyi sıfırdan yaptım, backend'ini yaptım, database design yaptım gibi şeylerle beni çok açmıyordu. Ondan öyle gelişti benim hikayemde.
Bir de şey görüyorum ya hakikaten bu DevOps'cu arkadaşlarda bir high level bir şeyleri işte big picture'ı görmek, architect denebilir belki ama o tarz bir istek, o tarz bir yetenek genelde oluyor ve olması da gerekiyor. Yani çünkü çok fazla birbirinden bağımsız şeyler var. O oraya nasıl gidiyor, ediyor onları bilmen gerekiyor. Ufacık bir yerde kalıp ufak bir şeyle uğraşmıyorsun. DevOps hakikaten şey yani büyük bir resim var onu görmen gerekiyor. Salih Emre,
Evet.
sana da sözü bırakalım.
Pardon.
Evet, buyur.
Mehmet bir şey diyordun.
Yok. Bir de yani ben yazılımcıları anlayabilmenin çok önemli olduğunu düşünüyorum. Yani o yüzden software background'lu olur ya da olmaz. Bir şekilde yazılımcıları iyi anlayabilmek gerekiyor bence. Aynı dili konuşabiliyor olmak gerekiyor. Ben sadece cloud'da infra'yı koyarım, bırakırım gibi düşünmemek gerekiyor bence. Pardon. Özür dilerim.
Ya benim zaten çok saçma hikaye ama yani ben bu arada hani computer science background'u da yok. Ben hani bütün bu işlere açıkçası bir stajla başladım ilk şirketimde ve hani yazılım stajıyla başladım. Ondan sonra part-time yazılımcı olarak devam ettim çünkü para kazanmak mantıklı geldi okurken. Böyle arkadaşlarına bir şey ısmarlayabiliyor olmak falan. Ya da kendi bilgisayarını alabiliyor olmak vesaire gibi. O süreçte işte full stack development yapıyordum. PHP, jQuery falan tabii 10-11 sene öncesinden bahsediyoruz. Ama AWS'teydi çalıştığımız şirket. 11 sene önce için bence müthiş vizyonerlikti. Ve şeyi fark ettim yani böyle yazıyorsun kodu işte o zaman JSON falan da yok. İşte SOAP, XML ve falan. Ha böyle öyle bir hayat ki yani ben dedim ben böyle yaşayamam. Yani bana daha adrenalin bir şey lazım. Hani o part-time çalışırken işte CTO'ma söyledim ya ben bunu yapamam. Bu çok sıkıcı geliyor falan diye. O zaman gel bakalım şu altyapı işlerini becerebilecek misin diye bir yönlendirdiler beni AWS tarafında. Gidiş o gidiş yani hani. Oradan sonra da baktım ki adrenalin burada. Ne kadar outage varsa o kadar heyecanlıyız falan. Bütün sistemleri çalıştım patlatmaya başladım falan diyormuş. Ya yok tabii de. Yani ben biraz daha severim bu arada. Saçma bir yere bağlayacağım ama işte FRP ya da işte RPG oynamayı çok severim ve orada hep böyle şeylere çok takıktım. Yani işte class'lar birbirleri nasıl çalışıyor, işte nasıl combo yaparsın vesaire. Böyle hep bir sistem nasıl birbiriyle işliyor ve bunu sen nasıl etkileyebilirsin falan diye. O kontrol mekanizmaları üzerine çalışmaya başladığınız zaman ve o hani işte min-max'çı olduğunuz zaman ki en uyuz oyun oynayan karakter sayılabilirim burada. Oyun oynamaktan çok oyunu böyle nasıl paramparça ederim perspektifine bakan biri olduğum için o perspektif bana biraz işte de yansıdı. Yani işte kodu yazıyorsun, kodu deploy ediyorsun. Ben nasıl en az bu işle uğraşırım? Nasıl en efektif şekilde uğraşırım ki bir daha geri dönüp beni ısırmaz diye bakmaya başladığım zaman aslında önce otomasyonu keşfettim. Otomasyonla birlikte otomasyonun ne kadar fazla yere sıçrayabileceğini gördüm. Özellikle cloud üzerinde olması başladığım ilk şirketin bana altyapıyı da yazılım olarak yönetme fırsatı sağladı ve ben o yüzden aslında o yazılım yeteneklerimi tamamen bu pis işlerden kurtulmaya yönelik çalışmaya harcadım. Sonra buna DevOps deniyormuş falan gibi şeyler oldu. Hani genel olarak aslında benim kariyer hikayem böyle. O hani işte birbirini etkileyen mekanizmaları, o akışı nasıl yönetiriz diye. Çünkü günün sonunda yani mesela hani hepimiz bir aracı kullanmak ya da işte bir şeyi yönetmek için iş yapmıyoruz aslında. Bir değer yaratmak ya da yaratılan bir değerin devamını sağlamak için çalışıyoruz. Title'dan ya da rolden bağımsız. Bu şekilde baktığınız zaman da belli yerlerde belli sorumluluklar gerekiyor. Genelde işte bu hani sistem tarafına bir şeylerin nasıl işlediğine bakan insanlar ve bunu daha çok hani bununla nasıl uğraşırım değil de bundan nasıl kurtulurum perspektifiyle bakan insanlar doğal olarak buraya kaymış oldu benim hani gözlemlediğim kadar kariyer süremde. Yani genel olarak böyle diyebilirim. O yüzden şeye dikkat edebilirler mesela. O çok iyi bir mantık. Yani yaptığınız şeyde hangi aşamalardan geçiyorsunuz? O aşamalarında ne kadar efor harcıyorsunuz? Bunu nasıl çözebilirsiniz? Sorularını sormaya başladığınızda hem size bu büyük resmi gösteriyor oluyor. Hem de asıl o zaman anlıyorsunuz. Yani buradaki efficiency'nin önemi ne? Buradaki işte otomasyonun önemi ne? Hani o fundamental soruları kendi kendinize refleks gibi sormaya başladığınızda omurilikten o sizi çok iyi geliştiriyor diyebilirim. Ve diğer arkadaşların eklediği her şey.
Bunlar da çok uğraşmak istemiyorsanız emotional roller coaster'sa frontend'e falan da kayabilirsiniz. Emotional roller coaster zaten DevOps frontend, yani ikisinde de sürekli hani şey değişiyor, bir sürü şey. Gerçekten oturmuş setup best practices muhabbeti backend'de birazcık daha fazla. Yani genel olarak. Hakikaten zor işler yani, DevOps hands-on yaptığın zaman frontend de öyle. Zor işler. Çok teşekkürler. Yani 45 dakikayı bulduk yine. Hızlı geçti zaman. 40 dakika geçmiş, 45 dakika olmamış ama hani yavaştan artık konferansı da kapatalım. Çok da fazla şeyimiz de kalmadı. Ne derler, söyleyecek bir şeyimiz de kalmadı. Katılan herkese çok teşekkür ediyoruz. Bütün konuşmacılarımıza çok teşekkür ediyoruz. Bu sene gerçekten o konuda hani çok içimizde rahat, her bir konuşma birbirinden güzel oldu. Eğer kaçırdıysanız bir geri dönüp YouTube'dan bakın derim. Discord'da bütün konuşmacılarımız sorulara cevap verdi. Orada bulunan arkadaşlara çok teşekkürler. Hani hala sorunuz varsa bence bakıyorlar. Oradan soru sorabilirsiniz. Onun dışında hani başta Derya olmak üzere bütün ekibin zaten hani bu sene aslında aktif olan Emrullah, Salih, Emre ve Mehmet. Bütün ekibe de çok teşekkürler.
Bu arada
yok. Teşekkürler.
ben küçük bir şey ekleyeceğim. Bu ekibin yaptığı işleri seviyorsunuz ya da bu etkinliği sevdiyseniz bizim parçamız olmanız için herhangi bir lisans ücretine veya herhangi bir şeye gerek yok. Tek yapmanız gereken aslında o formu doldurup kendinizden kısaca bahsetmek ve sadece bizimle birlikte bir şeyler yapmaya çalışmak. Komünite adına uğraşıyor olmak çok keyifli bir şey. Çünkü böyle bir sürü güzel insanı tanımanıza fırsat veriyor. Özellikle de bu pandemi gibi insanların birbirinden uzaklaştığı bu alanlarda da bu tarz komüniteler içerisinde çalışıyor olmak, işte bu burada gördüğünüz bir sürü insanla 10-15 dakika bile, benden bahsetmiyorum burada, konuşmacı insanlarla 10-15 dakika bile bir sohbet edebilmek bile belki 3-5 senede edinemeyeceğiniz tecrübeyi kazandırıyor size. O yüzden dediğim gibi hiçbir ücreti, lisans ücreti bir şey yok. Biz gelenlerden bir porsiyon baklava ısmarlaması falan beklemiyoruz. İstediğiniz gibi yani istediğiniz gibi katılıp başlayabilirsiniz. Hepimiz öyle başladık bu arada sadece. Evet. Burada güzel işler yapılıyor görünüyor. Ben nasıl yardımcı olabilirim diye. Yapmanız gereken tek şey merhaba demek.
Bir işin ucundan tutmaya gönüllü olmanız yeterli. Burada yani farkındaysanız sponsorların altında bile bir işte firma ismi şu an yok. Burada işte yani Getirinden Ventures'ına, freelance çalışanından Atlasya'na, işte Chloe'sından bilmem nesine, yani ekip işte Trendyol'undan böyle o kadar fazla değişik firmada çalışan insanlar var ki yarın öbür gün hakikaten kariyer basamağında bu insanlarla bir yerlerde karşılaşıyorsunuz. O anlamda da bu tarz işlerin içinde olmak çok değerli. Form var. Hani bakıyor olacağız önümüzdeki birkaç hafta. Hani süreçte iletişime geçeceğiz, herkese de bekliyoruz.
Kendinize iyi bakın. Bu cumartesinizi ayırdığınız için teşekkürler herkese.
Herkese sağlık.
Görüşmek üzere. End broadcast.